Right. So Akida, in this question, we have to measure the volume. Now, anytime you measure in volume, you have to measure volume at the bottom of the what?
The bottom of the line.
The bottom of the meniscus, as the proper terminology. And so that would be 7.5
Yeah, that thing.
because it's between 7 and 8. So the answer for the first question is 7.5. We okay with that?
Yes, sir.
Yeah.
All right. Part 2.
Yes, sir.
Question 2. In an experiment to locate the center of gravity of a sheet of cardboard, a plumb line string with a small mass on the end is used. So for those who don't know what a plumb line is just basically a piece of string with a mass on the bottom. So let me ask you a question, right? If I have a string and I put mass at the bottom, what's going to happen to it? Somebody tell me. If I have a mass and I attach it to a string, what direction is the string going to point to?
Downwards.
It's going to point downwards, right? So my answer is part D, because when you have a plumb line, which is a string with a mass attached, it would experience a force pulling it downwards. So it would be pointing vertically downwards. So the answer for 2 is D. So the plumb line, all that just give you a vertical line. That's it. Everybody okay with 2D? Yeah?
Yes, sir. Yes,
You
sir.
would? Okay, let me hear what I answer for this one. Let me hear what I answer. What do you think the answer is?
D.
I hear in some answers. C?
D.
C, I would agree. Why is B wrong? Why you can't say B is the answer? B is the formula.
That's velocity.
Right, and velocity and speed, we just usually use it interchangeably, but you should realize that velocity is the vector for speed. Yeah, so they are different in physics. Cool, I trust that everybody okay with this. Let's move on to question 4. So Kida, give this question a read.
Me?
Yeah, you give it a read.
Right. 3 immiscible liquids, P, Q, and R, have densities which differ. Q is denser than P, but less dense than R. Which of the following diagrams show how the liquids settle in the measuring cylinder?
So according to the information you just read, which one is the densest?
The densest, hold on, let me read this over. R is the densest.
R is the densest, right? Now, if something is dense, do you think it will float or it will sink?
It will sink.
It will sink, right? So R, being the densest, has to be to the bottom. What's the second densest?
Q is the second densest.
Right, because they said Q is denser than P. So Q would be right above R, and P is going to be at the top because P is the least dense. Make sense?
Yep.
All right. Okay. A lot of people unmuted for some weird reason. That's weird. Let me just change the permissions here. Give me a second. So what's the answer?
The answer is A.
The answer is A, right? Just change something. All right. Yeah, let's continue. So A is the answer, right? Does anybody have a problem with question 4? You don't understand it? Guys, don't be scared to talk. I'm here to ask questions. Well, answer questions. So I take it everybody okay with question 4. Let's move on. Question 5. When two bodies collide, momentum is conserved. This means that total momentum of the bodies before is equal to after. That's what it means. Because it doesn't conserve mean that before and after is the same. That's what conserve means, right? If you conserve something, it remains the same. So 5D. Question 6. Errors due to parallax can be minimized by, somebody tell me.
B.
I hear in
E. B.
B. It's in B, right?
Yes, sir.
B is correct. Imagine we have taken a measurement here. Would we take the reading like this? Like from here and here? Would we do that? No, we wouldn't do that. To avoid parallax error, you have to look at the bottom of the meniscus directly at it. And so why do they say 90 degrees? If this is a fluid, you can think of it like this. It forms 90 degrees. You can look at it like that. These would not be 90 degrees. And so to avoid parallax error, you take the measurement at right angles. So that's 6B. Question 7. Which of the following statements are true about the spring above? So first things first, guys, is the elastic limit of the spring being exceeded in this graph? Yes or no?
Yes, sir.
Yes,
Yeah.
sir.
So any option that's saying Hooke's law was constant throughout, wrong. And that's part two. Part two saying that the spring obeyed Hooke's law over its entire extension. But everybody could see that it only obeyed Hooke's law from 0 to 75. After that, it didn't obey Hooke's law. So part two is wrong. Part one, does part one make sense? The elastic limit of the spring was exceeded. Can we see that?
Yes, sir.
Right? And I need to do part three real quick. So if we want to figure out the force per unit extension, we are going to take the force and divide it by the extension. So they have a point for us already, and the point that they gave us was 75,10. So when we apply a force of 75 newtons, we get an extension of 10 centimeters. So if I wanted to figure out the force per unit extension, that's where I would be 75 all over 10. Is there anybody that's not understanding what I'm saying? Is there anybody that doesn't understand why I'm saying 75 over 10? It's force per unit. So the force over the extension. So the force over the extension. Remember, on the y-axis, we have extension, and on the x-axis, we have force. So if I want to figure out the force per unit extension, that is going to be my force divided by the extension. And what would this give me? What is 75 divided by 10?
7.5.
Right? So my answer is 1 and 3. So 7B. Cool. I'm going to move on. The moment of a force is defined as, what is the moment of a force? Somebody tell me the answer.
The product of a force times its perpendicular distance
Right.
about a pivot.
Exactly. That's exactly it. So this is what a moment is. Just going to draw a pivot here real quick. Then we just say we have a force acting down here. If I wanted to figure out the turning force, I would need to multiply the distance from the pivot by the force, the perpendicular distance from the pivot by the force. And so to generate a moment, the turning force, it's the force by the perpendicular distance. So 8D. Is everybody okay with that? Let me know. Okay, I take it that everybody okay with that. 8D.
Yes, sir.
Question 9. Let me see how bad all is, or I could figure out what the answer is without reading the question. I mean, without doing the full working. Could anybody guess the answer without doing the full working? Let me check the comment section.
Yeah, it's C.
It's C, right? Let me ask a question. So, let me read the question first. So, we have a glass marble X, and it's moving with a speed of 6 meters per second. Now, it collides with an identical stationary glass marble Y. So, X was moving at the start, Y was stationary. But after the collision, X is now brought to rest and Y is moving. So if that's the case, and all of the momentum was transferred to Y, because X is now stationary, right? That makes sense?
Yes, sir.
Right. And so if all the momentum was transferred to Y, So would the speed, right? Because momentum is mass by velocity. So the answer is C. But in case you change up the question, I want to show you how you would work it out. So remember that momentum before is equal to momentum after. So before you would have had a glass marble X, this is X. You'd have had a glass marble Y. Right, and after is the same story. Initially, X was moving with a speed of 6 meters per second. Now, guys, are these marbles different from each other or are they identical?
Identical.
So they'll have the same masses, right? So I'm just gonna label the mass M for all of them. Now, initially, X was moving at 6 meters per second. Y was moving at 0 meters per second because it was stationary. After the collision, X is now stationary. And we want to figure out the speed of Y. So we'll be trying to figure out the velocity of that. So V, we don't know what that is. Remember, momentum is mass times velocity. So if I'm looking at the momentum before, somebody tell me, what is it going to be? What will be the momentum for X before? So it's mass by velocity. Mass by velocity. So somebody tell me.
They gave us the mass.
Say that again.
They gave us the mass.
It doesn't matter. You'll see why. Because the mass is the same throughout. It doesn't matter. It'll cancel off. So work with M and work in terms of M for now. So it's going to be M by. So for this marble, it's going to be M by.
M by 6 meters per second.
Meters per second.
Correct. And then that's going to be M by 0.
M.
And after the collision, it's now going to be, so marble X is stationary, so that's going to be M by 0 plus M by V, because we don't know what the velocity for Y is. I'm trying to find that. So is everybody okay with what I have so far?
Yes, sir.
Okay, so on the left-hand side, anything by 0 is just 0, right? So the only thing we're going to remain with is M by 6, which is 6M. On the right-hand side, you have M by 0, which is just 0. And you're going to end up with M by V. So what do I really want to find for? Any question, what do I really want to find for? I want to find for what?
The speed of Y.
I want to find the velocity of marble Y, right? So I need to find for V. If I wanted to find for V, what would I have to do on both sides? Cancel off M.
The hell?
Somebody say, what the hell? Somebody very startled over. Yeah, so if I want to find for V, how would I do that? Right now I have M being multiplied by V. So what's the opposite? What would I have to do? What's the opposite of multiplying by M?
You transpose.
Divide.
Divide, right? I would divide both sides by M. And by dividing both sides by M, the M's would cancel off on either side because the masses are identical. And we're going to get V is equal to
6.
6. So that's the long working. So anytime you have a momentum question, this is how you do it. You draw a little diagram, you see the momentum before, you put it equal to the momentum after, and you find for the unknown. That's it. Is anybody very confused about this question? Can I hear anybody? So I'm going to move on to question 10. Let's move on to question
I'm
10.
good, sir.
Say that again?
I'm good, sir.
Okay, good. Question 10. An object with a mass of 45 grams is lowered into a measuring cylinder containing 45 centimeters cube of water. When the object comes to rest at the bottom of the cylinder, the volume reading of the measuring cylinder rises to 75 centimeters cube. What is the density of the object? So somebody tell me fast, what's the formula for density?
Mass over volume.
Do we have the mass already? Do we have the mass of the
Yes.
object?
Yes, sir.
The mass of the object is 45, but we need to figure out the volume of the object. Now, if I want to figure out the volume of the object, I'm going to subtract the original volume from the volume with the object in the fluid. That makes sense?
Yes, sir.
Yes, sir.
Because all objects would take up space. So they would have a volume. And by me adding that object into the water, my volume is now going to increase. So if I want to figure out how much it increased by to figure out the mass, the volume of the object, I'll just subtract 45 from 75. So the volume is going to be 75 minus 45. And so that's going to be 30 centimeter cube. So 45 divided by 30 is
1.5.
right? And the units is going to be grams per centimeter cube. Yeah. Guys, notice I didn't convert anything to the SI units. And typically in physics, you just do that. But look at all the options. All the options was in terms of grams and centimeter cube. So I needed to keep it in terms of grams and centimeter cube. So the answer for 10 is A. Cool. I'm going to move on. Question 11. Power can be defined as, remember, power, the formula for power is energy over time. And energy just simply means what? What does energy mean? What is the definition for energy?
Ability to do work.
The ability to do work.
Yes, the ability to do work. So energy just means work done, right? That's all energy means. So my answer is going to be work done over time because work done means energy. So 11D. Trust that everybody's okay with that. Cool. Let's proceed. So this was a nice question. Somebody that don't understand these kind of questions at all, I will let to unmute and we will do it together. Who here don't understand these questions for nothing?
I think me, I think it's me.
Okay, well, let me run through it, right? So anytime you have a bunch of composite forces, what I mean by that? We're talking about plenty forces, a bunch of different forces. What I would advise is, I would advise to simplify it first. So we're going to look at the vertical forces and the horizontal forces independent of each other. So Akira, what are the vertical forces in this question?
Right. Is 3 and 15? Is
No,
a very
that's
wild guess.
3 and 15 are
Like
the horizontal. Yes.
Horizontal. So it's
Yeah.
2 and 7.
2 and 7, right? So let me ask you a question. If you have a force going 2 up and then 7 down, waiting the resultant force could be?
5.
5 in what direction?
Honestly.
Where's
Repeat the question.
Where's most of the force acting? Upwards or downwards?
Downwards.
Right. So because these two are opposite, you will take away 2 from 7 and you will remain with a force of 5 newtons acting downwards, right? That makes sense?
Yeah.
Yeah.
I don't know if it's a problem on my end, but the screen just turned blank.
Okay, should see it in one. Okay, less than 1 minute. Cool. So you understand what I'm saying, that this will be 5 newtons. Makes sense?
Yeah.
Right. It's the same concept over here. Where is the force acting more dominantly?
Towards the right.
So this force would take away from this force and you remain with what?
12
newtons. And anytime you have two forces acting in different directions, to find the resultant, you have to find the diagonal. Make sense?
The what?
The diagonal. I'm just going to show you what's
right.
This is a diagonal. If I have this rectangle, the diagonal is this. Yeah, that's the diagonal. Understand? Now, what's the slant line? So watch. To find the diagonal, I'm going to make a rectangle here. So you see this force at 12 newtons? I'm going to replicate it in the bottom. And that 5 newtons to the left, I'm going to replicate it over here. We have a rectangle now, right? Cool. And the resultant will be given by this over here. This is the resultant. This is the resultant. Now, I want to ask you a question. What kind of shape did I form in doing that? What kind of shape did I form?
A triangle.
What kind of triangle? Not
That
just any
is
triangle.
scalene or isosceles. I feel scalene.
A right angle triangle. That's what I'm looking for.
Oh, yeah.
Right angle. Could you make a guess what the length for this side is going to be? Since it's a force that's acting 5 newtons downwards, what is the length here going to be?
5?
It's going to be 5, right? And what do you
Okay.
think this length is going to be?
12.
It's going to be 12. And we recognize that we have a right angle triangle. Anytime you have two lengths for a right angle triangle, you could do what to find for the third side? So that's what P.
Pythagoras theorem.
Pythagoras theorem, right? You could apply Pythagoras theorem. Pythagoras theorem says that the hypotenuse squared is equal to the sum of the other two sides squared. So this is the hypotenuse. The hypotenuse is always the longest length in a triangle. For anybody that's majorly confused, this is the triangle we are looking at. Everybody can see that this is the longest length in a triangle. So this is the hypotenuse. Hypotenuse is always the slant length. And so we're going to apply Pythagoras theorem here. So we're going to call this R because that's the resultant. And so R squared would be equal to 5 squared plus what? What's Akida? 5 squared plus
1 squared.
12 squared, right? What is 5 squared?
25.
Right, and 12 squared is 144.
44.
Right, so where's 25 plus 144? Quick maths.
25 plus 169.
You're bad. And so that's R squared, right? But I have to find for R. So what's the opposite of square and something?
Square root.
Right, so I would find the square root on both sides. Which is square root of 169?
Hold on, that's it.
Right.
13.
13, right?
13.
Yeah, so what's the answer?
13 newtons.
Right? B. So anytime you have forces
Right.
acting in different directions, yeah, most of the times at this level, because you don't know how to find vertical, you don't know how to like find vertical and horizontal components. It's not that complicated at this level. Well, they do physics in unit 1 and thing, or they go see some horrors. But at this level,
Number.
anytime you have forces in different directions, typically the forces will be at 90 degrees from each other. So you could always use Pythagoras theorem. Always. Right? At this level, always. So is everybody okay with this question? Let me know.
Yes, sir. Thank
Yes,
you.
sir.
Okay, nice. So let's move on. Kishava, you go with this question? Question 12? I need to tell me I was bad at maths.
Yes, sir.
Okay, word. Let's check out item 13. Right, so give question 13 a read.
The pressure due to the water is greater at.
So what do you think the answer is?
Q.
The answer is Q.
Yeah.
When we're talking about pressure as a result of a fluid, the formula is pressure is equal to height by density by gravity. Because I'm multiplying, if I use a bigger value for height, obviously my pressure is going to increase, right? And so what do I mean by height? By height, I'm talking about the distance from the top of the fluid to the point we are considering. So guys, where is the height the greatest? Enter Q? Everybody seen that, right? The height at Q is the
Yes,
greatest.
sir.
Cool. So in any question, what they're asking you for pressure due to a fluid, you're looking for the height, right? You're looking at the height. Just take a mental snapshot of that. Question 14. A student sets up a simple pendulum and finds that the period is 1.7 seconds. To obtain a period nearer to 1 second, he should. So guys, what does he want to do? Does he want to increase the period or does he want to decrease the period? Increase or decrease?
Decrease.
So what would I have to do with the pendulum if I want to decrease the time it's going to take to swing from left to right and back to the center?
Shorten the string.
Shorten the pendulum.
Right, I would have to shorten the pendulum. So my answer is C. If I wanted to increase the time period, I would lengthen the pendulum. I have some beautiful diagrams in the YouTube solutions. Right? So you can check that out. I'll just make a little note about it here, right? Longer pendulums equal longer because they could change up the question. Who knows? And they could bring it the other way. And everybody could be quick to put shorts on the pendulum. But you don't be, guys, read all the questions, eh? Read all the questions. Shorten. Okay, cool. Question 15. We have 6 microcoulombs here. What does micro mean? Micro is 10 to what power?
6, positive 6.
Nah,
Minus 6.
micro. Does micro sound
Minus 6.
small? Micro sounds small, right? So anytime we're talking about small, it's negative. So that would be 10 to the power minus 6. So which is my answer? A, B, C, or D?
A.
Cool. Question 16. An ice cube sinks in liquid A but floats in liquid B. Which of the following statements is true? So let me give a little scenario here. Where would you float? Would you float in a freshwater pool or in a very salty ocean? Where would you float?
Salty.
Salty. And the reason for that is because it's more dense there. Anytime you have a denser medium, it's gonna give you a stronger or a greater upthrust. So the buoyant force is gonna be more. So if the ice is sinking in liquid A, that means it has a weak upthrust. But if it's floating in liquid B, that means it has a stronger upthrust in liquid B. So which option corresponds to the logic I just now said?
A.
A, right? Because in A, they are saying that the upthrust in liquid A is less than in liquid B. That's what they're saying. So anytime something's sinking in a medium, that typically means the upthrust is less. So does everybody understand question 16?
Yes, sir.
Right? Question 17. What kind of curve is this? If we decrease any temperature, is this a heating curve or a cooling curve?
Cooling.
It's a cooling curve. So the graph shows the solidification started at Q. So if it begins to solidify at Q, what would it have been at P to Q? If it started to solidify at Q, right? What was it before?
A liquid.
That makes sense, right? That makes sense.
Yep.
It was a liquid. So where's my answer? Where was it a liquid?
D.
At P.
Not P. Not
It'll,
P.
it'll be
D,
between P and Q.
Between P and Q.
Yeah, between P and Q. Because at P, it was a liquid. It's still a liquid. It's still a liquid. It's still a liquid until it reaches a temperature and it begins to solidify. I have a question, guys. What kind of energy does this represent? Latent heat of what?
No.
Fusion, yeah? Fusion. Fusion,
Yeah,
because
fusion.
we're going from liquid to solid. So that's fusion. We're fusing. Yeah. Cool. So is everybody okay with question 17?
Yes, sir.
All right. Good. Question 18. The heat capacity of a substance is defined as the amount of heat energy you would need to raise the temperature by 1 degree or 1 Kelvin. So the answer is 18D. If the answer was specific heat capacity, how would the answer change? Somebody tell me. If it was specific heat capacity,
The heat energy needed to raise the temperature of 1 kilogram of a substance by 1 Kelvin.
yes, that's it. So anytime you see the word specific, just know your definition must include mass in it. If you do not see specific, then you can leave out mass from your definition. Question 19. As the temperature of a liquid decreases, what happens?
B.
B, right? When you decrease the temperature of something, you're removing thermal energy from the system. And if you're removing thermal energy, the kinetic energy is going to decrease. And so the atoms are going to start to vibrate less. So 19B. Question 20. Which of the following play a role with respect to the greenhouse effect? So when we talk about the greenhouse effect, we're talking about heat, the storage of heat. So which wave or which ray here stores heat or carries heat?
E.
Wait, I was doing something here. Tama?
E.
C, right? C. Sound waves don't make any sense. Water waves, what have to do with the greenhouse effect? Gamma rays, nah. Infrared. Infrared is the type of ray that has most of the thermal energy. You all would have probably heard about like infrared thermometers, right? So infrared rays carry thermal energy. And the greenhouse effect deals with the heating up of a closed atmosphere that's typically made out of glass. So we're talking about heat. How do we see? 21. A student wants to conduct an experiment to determine the specific heat capacity, C, of a solid using the electrical method. Which of the following equations should be used? So by now, you should know the answer, right? But I'll still do it anyways. But tell me the answer. What's the answer, guys?
A.
It's A, right? Do you know why the answer is A? Yes or no?
Yes, sir.
Okay, tell me the first formula I'm going to use. What's the formula I use when I'm dealing with specific heat capacity?
MC delta T.
Right. So if I wanted to make C the subject of the formula, I would have to divide both sides by what?
M delta T.
M delta theta, right? Why am I doing this? I would divide both sides by M delta theta so that the M and the M would cancel off and the delta thetas would cancel off. So C is equal to E all over M delta theta. And so now we had to remember that, well, N power is equal to energy over time. Yes or no?
Yes, sir.
And if I make energy the subject here, wouldn't I have to multiply both sides by T? And so energy would be equal to power by time. Now, since we're dealing with the electrical method, when we're dealing with electrical properties, you find power by multiplying the current by the what?
Voltage, potential difference.
Correct. And so look at what happens, right? Let's make a full circle. So we use the formula for power to get what energy is equal to, and we use the formula for power, IV, to figure out that E could be written as I by V by T. So I'm going to run through that one more time. So we had to use the formula E is equal to MC delta theta to find what C would be equal to. I then use the formula power is equal to energy over time to find what energy will be equal to. So energy is equal to power by time. But if we're dealing with electrical properties, to find energy is going to be the current by the voltage. And so I replaced power with I by V. And so if I know E is equal to IVT, I can make the final substitution. So E is IV by T, okay? And in the denominator is going to be M delta theta. So that's how you get your answer, 21E. I trust that everybody okay with that. All right, let's move on.
Yes, sir.
22. A gas occupies 2 meter cube at 27 degrees Celsius at a pressure of 1 atmosphere. At a pressure of 2 atmospheres, it occupies a volume of 1 meter cube. What is its temperature at this new volume and pressure? So guys, what we had to use here, do we have to use the combined gas law, Boyle's law, pressure law, Charles' law? What we have to use?
Combined.
You have to use the combined, right? The reason why we're going to use the combined gas law is because they are giving us volume. They're giving us volume. They are giving us temperature in degrees Celsius. You got to convert that to Kelvin. And they're giving us pressure, right? So what's the combined gas law?
P1 V1 divided by T1 is equal to P2 V2 divided by T2.
Yeah, that's it. And so before we move on, let's just convert that temperature to Kelvin. How do I convert temperatures to Kelvin?
Add 273.
Right. So 27 degrees Celsius would be equal to 27 plus 273. And that should be equal to 300. And that'll be 300 Kelvin. So guys, anytime you're dealing with a gas law question, you need to convert the temperature in terms of Kelvin. And to do that, you just add 273. So I'm going to put in all my information here. So my initial pressure was 1 atmosphere, so that's 1. My initial volume was 2 meter cubes, so that's 2. My initial temperature was 300 Kelvin. My wait, everybody, if you're joining the meeting, please mute yourself if you're not talking. Right. Did they give us the secondary pressure, like the final pressure? Yes or no? Somebody tell me, did they give us the final pressure?
No, sir.
Yeah. If you read the second part, what do they say?
At a pressure of 2 atmospheres, it occupies a volume of 1 meter.
Right. So that would correspond to the final readings. So my second pressure, let me just highlight it so nobody gets confused. Right. Okay, so my final pressure is 2 atmospheres, so that's 2. My final volume is unknown. And I'm going to divide that by the second waiter. I do know what my second volume is. My second volume is 1, right? It's the second temperature I don't know for. All right, so let's simplify it. 1 by 2 is 2, so 2 over 300. And that's going to be equal to 2 by 1 is 2, all over T2. So we're going to cross multiply here. So if I cross multiply, I'm going to end up with 2T2 is equal to 2 by 300, which is 600. So to find for T2, I will divide both sides by 2. And so T2 is going to be equal to 300 Kelvin. But I would need to convert that back to degrees Celsius. So somebody, guys, this is an interesting question, right? Because we got back the same temperature. So if we got back 300 Kelvin, how much is that in degrees Celsius? We should know already.
27 degrees.
27 degrees Celsius. So yeah. Are you all okay with this question?
Sir, could you go over it one more time?
Okay, I'll wait to stay unmuted, right? So in the question, can you see that they're varying the volume, pressure, and the temperature?
Yes, sir.
Okay, so anytime they vary in all three, you have to use the combined gas law, which is P1 V1 over T1 is equal to P2 V2 over T2. And you also know, when you're dealing with these gas law questions, you always have to convert degrees Celsius to Kelvin. You know that, right?
Yes, sir.
Okay, so when you read the question, they're saying a gas occupies 2 meters cubed at 27 degrees Celsius. So this is the initial volume, V1, and this is the initial temperature, T1. Yeah. And they're also saying it's has a pressure of 1 atmosphere So that's P1. So you understand how I get P1, V1, and T1.
Yes, sir.
And then they're saying at a pressure of 2 atmospheres, it occupies a volume of 1 meter cube. What is it? What is its new temperature? So new temperature. So it's underlying temperature. So the new pressure is 2 atmospheres. The new volume is 1 meter cube, and we have to find the new temperature. So you understand that we have P2 and V2. So T2 is the only unknown.
Yes, sir.
So like you're okay up to this point.
Yes, sir.
Right. So anytime you have two fractions, you'd cross multiply. So I'm going to multiply the 2 by the T2. So that's going to be 2T2. And 300 by 2 is?
600.
Right. So we end up with 2T2 is equal to 600. So if I want to find for T2, I would divide both sides by 2 to find for 1 T2. And 2 into 600 is 300 Kelvin. And so that's my final temperature, my new temperature. Now, all the options are in degrees Celsius, but you should know that 300 Kelvin is 27 degrees Celsius because that was the original temperature. Yes or no?
Yes, sir.
And do you know how you would convert from Kelvin to Celsius?
Yes, sir. Subtract 273.
Perfect. So it sounded like you're not getting it. Nice. So I'm going to move on, right? So the answer for 22 was 27 degrees Celsius. There was no change in temperature. So in item 23, this refers to the following diagram, which shows water boiling at the top of a glass tube while a piece of ice remains unmelted at the bottom. Why is this happening? Let me hear, guys. Why is this happening? Why is the water at the top? Summer?
Water is a poor conductor because it has such a high heat capacity. It takes long to boil.
Okay.
Completely.
You're bad, you're bad. So I'm proud of you for being able to see the linkage between specific heat capacity and conductivity. If something has a high specific heat capacity, it would take a large amount of energy to raise the temperature. So you know that, right? So you'd require a very large amount of energy to raise the temperature of the water. And so at this point of contact, it's going to get really hot. But since water is a poor conductor, the heat is not really going to reach here unless you supply real energy. The answer is water is a poor conductor of heat. 23E. I'd like to bring this question. Question 24. Which of the following is not an example of evaporation? Somebody tell me. This is real easy. This one real easy.
A.
A, right? What had to do with evaporation? Right. 25. Which of the following are reasons why a hot liquid placed in a double-walled vacuum flask retains its heat for a long time? So guys, what do you think is the purpose of a double-walled vacuum flask? To decrease the temperature, increase the temperature, or keep the temperature constant?
Keep the temperature constant.
So why would we want to absorb heat from the surroundings? This does not happen. So that's the outlier. That's wrong.
Yeah, that wouldn't make sense.
That wouldn't make any sense. Because when we're talking about a double-walled vacuum flask, we're saying that we want to keep the temperature constant. We don't want to increase it. We don't want to decrease it. Nothing. So it should just keep the temperature constant. So 2 is wrong. What about 1? Does 1 make sense?
Yes, sir.
Yes, that makes sense. Right? And part 3. Does part 3 make sense?
Yes, it does.
Yeah, because would heat be able to pass through air? Is air a good conductor of heat? So like what has happened is in these flasks, you just have like, so this will be the metal outer surface and this will be the metal inner surface. And so you would have like air in the middle. And the reason for that is so the heat, so whatever heat you lose from this portion, it has to pass through air. And air wouldn't do a good job of conducting heat. So most of the heat will be trapped.
Oh,
So
okay.
that's why part 3 makes sense. Because you understand, heat would be radiated here. Now, if it was just bare bones, the heat would have been lost to the environment, right? But
Yes.
because it has another wall, the heat would have to travel in the air between the spaces, and air is not good. Air is not a very good conductor of heat. So most of the heat is just going to be re-radiated back to the inner surface, and so that's going to get hot. So 1 and 3 make sense. So my answer is B. So we okay with that?
Yes, sir.
Okay, nice. 26. A detector of thermal energy is placed on equal distance in turn from each of 4 vertical faces of a hollow metal cube full of hot water. The reading on the detector is greatest when the detector is turned towards the face which is. So let me explain what the question is saying, right? So we have a cube here. And everybody understand that a cube has 4 faces in that sense. I mean, we know it has 6 faces, right? But on either end, it have 4 faces, minusing the face at the top and the bottom. And so essentially, it comes like you have a square cup, and in that cup, you put in hot water. And each of the sides have different properties. So one might be painted shiny white, one might be painted dull black, one might be painted highly polished, etc., etc. And we're taking a detector and we're putting it directly in front of the faces. So my question is, where would the detector pick up the greatest reading?
Would it be B?
B. Black surfaces are excellent absorbers of heat as well as emitters of heat because they absorb so much heat. 26B. 27. The energy required to change the state of a substance was determined to be EH. So we're talking about latent heat there. If the mass of the substance is doubled, the value of EH will? What do you all think?
C.
Is that B, quadrupled?
C.
C. Yeah, C is the answer. Let me show you why. So, Leah, give me an example of a formula for latent heat. I have 2 formulas. Either one will work. It don't matter.
E is equal to mlv.
Okay. All right. Watch this, okay? I'm gonna just assume some random values here. Some random values. Let me just say the mass is 2. Actually, I'll use 1. And let me just say LV is equal to 100. If that is the case, wouldn't that be 1 by 100? And what's 1 by 100?
100.
Okay, but if I increase the mass by 2 times, so my mass is now going to be 2. That's going to be 2 by 100, which is 200. So by doubling the mass, and you could see here that you're doubling the energy.
Yes, sir.
Yeah. All right, so that's that. If you don't understand, let me know now. This over here is just a little situation to prove the concept. If you don't understand, let me know. Higan, you understand?
Yes, I understand.
Okay, so I have a question. If I quadrupled the mass, what would happen to the energy?
It would also quadruple.
Exactly, so it's a linear relationship.
Yes, proportional.
I live bad boy. I didn't know the nice words and thing. Ah boy. Big up on yourself. I don't know how to use baby words around all you. I could use the proper jargon. Right, so question 28. According to the principles of heat transfer, which of the following statements is incorrect? So could we all agree that heat always goes from hotter to colder? Think for instance, if you take a metal spoon, right? Let me just say the metal spoon is at room temperature, and you put it in a pot with water. Wouldn't the heat spread from the base to the top of the spoon? Yes or no?
Yes, sir.
So for heat to be transferred, you must have a region that's hotter and a region that's colder. If you don't have a temperature gradient, heat cannot be transferred. So which one is incorrect?
Sir, D.
D is incorrect, right? That don't make sense. For heat to be transferred, you need a temperature gradient. 29. Which of the following statements concerning characteristics of steel and iron is correct? So iron is typically soft, and so it's very easy to magnetize iron. But because of its soft nature, it doesn't retain its magnetism. Steel, however, is very hard to magnetize. But when you magnetize steel, it has retained its properties. So which one corresponds to what I just said?
B.
B, right? So iron is easily magnetized because it's soft, but it doesn't retain its magnetism well. However, steel is very hard to magnetize, and so it retains its magnetism well. Right, I'm going to move on. Akida, I didn't hear from you in a very long time. Are you still there?
Hi.
Yeah, catch you lacking. Are you procrastinating or are you paying attention?
I am paying attention.
All right, so tell me, what is the answer for question 2C?
Let me read it. Item 30 refers to the following diagram, which illustrates a longitudinal wave train produced on a slinky. Which of the following distances represents the wavelength of the vibration? I'm going to take a guess and say C.
It's C to something. C to what?
C to E. C to
Yeah,
E.
C to E is correct. C to E is correct. So this is an example of a longitudinal wave, right? Now, when we're talking about wavelength for a longitudinal wave, we're looking at two successive compressions or two successive rarefactions. Does anybody not know what a rarefaction is?
So can you explain what this is?
Say that again.
Can you explain what this is?
Okay, so a rarefaction, so you understand, if you have a slinky and it's moving, and there are periods in time where it would contract and it would expand, yes or no?
Yeah.
So when it expands, that's a rarefaction. When
Okay.
it contracts, it's a compression. And so what
Okay.
I'm saying is, to find a wavelength, we're looking for two successive compressions or two successive rarefactions. So an example for the wavelength could be A to C. You make a guess. What could it be as well? It could also be what? Other than A to C. What could the wavelength be?
C. Also B.
So wait, funny for each hundred. And then I'll go from there.
Right now, lots of people talking.
B and D, sir.
B and D, right? B and D is also correct because remember, wavelength, or I'll write a definition. So wavelength is the distance between two successive compressions or rarefactions. I'll draw a diagram here, right? So this is our compression. And this is our rarefaction. So we're looking basically to see where it repeats itself. And if it repeats itself, it would appear two times. So like A to C. A to C is an example of two successive compressions. B to D is an example of two successive what?
Refraction.
Right? And C to E would be an example of two successive compressions. Cool. C to E. In case they change up the question, or they should know how to answer it now. So you're looking out for two successive compressions, and you're looking for two successive rarefactions. Cool. I take it everybody understand this. Right?
Sir,
Kida,
understood.
Keegan, you good?
Yes, sir.
All right, nice. Akira, you okay?
I'm fine.
So Akira, would this also be the wavelength from B to D?
Well, I saw this. I just got up to put my body sink, so I can't say no.
Nah, B to D is also an example of a wavelength. You know why?
What? Because it refracting out, like, when it's slinky, it going out, expanding thingy. That?
Yeah, that's called rarefactions. So
Oh,
wavelength is the distance between two successive compressions or rarefactions. And to this be and
I
that would be
see.
one rarefaction, and this would be another rarefaction.
Yeah,
So two successive rarefactions. That is how it is good. Right?
I see.
Yeah. So I feel like you understand it now, finally. If you don't understand something, tell me, you know. That's what I'm here for. Tell me.
I will.
Question 31. If sounds of different frequencies are played in succession, which of the following properties would change? So anytime we're talking about frequency, we're talking about what? What, guys?
Pitch.
Pitch. So if I'm playing different frequencies, the pitch would change. Trust everybody okay with that. So when we talk about frequency, we're talking about pitch. When we talk about amplitude, we're talking about what? What does amplitude mean? Correspond to?
Loudness.
Loudness.
Right, loudness. 32. Which of the following types of electromagnetic radiation causes tanning? The answer is simple. Why does wear sunscreen for?
UV rays or ultraviolet, I guess. D.
Yeah, that's it. So you wear sunscreen to block UV
C.
rays. So 32D. So UV rays cause tanning because UV rays have a shorter wavelength and a greater penetrative ability. So they could actually go beneath your skin and damage your cells. And that's why UV rays cause cancer. Okay, let's move on. Question 33. Which of the following are laws of refraction? So what exactly is refraction, right? Refraction is when you go in from one medium to another. And because you're going from one medium to another, the velocity of light would change. And so it would bend. So the first rule for refraction is that sin I over sin r is equal to n, which is equal to a constant. So 1 is correct. Do you all think 2 makes sense? 2 sounds like what? What does 2 sound
No, it
like?
doesn't make sense.
Total internal reflection.
This sound like how you say the normal line and the angular refraction. I'm mixing up my words. I know what I'm trying to say, but I'm mixing up my words. Give me a little second there.
I think you're trying to talk about this, the incident ray, the refracted ray, and the normal all lie in the same plane. I think that's what you're talking about.
Yeah, that's exactly what I'm trying to say. That number 2 reminds me of that.
So number 2 is very wrong because, okay, hear this, right, guys? Even if we're talking about total internal reflection, and when we're dealing with total internal reflection, you would say angle of incidence is equal to angular reflection.
Yes, sir.
So you would never say angular incidence is equal to the angle of refraction. You'd never say that. If they're the same, you would say reflection. So 2 is wrong. If this was reflection, then that could have corresponded to refraction because it would have been total internal reflection, which happens because of refraction. Right? So 1 and 3 is the answer. 1 and 3 is the answer. So everybody okay with that?
Yes, sir.
Okay, word. So again, I'll understand why 2 don't make sense.
Yes, sir.
Okay, cool. I'm gonna move on. Akida, you're good, right?
Yes, sir. I know 2 wasn't the answer.
Good, good. The note from a drum is louder when it is struck harder because the sound waves produce a greater what?
Amplitude.
Amplitude. Fellas, if all you don't know the answer, think of it like this. Even you're listening to car audio, you should know what amp is, right? And an amp is make things louder. So amplitude. That's why we just call an amplifier because it amplifies the amplitude. In case you didn't know. Yeah. So you don't have a reason to get this answer wrong. So guys, and most of physics so far is like common sense, yes or no? Like what I think. Like most of these
Yes,
questions.
sir. I find the multiple choices kind of common sense.
Exactly, right? Exactly. And let me ask you that question. So forget about the refractive index. What do you think is the densest? Air, ice, perspex, or diamond? What do you think is the densest?
Diamond.
Diamond.
Diamond. Where would all run faster? Are they gonna run faster in mud or air?
Air.
Air. So guys, the denser something is, the slower the speed is going to be in that medium. So what's the answer?
B.
Diamond.
Diamond, right? And we understand why. You don't even
Yes.
have to worry about the refractive index, but typically when we're talking about the refractive index, we're talking about which medium is the densest. So if your refractive index is the most, then that would be the densest medium out of the bunch. So the refractive index for diamond is 2.4. So that has the highest refractive index, so it's the densest. And it makes sense that the denser something is, the speed will slow down in that medium. The mask goes like this. When we're talking about sound waves, would sound waves slow down in a denser medium? Yes or no?
Yes,
Yes.
sir.
Nah. Sound waves is actually increase when a denser medium
Oh
is
yes, sir.
introduced.
That makes sense.
Think about it. And when I board in class, when I was in primary school, or you like pull their ears on the wooden desk, and you hit the desk and you hear it one time. Or you know what
Yeah.
I'm talking about? So yeah, guys.
Yes. Yeah.
So what I'm saying is, just remember that I feel like they might change up something about that. So just remember, light travels slower in denser mediums, but the speed for sound waves increase. Just remember that. Okay.
Wait, excuse. By the way,
Oh,
what's
it's because
perspex?
there's more.
Oh, perspex is just glass. That's just glass. Yeah. The
Sir,
refractive
is
index
it
should look
because
familiar. Yes, somebody was saying something.
sir, the reason why sound waves move faster is it because there's more medium or more particles as it's
Yes, that's 100% correct. So sound waves are examples of mechanical waves, and they need to propagate. You need to propagate something to move. So for sound waves to be transmitted, particles need to vibrate. And so if something is denser, there are more particles to vibrate. And so that's it. Yeah, you were spot on. Question 36. A wave has a wavelength of 5 centimeters and an amplitude of 2 centimeters. Which of the following diagrams represents the wave? So guys, when we talk about amplitude, and that's how high or low the graph goes? Yes or no?
Yeah.
Yeah.
yes.
Yes.
So tell me guys, which of the options are wrong immediately?
D.
Yeah.
A is correct, right? A is correct. The wrong answers immediately are
C,
D.
C and D.
The reason why that is the case is because the wave must have an amplitude of 2 centimeters, so it needs to be going up to 2 and going down to 2. If you understand what I'm saying. So amplitude is how high or how low a graph goes, is the maximum displacement. Understand? For the person that was confused.
Yeah, I understand.
Okay, Naomi, could you not draw on the screen unless you're contributing? I don't mean it's not a bad way or anything. I'm just saying, like, we're doing work. If I ask you to draw on the screen, you can draw on the screen, but refrain from it now. Right? And wavelength of 5 centimeters. What is wavelength? I'd like you all to think of wavelength as simply the time it takes for one full oscillation. I'm talking about time period. Wavelength is the length it takes for one full oscillation. So what is one full oscillation? This is an example of one full oscillation. You have a crest and you have a trough. So the wavelength is the distance for one full oscillation. So I want somebody to tell me, what is the distance for this full oscillation here? For this one, E.
10.
10. So could that be correct? What the wavelength supposed to be?
5.
Yeah. So this is wrong. So this is wrong, right? Let's check out this graph. So again, wavelength is the distance for one full oscillation. So this over here is one full oscillation. And so it's 5. So your correct answer is B. You understand?
Yes, sir.
So amplitude is the maximum displacement, and wavelength is just the distance for one full oscillation. How much oscillations we have here, guys?
In B, we have two oscillations.
Yeah, we have two, right? We're going up, going down. Then we're going up, going down. We're repeating that. So it's two oscillations there. Right. Let's continue. 37. Item 37 refers to the following graphs with axes having the same scales of two sound waves P and Q. So just by looking at this, right, guys, which one goes up? Which one has a greater maximum displacement?
Q.
Q. So if the maximum displacement for Q is more than P, that means that this sound wave is going to be so maximum
Loud.
displacement stands for amplitude, and so the amplitude for this wave is greater than this. So this wave is going to be louder. Make sense?
Yes, sir.
Okay. So this one is louder. And the reason for that is because it's going up to a higher point. So the maximum displacement is more. All right. And in this wave, let me ask you questions. I'm asking you some questions, right? We're dealing with the same time. Which graph has more oscillations? P or Q? Which? P. So if it has more oscillations, doesn't that mean the frequency will be higher because it's occurring more frequently?
Yes.
So if the frequency is higher here, what does a higher frequency correspond to?
Higher pitch.
Right. So let's see which option corresponds to that. So Q is louder. Q is louder than P. And also have no. Q is louder than P, but P has a higher pitch. So the answer is E. Everybody okay with that? So Q is louder than P. We understand why, because it has a greater maximum displacement. So the amplitude is more. But P has a higher pitch because in the same time period, the oscillations is more frequent. So it has a higher frequency. Higher frequency means higher pitch. So is everybody okay?
Yes, sir.
Yes, sir.
Okay, cool. Question 38. All right, Kida, let me see if you understand how to find wavelength. Tell me, Kida, waiting the answer is for 38.
You're real targeting me, you know.
What? I didn't hear you in a long time.
You hear me like, what, 5 questions ago?
That is a long time. That is a whole time period there.
Okay,
Moving on to a new oscillation here. Moving on to a new oscillation. So give me a question and read.
The wavelength of the wave is equal to the distance. Could scroll this up. So I can't see all the options.
I see all the options.
Okay, never mind. Never mind. The wavelength of the wave is equal to the distance. I gotta say it is that P to R.
Nah, what do you mean Peter?
C?
Nah. The
I
actual answer is Peter.
I'd give it, yeah.
Is it Peter
P
or
to
Peter?
S.
Yeah, let me explain,
Oh,
right?
I can see it. I can see it.
So guys, only remember how I showed earlier to find wavelength for a longitudinal wave, right? So it's basically two successive compressions or refractions. That's for a longitudinal wave. This over here is an example of a transverse wave, and we're looking out for the distance between two successive troughs or crests. So Akira, this is what I'm talking about, right? So Akira, these are examples of crests. The highest point of a graph, of a curve, like a sine function,
Yeah.
is the crest. And these would correspond to the what? What would these correspond to? These are the what?
The trust.
Yeah. Yep. So you understand what I'm saying? If I want to figure out wavelength, it's the distance between two successive crests. So I have a crest here and I have a crest here. So the distance between them. Fully understand that?
Yes, sir. Yes, sir.
Never making a mistake again. Never. Nah. Right? And tell me something, right? would this point to this point also be a wavelength?
Well, it's not two full troughs, but it could be.
Nah, it is. It is.
It is?
Yeah, because those 2 points are in phase.
Oh.
Watch it. Watch what I'm saying, right? And this point over here is the point you get when you go down and it cuts the x-axis. Can you see that that's the same thing that's happening over here? So they're in phase.
Yeah.
Okay. Tell me something. Would this be an example of the wavelength?
Yes.
Yeah, because that would be an example of 2 successive what?
Two successive troughs.
Yep. Awesome. That's a good thing I called you. But you're not done yet. Not done yet. So, I would say I'll give somebody a Bobby if they could figure out what 1 is. But I don't know how I'm gonna give a Bobby.
Wait, is 2 only, and?
Is 2 only, right? But I want to see if I could figure out what 1 and 3 are examples of.
So see, if I had my lab book, I would definitely get right, but I don't. So
Well,
1 is interference.
nah, 1 is not interference.
Refraction.
Yeah.
No, refraction.
Total internal reflection. That's what it is. Let me explain something, guys. So on this side, we have 1 medium, and on this side, we have another medium. So you're going from 1 medium to another. Same thing over here. So this over here, this is what kind of line? What line is that? That is normal, that's the boundary line. What is that? What is the line that separates 2 mediums?
Boundary line.
Right. And maybe if I do this, I'll see what I'm talking about. If I draw the normal, I'll see what I'm talking about. That's an example of what?
Total internal reflection.
Right. Which is characteristic of refraction, right? So this is an example of refraction. And this over here is also an example of refraction because it goes from this medium to this medium. And you notice the wavelength changes and the direction changes as well. So 1 and 3 are examples of refraction. So part 2 is the only correct answer. And what exactly is diffraction? Diffraction is just basically the spreading out of a wave when it has to pass through a slit that's very narrow. Now, guys, for refraction, what's saying? For diffraction to happen, the size of the slit needs to be very close or smaller than what? Let me see if I can know. The what?
Smaller than the wave.
The wavelength. For diffraction to happen, the size of the slit must be the same size or smaller than the wavelength. And this is the wavelength. So it's about the same size, right? If you notice, it's probably like about the same size. So in my opinion, it should probably have less diffraction, but it still would have diffraction, right? And diffraction is spreading out of a wave. So the answer is just 2.
Sir, question.
Yeah.
If a wave bends around an object, is that also diffraction?
If it bends around an object, like no, I wouldn't say that's diffraction. Like diffraction is when a wave passes through a very, very narrow slit. Yeah. I wouldn't say that's diffraction. That'll probably be reflection or something. Because it's going around. All right. So to the 9B. Okay, question 40. Guys, at the bright fringes, we will have what kind of interference? Somebody tell me. At the bright fringes, we're going to have what?
Constructive interference.
Right. And for constructive interference to happen, the waves must be in phase. So bright means constructive. And it means in phase. So if that is the case, what does he? What does the dark fringes mean?
Destructive.
Destructive.
Right? And it would be out of phase.
Or out of phase, yes, that makes sense.
Because if they're out of phase, it would cancel off because they're not aligned with each other. So the reason for the formation of the bright fringes is that all the crests are in phase along these points. The keyword I'm looking for is in phase. Everybody okay with that? So bright fringes is constructive interference, and that means in phase. So 40B, in phase. Yes or no? We good?
Yes, sir, we good.
Okay, cool. Question 41. Which diagram best shows the path taken by a ray of light through a rectangular glass block? I'm surprised they didn't call it perspex, right? Now let me show you a little trick. Anytime a light ray goes into a medium and comes out, the initial incident ray has to be parallel with the resulting refracted ray. So let me show you what I mean by that. So here gone. If I were to extend this line, can you see that it's parallel to the resulting refracted ray at the end?
Yes, I could see that.
Would it happen for over here?
No, it wouldn't happen there.
No, it wouldn't happen over there, right?
Yeah.
So that's wrong. Definitely not over here, right? Because this.
Yeah, definitely that out.
Nah. This one looking close, right? But you realize that it's not parallel because it's intersecting here. Yeah. So the only one where the initial incident ray is parallel to the resultant refracted ray is C. Are they seeing what I'm talking about? Anytime, so like the light ray is going from air to glass and then from glass to air again. Anytime this is the case, the initial incident ray is directly parallel to the resultant refracted ray. Can you guys see what I'm talking about?
Yeah, and that's like the lateral shift.
Yeah, that's exactly it.
In between there.
Yeah. That's why when you put, like, let me just say a straw in a glass of water, you just see it kind of shifted. You know what I mean?
Yeah.
Yeah. And this is also the principle for which we see another thing again. Periscope. This is the concept of periscopes. So is everybody okay with this question? Can you all figure out this in the exam?
Of course, sir.
Okay. Akida, you understand what I mean by parallel and thing?
Kind of.
What is it?
Kind of.
Kind of. Okay. Let me run through it one more time. I'm saying that if a light ray enters a medium and it comes out, the original ray needs to be parallel to the resulting ray. If I were to extend this, can you see that it is parallel to the resulting ray?
Yeah, I could see it.
So we can see that. Let me try any other. Give me one to try. I'm going to try one. Then we're going to move on. A, B, C, or D. I mean, A, B, or D. Which one do you want me to try?
B.
B, okay. Oh, B is wrong for another reason. This look like it get refracted?
Nope.
No, so this is definitely wrong, right? But even so, if you were to draw it, do they look like they are parallel?
No, sir.
Nah. So you understand it now, right? Like fully.
Yes, sir.
They had to be
Fully.
the original incident ray needs to be parallel with the resultant refracted ray coming out. Item 42. Akira, would you say the answer is 8 and just move on about today? Would you say the answer is 8?
No.
No, what would you say the amplitude is?
I would say it's 4.
I would say it's 4 as well. Because 8 centimeters represents the
full thing. But it just want the
both of the displacements, right? So the displacement above the x-axis and the displacement below the x-axis. So if I want to figure out the displacement strictly above the x-axis, I would have to divide this by 2. So that will be 4.
With sun and also the region above, that would be like the loudness. So that is the amplitude. So that's why there will be 4 as well.
Yeah, that's specifically it. That's specifically it. Because when we talk about the maximum displacement, we're talking about amplitude, right? And
Yes, sir.
you can see that this is the displacement.
Yeah, I can see that.
Right. So this is the amplitude. So the amplitude is 4. So the answer is 42A. Now, let me just say they change up the question, right? And instead of amplitude, they ask you for wavelength. Let me see. What do you think the wavelength would that be? Let me see how bad it is.
21.
Nah, 21 is wrong.
7.
7.
7 is the wavelength. For the girl answer,
Because they
21.
divide by 3.
Exactly. Exactly, because the wavelength is the length for one oscillation. Hence, and over here, we have one oscillation here. Then we have another oscillation here. And then we have another oscillation here. So the Gila answered 21. Can you understand why it's supposed to be 7?
Yep.
Yes, sir.
Because the wavelength is the length for one oscillation, not 3, 1. So we have 3, so you would divide 21 by 3 and you get 7 centimeters. So that's just something to keep in mind in case they switch it up. Okay, we're going to move on now. 43. Which of the following statements about insulators are true? So guys, insulators prevent the flow of current. And what exactly is the flow of current? The flow of current refers to the net movement of electrons. So an insulator has to prevent the flow of electrons. So which options, all you think, would be true for an insulator if we don't want electrons to flow? So we don't want electrons to flow.
Well, so 2 definitely out.
Yeah, definitely out there because it's saying in an insulator, many electrons can move freely. I'm talking about our metal there, right? I'm talking about metallic more than that's wrong. Because, and so I just now say that an insulator has to prevent the flow of current.
Yes.
And current refers to the movement of electrons. So
Correct.
if in an insulator, many electrons could move freely, that means that the electrons can move. And so that would technically make it a conductor. So option 2 is definitely wrong. Right?
Present?
Yeah. Mr. Uchiha, your mic unmuted. I'll call Toby Rama for you. Yeah. Right. Yeah, so I hope everybody understand that. Option 1 makes sense because it says that the electrons are bound firmly. If the electrons are bounded firmly, that means that the electrons cannot move about. And if the electrons cannot move about, then it cannot result in a movement of electrons. And part 3, does anybody know why part 3 makes sense? Could you give me an example of that? Could somebody
The
give me an
glass
example?
rod thing.
Static electricity.
Glass rod, static electricity, everybody saying correct things. Nice. So the answer is 1 and 3. 1 and 3. So that's B. So everybody understand why option 2 is out of the question. Take it as yes. Take it as
Yeah.
I'm going to move on. 44.
I want to understand some, right? Why, how come option 3 is correct? Like, I got the answer because I know 2 definitely out. So with process of elimination, I get it. But how is 3 true?
Okay, so let me give you an example, right? When you was doing electrostatics in physics, and you had an example where you would have a silk cloth and a glass rod, yes or no?
I do remember that, but I'll say yes.
Okay, all right. So a glass rod, do you think a glass is a conductor or insulator?
Insulator.
Right. So basically what I'm saying is, if I take the glass rod and I rub it against the silk cloth, some of the electrons from the glass rod is going to get transferred to the silk cloth. If only one of the specifics, or they could look up the triboelectric series. They probably would have. Or they don't have to know about that, right? Unless you're doing like chemical engineering or something. I'm not doing that. I'm doing electrical, but I know about it. Basically, when we're talking about insulators, it has something called the triboelectric series, and that tells you if it would lose electrons or gain electrons. So based on the position of glass would actually lose electrons if you rub it. So Hagan, you understand what I'm saying, right? If you rub a glass rod
Yes,
against cloth, it's going to lose electrons. If it's losing electrons and it's going to the cloth, what's going to happen to the charge of the glass rod? It's going to become what? If you lose electrons.
it's going to become more negatively charged.
No. Hagan, what is the charge of an electron?
Or electron is negatively charged.
So if you're losing negativity, becoming...
It'll be more positive, it'll be positive charge now.
Yes. You understand?
Like a balloon. How a balloon is like, if you rub a balloon against your clothes, that would like charge it up.
Yep, that's a perfect example of an insulator becoming charged by rubbing.
All right.
Yeah. So I think you understand, right?
Yes, sir.
Right. Becomes... Okay, 44. I think we know the answer is A, right? Anytime you have two oppositely charged point charges, the positive would go to the negative. So, A. Additionally, you should know that the field lines for a positively charged particle would always go outwards. And for a negatively charged particle, the field lines would go inwards. And well, if it's oppositely charged, the positive would go towards the negative in this manner. So I trust that everybody okay with question 44. Yeah, let's move on. 45. Which of the following circuits is electrically the same as the circuit above? So in item 45, we have an example of what kind of circuit? A series circuit or a parallel circuit?
Series.
A series.
Series.
Do you guys know why a series? Or they just put series?
It only flows in one
It's
direction. Yeah, one direction.
Exactly. That's the perfect answer, right? If we have a series circuit, there's only one path for current to take. And if I draw the current in the circuit, you'll see that the current never splits. So we understand series circuit. So which of the following circuits is electrically equivalent? The answer is A, right? Because in option A, this is also an example of a series circuit. Matter of fact, it come like I just take this, I shift it to over here, and I shift this one over here. That's what it come like. So everybody understand that 45A is the answer, right?
Why is 45A the answer though? Like, why the rest of answers is wrong?
Okay, I will show you, right? But yeah, how to say your name? Is it I don't know how to say your name. I don't wanna mess up your name. How do you say your name?
Fourier.
Or like Fourier transform. Yeah. So you understand why the circuit above is a series circuit, yes or no?
Yeah.
Okay.
Yeah.
Be honest with me. You understand why is a series circuit? Or you just explain to me why is a series circuit?
Because it's taking one path, and another reason why it's series is because if you had a switch in the circuit, it would control all the elements in the circuit. If you had a parallel circuit, you could have two switches and it would affect two different parts of the circuit.
Yeah, you're talking sense, right? You're talking sense. And so anytime you have a series circuit, there's one path with a current to take. And you see now over here, right? Yes or no?
Yes.
So let's look at the other options. Watch this, right? When the current reaches this junction, what happens to the current?
It splits.
So this is a parallel circuit. When the current reaches this junction, what happens?
It splits.
Okay, over here now, when the current reaches this junction, yeah. So all the other options are example of parallel circuits. Yeah. So 45A. Should make a note about that. Parallel. Okay. All right. So, which of the following combinations correctly identifies the currents? The first thing I'm going to ask Colin, do these currents look like they're the same magnitude? Or in other words, do they have the same amplitude?
Yes, sir.
Yeah, they have the same amplitude, right? Because they're going up to the same value, which is what? What is in between 0 and 5?
2.5.
Yeah, 2.5, right? 2.5. So it would go up to 2.5. Both of them would go up to 2.5 milliamps, and both of them would go down to minus 2.5 milliamps, which just means a change in direction for the current. So automatically, any option that says that they have different greater peak values is wrong because they have the same peak values. So what do I mean by peak value? Peak value is the highest value the current is going up to. Can everybody see in this class that the current, the highest it goes up to when the first one is 2.5 and the highest it goes up when the second one is 2.5? Can everybody see that?
Yes, sir.
Yes,
So,
sir.
so neither
Yes,
of
sir.
them,
Yes, sir.
have a greater peak value. So anyone that says 201 is wrong. The next thing, which wave oscillates more frequently?
The first one.
The
The
left
first
hand
one.
one.
The first one. So that means this one has a higher frequency. I'll show you all the calculation, but just by looking at it, it oscillates more. So it's more frequent, so it has a higher frequency. So what's the answer?
E.
Somebody said A.
E.
D.
E.
B for bat.
So D.
I hear in D. I hear in B. I hear in
B for bat.
yeah, B for bat. Yeah. Somebody said D. D is wrong. Why is D wrong? So they're saying current with greater frequency. So this is current 1 here, and this is current 2. If you look at it, you could see that this current oscillates more in the same time frame. So it has a higher frequency. It's more frequent. That's the common sense explanation. Let me show you the physics like the mathematical and physics proof. So how do we find frequency? Frequency is equal to 1 over what?
Period.
Period. All right. And that's a wrap. Yeah. So do you all know what period means? Period is the time it takes for what?
One oscillation.
For one oscillation. So one oscillation here would be what? How much seconds?
0.2. 0.02.
Nah. For this one is 0.01. Unless you was talking about 2. So we're going to find the frequency of 1 first, right? So to find for the frequency of 1, I can call that F1. That's going to be 1 over 0.01. And that should be 100 hertz, if my math's correct. So that's the frequency of the first wave. So to find the frequency of the second wave, that's going to be 1 over 0.02, which is going to be equal to 50 hertz. So everybody should be seeing that the frequency of the first wave is 2 times the frequency of the second wave. Akira, that makes sense? You good?
Yeah.
And Akira, common sense. Like we use some common sense here, right? And
Where's your pen?
Akira, and you can see that Ashan, I think your mic is unmuted. Unless that's intentional and you're asking a question.
You did not say the paw prints out when you press on your screen.
Wait, I'm not hearing you
Did
properly.
you know that the paw prints out when you press on your screen? You did
Talk a
not say
little
paw
louder.
prints out when you press on your screen.
You guys hearing what Shana's saying?
Can she type it out?
Yeah, type it out, right? So Akira, and logically, just by looking at it, you can see that in the same time period, you have 2 oscillations here, but you have 1 oscillation here. So and just seeing
Yeah.
that this one is 2 times the frequency of this just by looking at it, you can see that.
Yeah.
Yes, sir, that
Yeah.
makes sense.
Right. So did Sean type the message in the chat?
Not yet. But she might unmuted, so maybe she waiting to speak.
Okay. Well, you
Why do
let me know
so?
what's going on in the chat. So that's the answer to 46. Is everybody okay with 46?
Yes, sir.
Okay, good. So let's move on to 47, right? So in 47, we have a bulb over here. This is a fuse. This is a diode. And this is a resistor. And also this is a dry cell battery. What's my answer?
D.
You can see the pose. You see it?
It's D, right? Taking the word for it. Let me
Yes,
just check
sir.
it back. Let me just check it back. So resistor is 4, lamp is 1, diode is 3, fuse is 2. Excellent. So let's move on. Item 48 refers
Wait, excuse
Hello?
me. We could go for that last question again, please.
this one over here.
The last one you did. What is
All
it,
right,
40?
so this is our bulb. This is our fuse.
Oh, so I'm not seeing it on your screen, eh?
You not seeing your screen?
Yeah, I've seen it now. I've seen it now.
Okay. Yeah, so that's basically about it. 1 is a bulb, 2 is a fuse, 3 is a diode, and 4 is a resistor.
Oh, okay. You just label it. Okay, I understand now.
Yeah. So in item 48, we have a small particle that's negatively charged and is between 2 plates being observed with a microscope. So this is negatively charged. If something is negatively charged, it'll be attracted to what? Keegan, tell me.
You'll be attracted to something positive.
Right. So which of the following arrows correctly indicates the direction of the movement of the dust particle when the switch is closed? So if I close the switch, I complete my circuit. And so if I trace back the route, so this is the positive terminal here, this is the negative terminal. The positive terminal is going to be connected to this plate. So this plate is going to become what?
Positively charged.
Right? So this plate is going to become positively charged. So the negatively charged particle will move towards it. So the answer is downwards. Good?
Right, yes, downwards.
Right. So the answer is C.
Yes, C.
49. Which of the following diagrams represents the magnetic field which exists between 2 opposite magnetic poles? Anytime you have 2 opposite magnetic poles, the field lines always goes from north to south. So which one goes from north to south?
C.
That's C,
C.
right? C is the answer. Okay, this one should be very easy. Was the frequency of a voltage time graph? Frequency was formula for frequency. Frequency is 1 over.
Period.
Right, so 1 over T. So the answer is 50D. 51. Magnetic induction occurs when iron nails near a magnet become magnetized. So I suspect that a very few people might understand this question. So let me explain it. I have a nice animation in the video I uploaded on YouTube, but basically what happens is, and everybody can agree that iron is attracted to magnets, yes or no?
Yes.
Yes, sir.
Yes,
So,
sir.
the proper name for that is a ferromagnetic material. So iron is a ferromagnetic material. So within the iron, if you had a microscope, you have a bunch of domains. And you can think of these domains as very small, weak magnets. And so when I take a magnet and I bring it close to a ferromagnetic material like iron, what happens is the domains align and it acts like a magnet. And that process happens without directly touching. So anytime you're doing an action without physical contact, it's called induction. So let me run through the process one more time. So let me just say we have an iron nail. I'll draw the diagram. So we have an iron nail here. So iron nail is an example of a ferromagnetic material. And so inside of it, there's a bunch of very weak temporary magnets, and they're all over the place. Okay, so that's what's going on, right? Now, if I were to take a magnet and bring it close by, let's just say that this is the North Pole, this is South Pole. So I have a magnet here. Look at what's going to happen. Right. Right, so look at what's going to happen. By me taking that magnet and bringing it close by, all of the domains would align in the direction of the magnetic field. So they would align like this. And if it aligns, the iron nail would temporarily become magnetized. And so that's why we call it that's why we call it magnetic induction, because it's becoming magnetic without any physical contact. And everybody in class understands that a magnet would have invisible magnetic field lines. You don't necessarily have to put a magnet directly by an iron nail for it to feel the magnetic field. You can just put it close by. So here, you get what I'm saying?
Hold on, sir.
Yes,
Repeat
sir.
one more time.
Understand.
Rachel, say that again.
Repeat one more time, please.
So Rachel, I'll explain it in a simple manner. Rachel, you ever rub like a metal screwdriver or something on a magnet, and when you remove it, the screwdriver is still magnetized? Yes or no?
No, but for this case, I'll pretend I have experienced that.
Say that again. A little louder.
Yes, sir. Yes. Yes.
Okay, so you've seen it in real life before. Like you understand that's happened. And so basically, anytime you take a material that's ferromagnetic, meaning that it could be magnetized like iron, I'm saying that when you bring a magnet close by, there are these things called domains, which is like tiny magnets inside the material. They would align with the magnetic field, and if it aligns, then the iron nail would become magnetized. And because there's no physical contact, that's induction. Yeah.
Oh, it's the magnets part, because on the diagram it looks like electrons. That's right.
Oh, yeah. If I were to draw it like perfect, it would actually be a bunch of small, tiny magnets. Yeah. It would be a bunch of very small magnets.
Yeah, that's what confused me. I get it now.
Okay, nice. For a simple AC generator, which of the following graphs will be produced by two complete rotations of the armature? So in an AC generator, if you rotate it completely, you will result in a positive current and a negative current. Consequently, you would have a positive voltage and a negative voltage. So that's one full oscillation. That's when you rotate the armature once. So if I rotate the armature again, it's going to generate another wave. So I should have two oscillations. So in which graph are you seeing two oscillations?
D, sir.
D, right? So guys, let me see how bad it is, right? So in this example here, this would have meant that I would have turned the armature how much degrees? Make a guess.
That is 90 degrees there.
Nah, that's 180.
Is 180 because it's a straight line.
No. If you revolve the armature 360 degrees, you're going to get this waveform, right? You're going to get a full waveform.
Right.
So and you can see that this is half of a waveform.
Oh, yes.
So that'll be 180. Because to get a full waveform, you have to rotate it 360 degrees, the armature, for the AC generator.
All right, yeah, I see it.
Good. So this would be a rotation of 180 degrees. This would be a rotation of 360 degrees. Yes or no?
Correct.
So this is how much rotations? That's 1,
There's one full rotation.
Right. And this one over here is how much full rotations?
There's 3 full rotations.
Right. So if they change up the question, or they know how to handle this very skillfully.
Cool.
53. An ammeter has a very low resistance so that it can be placed in. So guys, our ammeter measures what?
Current.
And current flows in a circuit, right? So the current has to pass through the ammeter. So if I want to measure current, I need to place the ammeter in series so that the current can pass through it. Does anybody know why it needs to have a very low resistance?
So that the current will pass through the ammeter. Since
Right.
current takes the path of lowest resistance.
You said something about current takes the path of least resistance. Now, since it's a series circuit, there's only one path to take. And so, if our ammeter has resistance, it's going to affect the circuit very badly. So all we want the ammeter to do is just measure the current, right? Well, that's all we want it to do. We don't want it to affect any other component in the circuit. So our ammeter should have very low resistance, so the current could just go straight, it could enter and leave without doing anything additional. That's what we want. So this is a little diagram here showing the current passing through the ammeter. So the current is directly passing through the ammeter there. Right, so our ammeter is hooked up in series, and it must have very low resistance. While I am on the topic, let's go through voltmeters one time. So the answer here would be series with a component and not affect the circuit, so B. That's why so our ammeter is hooked up in series, and it must have a low resistance, so it doesn't add any resistance to the circuit. Cool. Let's just say I have a bulb. Guys, how would I measure the voltage across the bulb? Would I use an ammeter or a voltmeter? And a voltmeter measures the potential difference across 2 points. So this is how I would hook up the voltmeter. I would hook it up at this point and this point, because I want to measure the difference between those 2 points. And this would be an example of a what kind of connection? Parallel or series?
Parallel.
Some of you all might be saying, why parallel? Watch, if I draw the flow of current, when it reaches this junction, it will want to split. If that is the case, what do you think a voltmeter should have? High resistance or low resistance? Do I want the current to split?
High resistance.
High resistance, right? Because I don't want the current to split. So I don't want this to happen. I want all of the current to just flow through the bulb. I don't want the current to be used up by the voltmeter. So the voltmeter should have a very high resistance. So Higan, do you understand why the voltmeter should have a very high resistance?
Yes, because the relationship it's supposed to have with the current is supposed to be not proportional to it. So
Okay.
as one increase, another one is supposed to decrease.
Okay, I get what you're saying. So basically what you're saying is if I increase the resistance for the voltmeter, less current is going to pass through it. So that's what you're saying?
Correct, yeah.
And that's exactly what you want. Because Higan, you don't want the current to split any circuit. Because if I'm doing that, and that means the bulb not going to get all the current.
Yeah, and then the bulb wouldn't light up.
Exactly. I need the bulb to be getting the maximum current. So this must have a very high resistance. So most of the current passes through the bulb. Make sense?
Makes sense.
Because current always takes the path of least resistance. So
Yes.
a voltmeter is hooked up in parallel, and it must have a very high resistance. Awesome. Let's move on. Question 54. According to the Rutherford Bohr model of a neutral stable atom, P is equal to E. When I say the word neutral, what is the charge? If I say neutral, what is the charge?
0.
Zero. So does everybody understand why the number of why the protons will be equal to the electrons?
Yeah.
Yes, sir.
No,
Right.
no, sir. Not really. I ain't sure about the chemistry.
Okay, so protons would have a what? Negative or positive charge? What it look like?
Protons is positive.
right? And electrons is.
Negative.
So if we had the same amount of protons and electrons, what will happen?
They'll balance out each other.
Exactly. Guys, think of it like this, right? Imagine you had 5 protons, so that would be +5, and you had 5 electrons, that would be -5. What's 5 minus 5? What's plus
Oh,
5?
0.
0.
Neutron.
So you understand why we need to have the same amount of protons and electrons, right?
Yes.
So they will cancel off. Cool. Which of the following statements about radioisotopes is true? The answer is C. They are sometimes used in medicine. Could somebody give me an example of when it's used in medicine?
Like filtration, like in the thyroid glands.
Yeah, that's correct. That's correct. Also in treatment of cancer, right?
Yeah, wait, so what about cutting like cataracts and things like that?
No, I don't think so. To my knowledge, nah.
Oh.
Yeah, to my knowledge, no. You could, in the solutions for this, I did on YouTube. I showed you all a list of all the uses, all the medical uses. So after the crash course, I'll like check out the videos. Yeah. All right, so 56. Which of the following describes 2 properties of an alpha particle? So Hagan, alpha particles are what in nature? They're what?
Positive in nature.
Right. Not just positive, they
They're
represent.
very ionizing.
Yeah, they're very ionizing. And that's because they exist as a helium nucleus, 4,2 Ag. So some
So would
properties.
the answer be B?
The answer would be B. No, it wouldn't be B. Remember, alpha particles, they have the weakest penetrating power.
Oh, right.
Yeah. Gamma has.
So is it C?
C is the answer. Yeah, C is the answer. Yeah, because alpha particles, they are stopped by paper, right? They don't really have a very strong penetrating power. After alpha, you have beta, and then after beta, you have gamma. So let me just list out some properties of alpha particles. So it exists as a helium nucleus in nature. So helium nucleus, it's positive in nature, not very penetrating. Like I said, it has a high ionizing power. Matter of fact, it has the highest ionizing power. Could somebody else list another property of alpha particles? Are there any other properties to list?
It have 2 protons and 2 neutrons.
Full government name
Yes.
out here.
Right, so the mass number is 4 and the atomic number is 2. While we at it, could somebody tell me what beta would be? One time, so
What do you mean, say like a characteristic?
nah, just tell me the emission. So what would the emission be for a beta? Like if you had beta decay, what would the emission be?
So it would be like moderates.
I'm talking about the emission. So when we undergo alpha decay, the element would give off a helium nucleus. So if we're talking about beta decay, it would give off a what?
Oh, so I can't remember if the -1 on top or the bottom.
The zero at the top.
-1 and
Yeah,
E
the
electron.
bottom.
Yeah, okay.
Right. And gamma is just simply
Is this
0, 0.
right?
Right. And the reason why is because gamma is just pure energy. It's made up of photons, and photons don't really have a charge. They are just electromagnetic radiation, EM waves. That's gamma. So 57. Which of the following scientists discovered radium? Who discovered radium? A. Marie Curie. Not Maria Curie, yeah? Marie Curie. The last name kind of sounded like Curry, like curry duck. I don't find me. I don't be curry duck, though. I don't be curry duck. You have anybody from Guyana here?
Me, sir.
Okay.
Yes, sir.
Do you all say,
Yes, sir.
okay, like you, a little personally, right? Or they just say chicken curry or curry chicken. I just ask it. I just curious.
Chicken curry.
For me, sir, it's chicken curry.
It's split. It's split evenly. But what if I find a song better? Curry chicken or chicken curry?
Curry chicken.
Chicken
Chicken
curry,
curry.
sir. So it's chicken curry. Mean ke all you say is chicken curry.
What's curry chicken? I get outnumbered there. I get outnumbered.
So why would you say chicken curry?
I would say curry chicken.
Exactly.
Yes.
But for me personally, I don't even eat curry chicken. So
everyone have their own
curry chicken,
views
sir.
on what it would be. So for this perspective of different person, it'll be different.
I agree. It's a culture, and we are accustomed with. Right. I'm gonna start any wars here. So 58. Which of the following graphs shows the activity of a radioactive source varying with time? So D is the answer. D is the answer, right? Why is D the answer? Ent are you familiar with these kind of graphs? Ent would have to find half-life. Like I show you see graphs like this before. Yes or no?
Yes, sir.
So let me understand the logic. When we have radioactive decay, the activity, when time is 0, the activity is in maximum. But as time passes, it gradually decreases until it approaches 0. So, has to be D. And for anybody that wants to know the technical terminology, it's given by an exponential decay curve. Yeah, this is wrong because this tells us that the activity is increasing, but if it's decaying, then it's decreasing over time. These two are definitely wrong. And the answer is D. Is there anybody that does not understand why I'm saying that this represents the radioactive source with respect to time? Yes or no? I'm going to fully understand that. 58D. Akira, you understand?
I just rejoined, so I have no idea what went on.
Okay, you understand why I'm saying 58D for the activity of a radioactive source?
Yeah, no, I don't understand.
Okay, so Akira, if something is decaying, and when the time is 0, like before anything starts, it has its original mass, or it's the original quantity. All right.
Mm-hmm.
But as time passes, doesn't the amount decrease?
Yeah.
Until it approaches 0. So this is the only graph that explains that. So we start off at the original amount, but as time passes, it decreases. Yeah or no?
Okay, yeah, I get it.
Yeah. Right, and this represents the activity of a radioactive source. Keep that in mind. 59. Which of the following equations is correct? So in any equation, the left-hand side has to be equal to the right-hand side. So my answer is C, I believe. And let me show you why. Remember, alpha particle is 4, 2, right? So on the left-hand side, we have 226 for the mass number. We had to get back 226 on the right-hand side. So if you add 222 and you add 4, will you get back 226? Yes or no?
Yes. Yes, sir.
And for the atomic number, if I add 86 and I add 2, I'll get back 88. So this is the only correct option. All the other options is going to be very wrong. And I can show you one, for example. Like this one. This will be 0. This will be -1. With 222 and 0, give you 226?
No, sir.
Nah, that don't make sense. Would 86 plus -1 give you 88?
No.
Now I'll get 85. So all the other options will give you wrong answers. So the answer is C. Left hand side had to be equal to the right hand side. Question 60. In the scattering experiment conducted by Geiger and Marsden, some of the alpha particles were deflected. The explanation for this phenomenon is that, so guys, alpha particles are what in nature? Positive or negative?
Positive.
And so if it goes very close to the nucleus, remind me, what is the charge of the nucleus?
Positive.
Positive.
Yeah, so if the alpha particle goes close to the nucleus that's positively charged, wouldn't it be deflected? Because Oh, like charges repel?
Yes,
Yeah.
sir.
Yes, sir.
So the answer here is D. The nuclear charge and the mass are concentrated in a small volume in the atom. That's called the nucleus. Yeah. So that was it for 2025 January. Everybody okay with that?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, I'll have a little break or straight on to the 2024.
A little
Straight on.
A
5, sir.
break, a break.
5 minute break.
Straight on, sir.
Okay, I'll give her a little break, right? Give her a little break.
Yeah,
Alright, sir,
thanks.
5 minutes.
Thanks
Yeah.
for the break, man.
Excuse, sir.
Take
Yeah,
a
some
5
of
minutes.
us haven't eaten for the day yet.
Down. I
Excuse,
make
sir.
sure to say eat food before joining. I hear somebody saying something.
These papers that I corrected, you sent it, right? I know you already corrected this paper and sent it.
Okay, I will send it. It's on the chats.
No, this paper, the January 2025, I know you already did this and sent the proper thing, but
I will send this exact thing over here. This like this what we correcting here. I will send this.
alright.
Excuse, sir.
Thanks, sir.
Is this coming for the exam Friday?
Chances are like 60% of these questions are going to come back. The exact same questions. Yeah.
Okay, sir. So what about the other 40?
How about the what?
The other 40.
Well, we look at the other 40. When we do
I
the
think
other
about that
past.
question with the diode and something with the plates. It was near 50.
All right. You are talking about this question. Yes or no? This question you're talking about?
Yeah, that question.
Okay, so they're saying that the particle is what? What charge does the particle have?
Negative charge.
Negatively charged. If it's negatively charged, it'll be attracted to?
Positive.
Right. So when I close the switch,
Positive.
when I close the switch, this represents the positive terminal, and so it's connected to this plate. So this plate is going to become positive. Yeah or no? Tell me if you understand that.
So when you connect it, since the negative charges go to the positive,
Yes. So watch. This particle is negatively charged.
Okay.
When I close the switch, since this is the positive terminal, and I'm connecting the positive terminal to this plate is going to become positively charged. So that plate there is going to become positively charged, and so the particle will move downwards to the positively charged plate. Tell me if you understand that.
Yes, sir. Thanks.
All right.
Yes, sir. Thank you.
Okay, so come back at like 6:33. Right? Give it a little break. See you all then.
Fucked up, fucked up. Oh no, why did I say that?
Hey, Tiara, hush him out now.
Whoa, whoa, whoa. Things getting a little feisty here. I would appreciate it if like you keep your language to a more appropriate level. All right, guys, let me start back. All right, here you go, Nede. Akita, Aliyah, Kiara.
I'm here.
Okay, let's move on to 2024. Right, so let me just send this on the chat real quick.
Gosh.
All right, so Akita, let's up straight into 2024, right? So Akita,
Yes.
let's have a question one.
The answer is D.
D. Why? Why is it D?
Because when you move something, it's potential energy. And
Not quite. You see, when you move it, right, you're placing it, you're increasing the height, aren't you? Think about it.
yeah,
An object on the ground, and then you place it on a shelf. Would any object gain energy because of its position?
yeah.
Right.
Oh,
So let me show you what I'm talking about. Isn't the formula for potential energy mass by gravity by height?
yeah.
So if the height increases, wouldn't the total potential energy also increase?
Uh-huh.
Yeah. You sure you understand that?
I understand. It's just, it's my voice sounding like I don't understand because I'm very, very tired. No.
Okay. Well, guys, anytime you take an object and you increase its height from the ground, you're increasing the potential energy, specifically the gravitational potential energy.
Okay.
Question 2. This is a repeat. What's the answer? Well, actually, it's not a repeat, right? But you should know the answer. The time period of a simple pendulum oscillating with a small amplitude depends on the
The length of the pendulum.
The length
Right.
of the pendulum.
Depending on the length of the pendulum, that would affect how long it's taken to make a full loop. And so that would affect the time period. Remind me, guys, a longer pendulum would take a longer time or a shorter time?
Longer.
Longer time.
Right, so this would have a longer period, longer time period, shorter time period. Cool. Question 3. Is a repeat. What's the answer?
B.
Easy answer. Question 4. A diving ball is to be used at great depths, and so its walls are made thick. The main reason for this is that
E.
A. Yeah. Remember the formula? Pressure is equal to height by density by gravity. If you are going very deep into... Okay, I have a question, right? Let me just say, this is the C here. Where would the pressure on the ball be greater? Over here or over here? Where would the pressure be greater on the...
Second.
That answer.
in the second position, right? And the reason for that is because its height is going to be more. That's the reason why. So anytime you're increasing height, you're going deeper into a fluid, the amount of fluid acting on the body is going to increase, and so the pressure increases. So the ball needs to be made thick so that it can withstand the high pressure, because it needs to go deep into the water. And so the height is going to be very big. Akira, does that make sense? Yes or no?
So did that one submarine follow this law?
Say that again?
Did that one submarine follow this law?
One summary?
Submarine. That one submarine.
The submarine with the billionaires?
Oh yeah, the submarine that... Nah, them didn't follow that.
That's so
Them did
funny,
not follow
actually.
that. I tell you, when I was doing the solutions for this, that popped up on my phone.
Crazy timing.
I say that. So yeah, the reason why it imploded was because it reached a depth where it wasn't able to withstand the pressure of the ocean, because too much water was acting down on it, and so it imploded. Yeah. Right. Question 5. So in question 5, we have a velocity time graph. Tell me something, guys. What could I get from a velocity time graph? What are the two things I could get from a velocity time graph?
Acceleration.
Acceleration.
Okay, acceleration and deceleration, more or less the same thing. Just a different in sign. And I could also get the distance traveled. To find the distance traveled, I would figure out the area under the graph. Now, which of the following statements about the object is true? 1. It returns to its starting point. Guys, could we infer the position of the object from a velocity time graph?
No, sir.
A velocity time graph just tells us how fast it's going, right? That has nothing to do with where it's at. So the first option is wrong. Second option, it has zero acceleration between T2 and T3. For something to have zero acceleration, it needs to be moving at a constant speed. Could we see that it's moving at a constant speed between T2 and T3?
Yes, sir.
Right, so 2 is correct. Number 3, its velocity at T4 is the same as the initial velocity. So this is the initial velocity at O, and this is the velocity at T4. Is it the same?
Yes, sir.
Right, so my answer is 2 and 3. 5C. Question 6. Which of the following will be constant if a constant net force is applied to a body? So if you keep pushing something with the same force,
Momentum.
Nah.
I think is B.
Acceleration. I'm not sure why. In the formula for acceleration, well, the formula that has acceleration in it is F is equal to ma. F is equal to ma, right? Yes or no?
Yes, sir.
If I make acceleration the subject of the formula, I will divide both sides by m. So A will be equal to force over mass. I can make a formula there. So let me know if you understand how I come up with A is equal to force over mass. If anybody confused by how I come up with this, let me know. Okay, so Akida, acceleration could be written as force over mass. Let's just say we always pushing with a force of 8 newtons, right? We always pushing with a force of 8 newtons. And let me just say the mass is 2 kg. Akida, could mass ever change?
No. Well, yes.
Well, not really.
No.
In
Sorry.
physics, not really, because mass is the amount of matter in an object, and that can't change. If I keep my force constant and mass can't change, will my acceleration ever change?
No.
No. So you understand the relationship here, right? So if my force is always constant, and it's always going to be 8 over 2, it's always going to be 4 ms minus 2. So if I'm
that makes sense.
If I'm keeping my force constant, then my acceleration is always going to be the same. And this is the proof. Yeah. Question 7. An object of mass m is attached to a spring balance and its weight W recorded. What will be the result if the object is taken to the moon where the gravitational field strength is less than weight? Guys, does mass ever change?
No.
No, so mass has to be equal to m. And so any option that doesn't say that is wrong. And where do you all think the object would weigh more, on Earth or on the moon?
Earth.
On Earth. So if it's at the moon, the weight would be less than W. Make sense?
Yes, sir.
And why is that? Remember, weight is equals to mass times gravity. On Earth, the gravity is equal to 10. So that'll be 10m. This is on Earth. Does anybody know the gravity on the moon?
So I think it's
like 7 point something.
1.6.
1.6, yeah, 1.62. So on the moon, that would be like, so I'll give you an example, right? So let me just say we have a mass of 10 kg. On Earth, how much that will weigh?
100.
100 newtons, right? And that's because the gravity on Earth is stronger, so it'll pull it to the core of the Earth with a greater force. Let's calculate for the moon. So on the moon, the gravity is 1.6. I'm just going to say 1.6, right? So that's going to be 10 by 1.6. What is 10 by 1.6? 16, right? So I have the same mass, but everybody can see that by measuring the weight on the moon, it's less. Could we all see that? So we have the same mass, 10 kg, but on Earth and on the moon, there are two different gravities, and the gravitational field strength on Earth is more, and it's less on the moon. So the weight would be less on the moon. Is everybody okay with this question?
Yes, sir.
Okay, this question now. Item 8 refers to the following diagram, which shows a non-uniform bar pivoted at P. W indicates the weight of the bar, and forces F1 and F2 are applied at the position shown. So this is the pivot here. So what exactly is a pivot? A pivot is a point through which an object could rotate. So this object could either rotate like this, or it could rotate like this, depending on what force you apply. So we need to figure out the sum of clockwise moments. So let me run through this, right? Do you all think that if I apply an upwards force, that would be a clockwise moment? Yes or no?
Yeah.
Yeah, because if I were to continue this motion, look at how the bar is going to turn. It's gonna result in this motion. And this motion represents a clockwise motion. So this is clockwise here. Do you think that this would be clockwise?
Anti-clockwise.
This would be anti-clockwise, right? Because if I continue the motion, if I apply a downwards force, and this is the pivot, that means the bar would move in this direction. And so this is clearly anti-clockwise. This is anti-clockwise. For those of you all that don't know what clockwise and anti-clockwise is, this is clockwise, right? This is clockwise. This is anti-clockwise. All right. What do you all think this force would generate? Do you think it would generate a clockwise moment or anti-clockwise moment? What do you all think that's going to be? Clockwise or
That's an anti-clockwise there.
That's a clockwise.
Keegan, if I push this, if I push the bar downwards, wouldn't
yes, it's clockwise. Okay, I see what you're saying. I see what you're saying.
So you understand that if I push it downwards, it would pivot and it would be in this position. Yes or no?
Yes, I understand now.
And if I keep pushing, it would result in that kind of motion. So that's clearly a clockwise motion. Because this is 12, 0, it going in that direction. So this is clockwise as well. So to find the moments, you multiply the force by the perpendicular distance from the pivot. So let me look at this moment over here. So the force is F1, and what is its distance away from the pivot?
D1 plus
D1,
D3.
right? No, it's D1.
D1.
Watch.
D1 is the entire thing.
Yeah. So the distance from this force to the pivot is D1. So that's going to be F1 by D1. F1 D1. And I'm going to add that because I have another clockwise moment, right? So I have another clockwise moment generated by this force. So what's the distance from the pivot for that force?
D2.
So that's going to be F1 D1 plus F2 D2. So what's my answer?
D.
Yeah, my answer is D, right? Good. Question 9. A boy measured the height of a laboratory table. Which of the following measurements is most likely the correct one?
Wait, excuse me, what's the last option there? D was what?
D. F1 D1 plus F2 D2.
All right, okay.
The answer is C. All the other options don't make sense. Most tables are height of around 1 meter, so 0.895 meters. Okay. Which of the following readings is shown on the scale above? So we have to read a vernier caliper here. So the top scale will be the vernier scale. Sorry, what I'm saying? This will be the main scale, and this will be the vernier scale, right? So first, we're going to take the reading on the main scale. So we're looking to take the reading right before the vernier scale. So that would be right here. So here gone. That looks like 12 point what? So between 12 and 13, we have 10 divisions. So
right, so each one is 1.
Now each one is 0.1.
0.1. Oh yes, 0.1. Okay, that's what I meant.
12.1, 12.2, 12.3, 12.4, 12.5.
Yeah, that's what I meant. I just said wrong. 0.1.
So here on, right before the vernier scale, what's the reading? That's 12.1.
12.2.
Right? So for the main scale, we're going to have 12.20 centimeters. And on the vernier scale, let me show you how we're going to take that reading. So we're looking to see where it aligns with the main scale. This doesn't align here, doesn't align here. Nope, 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 nope. What about here? This is a line over there.
Yes.
And that would correspond to what?
12.9 centimeters.
No. Take your time. So let me explain something right here, Gun. The main scale would give you accuracy of 0 up to 0.1. The vernier scale will give you accuracy up to 0.01.
Right.
So this is 6 over here. And
Okay, yeah, that's 6.
so on the vernier scale, that's going to be 0.06.
Okay.
Let me explain this. So you see how the main scale starts at 12? Well, the vernier scale starts at 0. So that'll be 0, 1, 2, 3, 4, 5, 6. So the measurement here would be 0.06. So on the main scale, we're getting 12.20, and on the vernier scale, we're getting 0.06 centimeters. So you have to add it up. If you add up those two, we're going to get
12.26 centimeters B.
B, yeah. Let's move on to 11. Which of the following features must be present in a stable, well-designed racing car?
A.
It must have a low center of gravity, otherwise it have a chance of toppling over. Question 12. The unit for momentum is, so remember, momentum is mass by velocity. So the unit for mass is kg.
Newton meter.
No, take your time.
B.
So momentum.
C.
Yeah, it's C. Wait, let's say in C, no, it's B. It's B, watch. And velocity is ms minus 1.
Yeah.
Yes, sir.
Yeah, so it's kg ms minus 1, so it's B. What is ms minus to the unit of?
Acceleration.
That's acceleration, right? Yeah. So momentum is mass by velocity. Mass is kg, and velocity is ms minus 1. So be careful. Yeah, so just be careful, right? Hang on. Be careful.
Oh, yes, sir.
All right. Question 13. Wait, this I repeat. What's the answer?
C.
C. Question 14. A bubble of gas rises to the surface of a soft drink. This is because, so in any object, an object would have a weight, right? And the weight would be acting downwards. Now, if the upthrust is more than the weight, you'll remain with a net upward force. And so what I'm saying is, for something to rise to the top, the upthrust or the buoyant force needs to be more than the weight of the object, so that it will push it upwards. So like take for instance, this is 2 newtons and this is 5. So here on, after I take away the 2 newtons from the 5 newtons, I will remain with what?
3 newtons.
And that force could be acting upwards, and
Right, yes.
so you go push the bubble upwards. So for something to rise, the upthrust must be more than the weight. So which option corresponds to that?
That's B, sir.
B, the upthrust on the bubble is greater than the weight of the bubble. Yes. Akida, you understand? Can I hear an Akida? I trust in everybody okay with question 14. I'm going to move on. Question 15. Right. Given force is equal to mass times acceleration, the unit of force will be written as, so we measure mass kg, and acceleration is ms minus 2. So what's the answer?
E.
D. Question. Mass is kg, acceleration is ms minus 2. So kg ms minus 2. Be very careful. Understand? So let's continue. 16. Which of the following pair consists of fundamental quantities? So a fundamental quantity is a quantity that exists. There's no formula for it. So the first option is mass a fundamental quantity, yes or no?
Yes, sir.
Yeah, well, is weight a fundamental quantity?
No.
No, weight is a derived quantity because there's a formula for it. Right? To find for weight, you'd multiply the mass by the gravity. Okay, is mass and length fundamental quantities?
Yeah.
And time and current are also fundamental quantities. So yeah,
Yes, sir.
is D, 2 and 3. As the temperature of a liquid rises, what happens?
C.
C, yes.
The force is, yeah, C.
right? Because if you're increasing the temperature, you're adding thermal energy, and when you add thermal energy, you're adding kinetic energy as well. And so when you add kinetic energy, the particles are going to start to vibrate, and any other options like the forces of attraction will decrease would be correct. So yes, 17C, because the particles will start to vibrate more frequently. So the kinetic energy is increasing. Question 18. A metal of mass M requires energy E to raise its temperature from T1 to T2. The specific heat capacity of the metal will be given by. So what formula am I going to use here to find for specific heat capacity?
E.
C. So I have to use the specific heat capacity formula, right? That's E is equal to MC delta theta. Remember, delta theta is T2 minus T1. So if I want to find for C, I would have to divide both sides by M T2 minus T1. So at the start, I see somebody said the answer was D. D is not the answer. The answer is looking like C. C is the answer. Right? Is everybody okay with why C is the answer? So I'm just making C the subject of the formula. And any option that does not have T2 minus T1 in it is automatically wrong. So this is wrong. Where's the T1? This is wrong because it's supposed to have T2 minus T1. This is wrong because you had to divide by M to find for C. So the M should be in the denominator. So I'm going to move on to question 19 now. Which of the following ranges of temperature is most suitable for a clinical thermometer? What do you all think is the answer?
E.
D, right? D. 20, this is a repeat. Water is a poor conductor of heat. 21. The specific latent heat of fusion of water is 340 kilojoules per kg. This means that when 10 kg of water freezes, what happens? All right.
C, sir.
C? Yes, C is the correct answer, but let's just explain why. So, what's the formula for specific latent heat of fusion? The formula is E is equal to mLF. The mass is 10, and the latent heat of fusion is 340 kilojoules. So you're going to end up with 3,400 kilojoules. Well, let me ask you a question, right? If you are freezing water, are you absorbing heat or are you giving out heat? What do you all think?
Giving out.
Yeah, because if you're absorbing heat, ain't it becoming hot? So the answer has to be C. Some people would have put D as the answer. No, C. Be careful. This is a problem question. Just remember, if you're freezing, you're giving out heat. Okay, 22. An electric kettle full of water is plugged into the mains. The major process by which heat travels through water is? Let me hear, guys.
Convection.
It's convection, right? Because in the kettle, the water at the bottom is going to get really hot, right? Now, if the water at the bottom gets really hot, what happens to hot fluids?
It rises to the top.
It would rise to the top, and the cool water at the bottom would sink to the bottom, and that would get hot, and it would rise back to the top, and it would just repeat. So this is what convection currents would look like. So you have the hot water going to the top, hot water going to the top, water right. So that's convection currents. Nice. 23. Which of the following materials is both a good absorber and a good emitter of thermal energy? What's the answer?
D.
D is the answer, right? Why? Because black surfaces are excellent emitters of heat and absorbers of heat. Right? And metals, they are good conductors, so they will absorb heat. 24. When heating a substance, a point is reached when no further change in temperature is observed. The most likely reason for this is, what do you all think?
Changing state.
Change in state, right? That's the answer. Think of the formulas like latent heat of fusion and latent heat of vaporization. In those formulas, you don't have any temperature. And that's because when you go in from one state to another state, you need to restructure the atoms. The atomic structure will change, and that process requires energy. All right, so 25. Okay, go on. Read 25. See if you can figure out that.
To check the upper fixed point on a thermometer on the Celsius scale, the thermometer is placed in upper fixed point.
The upper fixed point of a thermometer is 100 degrees Celsius.
Right.
Yeah.
Is melting ice at atmospheric pressure?
No, if I melt ice, that's at 0 degrees Celsius.
No. If you melt ice, true. Is if you boil water at atmospheric pressure.
Okay, now I had to be very careful here, right? Now I feel like I have a divide here, but let me just show already. I'm going to show already the process by which you figure out the upper fixed temperature and the lower fixed temperature. Watch. So when we are trying to figure out the upper fixed point, you actually place the thermometer above steam. That's what you have to do. So it's actually C.
C.
Yeah. So steam above boiling water, because the temperature of steam is 100 degrees Celsius at atmospheric pressure. Yeah.
Okay, right. Boiling water can't be atmospheric pressure because it's not air. Steam is air.
I hear logic, right? I hear logic, but right now, everything is at atmospheric pressure. Atmospheric pressure just simply is the pressure exerted by being in the atmosphere, as it.
Okay.
Yeah, so anything could be at atmospheric pressure.
I took you understand.
Yeah, so steam is at 100 degrees Celsius. If you boil in water, the steam will always be at 100 degrees Celsius, unless you superheat the steam, which all you don't have to know about at this level. Right, so the answer is C.
Yes.
26. Who was responsible for arriving at the conclusion that measured amounts of electrical and mechanical energy can be converted to proportionate amounts of heat energy? We're talking about energy, so
D.
D, yes, right? Joules. Okay, Gunnar, we just measure energy in joules.
Yes, sir.
Yeah, so this one should be a giveaway. As soon as you see energy, it should be like joules.
Yeah, that's true.
All right. Two types of radiation, L and R, fall on a woman's left and right hand. Her left hand feels hot but does not become tan. Which type of ray carries the thermal energy? Is it ultraviolet or infrared? Or is it visible?
Infrared, sir.
Infrared. So L has to be infrared, and D is the only option that has L as infrared. So D has to be the answer. Let me continue though. Her right hand does not feel hot, but it eventually becomes tan. And ultraviolet rays is the harmful rays that could cause tanning and skin damage.
Yes, sir.
Yeah, so R has to be ultraviolet. Right? Anytime you see thermal energy, we're dealing with infrared rays, because infrared rays carry thermal energy. 28. Which of the following statements about evaporation is false? The answer is C. Evaporation could technically happen at any temperature, so long as it's not freezing. Think about it, right?
So you said so long as it's not what?
Freezing.
Okay.
It's like 0 degrees Celsius, right? Think about it. And if you spill water in your freezer, like I'm talking about the bottom compartment, right? if you spill water in your freezer, would the water stay there? Or like if enough time passes, it will evaporate.
Yes, sir.
It will evaporate, right? So evaporation could happen at nearly any temperature. So C is a lie. Evaporation does not only happen at room temperature. And think about it, and all of our rooms would be different temperatures, but water does still evaporate in it. So that's a lie. That should be a giveaway as well. 29. This is a repeat. Akira, if you're here, somebody answer. Don't think Akira is here. Somebody tell me, what's the answer for this?
B, sir.
B, C to E. And C to E is an example of two successive what?
So it's
Compressions, right? Because the slinky is compressing at these points. And at these points, the slinky is refracting. So it's spreading out. So 30. Which of the following statements is true of a diverging lens? Divergent lens. So let me just draw a divergent lens. Yeah, A is correct. So yes, a divergent lens is thinner at the center than it is at the edges. So the answer is 30E. Right. So Hagan, yeah, okay with this question?
Yes, sir, okay with this.
I could give an example of something real quick.
Yes, sir.
Divergent lenses. Do the light rays converge or they diverge?
Diverge.
They diverge, right? So let me give a little example. So when you're doing a array diagram for a divergent lens, you have to follow two rules. So I just showed you a quick example, right? Let me just say this was the focal point here. The first thing I would do is I would draw a light ray that's parallel to my principal axis. And then I would take my ruler and align it with the point of intersection with the lens and the focal point, and I would draw a line. And that would show me how the light ray is going to diverge from the lens. So this is what I mean by that. And the other rule I'm going to use, I'm going to draw a light ray that's passing directly through the optical center, and it would not be refracted. So guys, this is what typically happens when you're dealing with a divergent lens. You have the object over here. This is the object, and the image will be over here. I should probably use different colors. So this is the object. Just going to call it O, and this is the image. So guys, based on what you're seeing here, the image that is formed, is it real or is it virtual?
Virtual.
Right, so D is wrong. Is the object inverted or is it upright?
Upright.
Upright.
It's upright. Yeah. So then this is wrong as well.
And also not enlarged.
It's not enlarged. So you understand why I say the answer with A, right? All the other options are wrong.
Yeah.
31. So we have a plane mirror over here. Anytime you have a plane mirror, you're gonna have reflection, right? So the reflected object is gonna be like this. So this is the image. Yes or no?
Yes, sir.
So my answer is B. B is my answer. 31B. 32. Which of the following statements about sound is not correct? Let me hear, guys. What do you think is the answer?
C.
C. Yeah, that's not correct. Sound is an example of a what kind of wave?
Longitudinal.
Right. Right. It's not a transverse wave. And it's also a mechanical wave. Take note of that. Right. 33. Would you like me to go through the other options, or like all you understand is not all you understand that this is not a transverse wave? Let me know.
So what do you mean by mechanical wave?
So okay. And you understand for sound to be traveled, for sound to travel, you understand that it has to vibrate particles back and forth. Think of a speaker. When a speaker, like one bass, we're going to have a real bass, and as we shaking up the place. Yes or no?
Yes, sir.
So if there's plenty bass, you just feel it, right? And you just feel the wave, you just feel it. So mechanical means there's a movement. There's a movement of a medium. So for sound waves to propagate, it needs to move, it has to displace air particles. That's what I mean by mechanical. Mechanical waves need to move a medium for it to propagate. Light waves is not like that. You understand what I mean?
Sir.
So mechanical just means a movement. Yeah.
Okay, sir.
Like, Jilla, do you feel light waves? Or you see them?
See them?
You see them, right? And because you don't feel it, it's not a mechanical wave. Simple as that. But you feel sound waves, so it's a mechanical wave. Right. Question 33. A ray of white light enters a transparent glass prism. In which of the following diagrams is the dispersion of light correctly illustrated? So any diagram that does not have Roy G. Biv is wrong. So automatically this is wrong, this is wrong. And I'm asking a question. Do you all think the light would split outside the prism or inside the prism? What make more sense?
Inside.
Yeah, inside. Light would split inside the prism. It wouldn't split on the outside. So the answer is 33E. Cool. Let's move on. 34. Which of the following properties is true of both light waves and sound waves? So option A is wrong. Only light waves are electromagnetic waves. Option B is wrong because only sound waves are longitudinal waves. C is wrong because sound waves cannot travel in a vacuum because there's no propagation of particles in a vacuum. Right? So the answer is D. Both light waves and sound waves undergo refraction. Yeah. We okay with that? 34D? All refraction means is we're going from one medium to another medium. That's all. So when sound waves travel in it, so let me give you some examples, right? An example of refraction for light waves is a laser going from air to glass. That's refraction. An example for sound waves is music playing from a speaker and it interacts with a solid surface. Right? If you take your ears and you place it against the solid surface, you'll realize that you're hearing the sound. And that's because sound is going from the air to the solid surface. That's an example of refraction. 35. This is a repeat. For bright fringes to occur, you must have what? What kind of interference?
So it's B.
You need to have constructive interference, right? And in constructive interference, the waveforms are in phase. So it's, you said it was B or C?
C.
Okay. How much of you guys say in B? Because B is wrong. For bright fringes to be formed, you must have constructive interference.
So it's C.
Is C right? C says all the crests and troughs are in phase along these points. So
you say in phase is the keyword as the last question we did the other time.
Yeah, in phase is the keyword. If the waveforms are in phase, then it's constructive interference. Let me just make a little note. So dark means out of phase. Bright means in phase. If you are out of phase, that's destructive interference. And if you're in phase, that's constructive interference. Okay, let's move on. 36. A ray of light leaves the air and enters glass of refractive index 1.5. If the angle of incidence is 37 degrees, what is the sign of the angle of refraction? So can somebody remind me What is the formula for refraction?
N is equal to sine I over sine R.
Right. Where I is the angle of incidence and R is the angle of refraction. So the refractive index here is 1.5. I'm going to write 1.5 over 1. You'll see why. The angular incidence is 37. So that's 37 here. And we don't know what the angular refraction is. So I'm going to leave this as sine R. What I'm going to do next is I'm going to cross multiply. If I cross multiply, I'm going to end up with 1.5 sine R. And that's going to be equal to 1 by sine 37, which is sine 37. Now, they wanted us to figure out the sine of the angular refraction. So they want me to figure out for sine R. So to find for sine R, I would have to divide by 1.5 on both sides. So sine R is going to be sine 37 over 1.5. So Hagan, what's the answer?
D is 0.4. Oh, yes, it will be. Oh, let me check it out now.
So it's not D?
It's D. Yeah, it's D.
It's D, sir.
Yeah. Hagan, watch.
No, sir, understand. I'll just calculate it.
Oh, you didn't know how to calculate anything, huh? Because they give me the answer in exact form.
Shucks. I know catch.
Yeah.
I was looking for an exact figure.
No, they wouldn't do all of that because I don't think calculators are allowed for physics paper 1. Yeah. Which of the following objects can detect X-rays? Yeah, somebody was saying something?
Are you sure it's not allowed?
Let me check. Let me check real quick.
Because it has to be sine.
Oh, yes. You could use a calculator.
Okay.
The one subject you can't use a calculator for is maths. Maths. Yeah. I'm sure about that one. You can't use a calculator for maths. You use it
No,
for
sir,
maths.
it's not. Oh, yeah, probably maths. Yeah, just maths.
You can't use it for maths. You can use it for hard maths, though. Right, which of the following objects can detect X-rays? The answer is photographic film. Reason for that is because photographic film, if you expose it to visible light, an image develops. And you need to understand that visible light is part of the EM spectrum. And so X-rays have the same properties, right? So they would also affect photographic film. Wait, could you stop putting dots on the screen?
Sorry, sir. No accident.
Oh, okay. All right, to the 8th. A note from a drum is louder when it is struck harder because the sound waves produced have a greater what?
Amplitude.
C.
Amplitude, right? When we talk about loudness, we're talking about amplitude. Right, to the 9. Which of the following phenomena are exhibited by sound waves? So all 3. So sound waves could experience refraction, they could experience diffraction when passing through a very narrow slit, and they could also experience interference. An example would be the question I get this year. And the question this year was, you had to move from one end to the other end and explain why it would have like soft parts and loud parts. You know what I'm talking about?
Yes, sir.
At least you know what I'm talking about. And the reason for that was at some instances you'd have constructive interference and some instances you'd have destructive interference. All right. So question 40 is a repeat. What's the answer?
A.
A is the answer, right?
The answer is A.
41. Which of the following symbols represents the AND gate?
B.
B.
B, sir.
B. A is a NOT gate. C is an OR gate. And D is a NOR gate. I mean, what's it as a NAND gate, right? It's a NAND gate. Let me just explain something real quick. You see a little circle? Anytime I add that circle, I'm just going to attach an N. So you see this? This is an OR gate. What would this be? It'll be a NOR gate. Simple. Right? So why do I call this a NAND gate? It's because this is an AND gate. And so if I attach the circle, It will become a none. I trust that everybody okay with that.
Yes, sir.
Okay.
Yes, sir.
Which of the following relationships between electrical quantities is correct? The only correct one here is Q is equal to IT. The correct one for this is P is equal to IV. The correct one for this is V is equal to IR. And the correct one for this is E is equal to VIT. 43. Which device allows one circuit to switch another circuit on or off without any direct contact between them?
Magnetic.
A relay, right? Think about it. And if I tell you a message and I will say, I relay the message to you. So didn't I transfer the message? Didn't I carry the message? So you can think of it here. This is kind of like the same concept. But magnetic relay allows you to switch one circuit on or switch it off. So it like carries the message. In the YouTube video, I have like a full explanation. Basically, what a magnetic relay is a coil that when you supply power to it, it develops a magnetic field, and that magnetic field causes the armature to be attracted, and that closes the circuit. If you de-energize the circuit, the magnetic field becomes undone, and so the armature returns back to its original position. And so the circuit becomes open again. That's the basic principle of a magnetic relay. Right? Okay, 44. Hagan, help me with 44. The 44 I read. You should
glass rod
for this one.
Yeah, a glass rod is rubbed with a piece of silk and is positively charged. The glass rod became charged by.
Yeah, you understand what I'm calling you for this question?
Yeah, because I said I didn't like chemistry.
Yeah.
We gained protons.
No, they can't gain protons.
No. Hold on. We lost electrons.
Right. That is what I want to hear.
We lost electrons because electrons are negatively charged, and if we lose electrons, you obviously get more positively charged.
Well, you wouldn't gain positive charge. You will lose negativity, and if you lose negativity, you become positive. Yeah.
Yes.
Right. Cool. Glad I remember that. Right. So Hagan, let me answer question 45, right? So when an excessive current passes through a fuse, which of the following is a sequence of events? So let me just draw a fuse here, right? So this is what fuses look like.
Yeah.
Inside a fuse, you have a very thin wire. And so effectively, if you pass a current that it's not rated for, what is going to happen? Hagan, do you know?
If what happened?
If I apply a current that exceeds the fuse rating, what's going to happen to the thin wire on the inside?
It will dissolve.
They wouldn't dissolve. It will heat up.
It will heat up.
It will melt, and it will break the circuit.
It will melt, yes.
And if it melts, it would break the circuit, right?
Yeah, it will.
Sure, what I mean by that.
But if it melts in the center, the other two ends wouldn't be able to connect, and then obviously the circuit will break apart.
Yep, that's exactly what's gonna happen. Right, so here you're gonna get to it. Right, so you can see that that's what fuses, and if you apply a current that's surpasses the fuse rating, the wire on the inside is going to get hot, right? Then it's gonna melt. Then the current is gonna cut off because it breaks the wire in the middle, breaks the continuity of the circuit. So which one corresponds to that?
B.
B.
So the wire gets hot, the wire melts, and the current is cut off. Cool. Gonna move on now. 46. Which of the following current time graphs best represents a DC current? Now, easy answer. And let me see how bad it is. This is the current you get right after what? Right after what? That's what R. Before you put a smoothing capacitor or a decoupling capacitor. Does anybody know?
Sister?
Say that again. Okay,
So somebody in the comments said rectification.
that's correct. So this is what the waveform would look like immediately after full bridge rectification. Before you apply smoothing capacitor, and when you apply the capacitor, it's going to turn to this, which looks more typical of a direct current. Let's go through why all the other options are wrong. Kamaria, am I saying it incorrect?
Yes, sir. Shockingly.
Okay, people let's say that wrong.
Yes, sir. They say all kind of madness, like Chimeria, Camaria, all kind of madness, sir.
I saw plenty of people, they just call it Maria.
So I didn't even respond to it.
All right, so I wouldn't call it Maria, right? So in a direct current, the current is always constant. What do I mean by that? If the current is positive, it's always positive. If it's negative, it's always negative.
Mm.
If it isn't always positive or it isn't always negative, it alternates. So let me show you what I mean. So over here, the current is positive or negative?
Positive.
Over here, the current is positive or negative?
Negative.
So you see that alternating between positive and negative.
So it's AC.
So this is AC because it's alternating. Over here, this is positive.
Positive. And it'd be negative. So all yours is just AC then.
Yep. Watch. But over here now,
it's just positive.
It remains positive. It remains above the x-axis, so it remains positive.
Right.
Yeah. Okay, that's it. All right, 47. So appropriate labels for device W and input X are. So let me count the amount of turns we have in the primary. So how much turns it look like we have? How much turns is this?
3.
3, sir.
So we have 3 turns in the primary. How much turns do we have in the secondary?
4.
4.
So where we have more turns?
In the secondary.
So this is our step up or step down?
A step up.
A step up, right? Because the more turns you have, the more amount of times it's going to cut the magnetic flux. And if you cut any magnetic flux, the induced EMF is going to be more. Faraday's law. All right. But for other level, all you just had to know that, okay, if it have more turns, step up. If it have less turns, step down. Yeah. So the answer for this is going to be C. Now, I don't know if all came to the crash course I had for physics, but I made sure and explained that in a transformer, it could only work with alternating current. So it must have an AC input. Transformers don't work with direct current. They don't. Because you need an alternating current to produce a change in magnetic field. Again, Faraday's law. So, Camaria, understand why the answer is C?
Yes, sir. They pronounce it wrong now.
How? What?
They don't say Camaria.
Camaria?
No, it's Camaria.
I don't know how I pronounced it correctly first time, and then maybe it's how we had a conversation about how people were saying it wrong, and maybe that is why.
Yes, sir.
So, Camaria.
So you're still saying it wrong. It's not Camaria, it's Camaria.
Camaria.
Yes, yes.
Right? Yeah. Tama. Wait, Akira, that is you. Where you
I
was?
just
Where you
rejoined.
was?
You could explain.
Where you was?
So I had to deal with a situation with my parents, and then I went and bathed one time. So yeah.
Oh. Everything okay though?
You can explain. Yeah, we're good now.
Okay,
It was
good.
just something to do with school.
Tell them you was
We
doing
could go over
schoolwork.
that last question.
What is question 47?
Yeah.
Okay, so a transformer is a step up when the number turns in the secondary is more. So watch. What's the number turns in the primary?
3.
And where's the number turns in the secondary?
4.
So where's the number turns more?
Secondary.
So that means at the secondary, we're going to get a greater voltage, a higher voltage. And so that's stepping up the voltage, increasing the voltage. So,
Yeah.
This transformer is a step-up transformer, and transformers require an AC input to work. So X has to be an AC input. Transformers do not work with direct current inputs. You
Okay.
burn down the house if you do that.
Okay, sir.
Yeah. Guys, I know I have like massive transformers. Like in my room, I just have like massive transformers, like that weighing like 20 pounds. Just like there.
Isn't that dangerous?
No,
Said
no.
why?
No, it's not dangerous. It's not dangerous. I'm like one of those crazy
Sir,
electrical
can we
engineers.
see? Please.
I will send a picture after. When I give a little break, I'll send you a picture of one of the transformers. Yeah. I have a bunch of transformers.
So why you just have a bunch of transformers in a room?
I'm an electrical engineer, like actually like
Oh, okay.
I love electrical engineering.
So you just feel to keep it in your room.
My room is like my lab, you know? I do all my experiments.
Right. Very unethical.
Very what? Unethical?
I say that's very unethical.
How is that unethical?
So why is your room your laboratory?
Because I don't have a dedicated space for my laboratory other than my room.
Oh, okay.
He goes sleep. He goes sleep.
Because
So Kamara, what idea blow up yourself?
Guys,
yourself alone.
in all
I feel like the whole place gonna blow up.
in all my however years of experimenting since I was like 5 with electronics something, I never get shocked once. And I never created a fire once. Never.
So the black
Really?
Guys, no need to worry. I'm sure
Don't
Sir
worry.
is capable of
Well, I'm
doing
not even
things
hating
like
though.
that stuff.
I just this is about safety
Okay.
precautions.
No, don't worry, don't worry. I'm
He's
fine.
in.
I'm fine. I'm fine. But I could create intentional bombs. Like at time I did create intentional bombs, but I detonated it in a open space. No one think I
So should we be worried?
I is not terrorist.
So you can teach us, please.
So I wanted to
Any
learn how
purposes?
to make a bomb recently, you know.
What's
Here what? The simplest bomb you could make is just hook up a capacitor in reverse. Or just go past the voltage rating.
So why are we teaching students how to make a bomb?
I see.
Oh god, oh god, oh god. I incriminated myself. Well, this is part of physics, you know. This is part of physics, right? It's part of physics because a capacitor is made up of two differently charged plates. And if you reverse the polarity of current going into it, it will blow up. That's physics, you know. That's physics.
Alright, so
Physics.
here what I'm gonna do, right? When I go to school Friday, I'm gonna blow it up.
Where you gonna get a capacitor
Okay,
from? Where
And then
you
I'm
love
gonna
that
tell
idea.
them, that the teacher on the Zoom, he told
Wait.
me how to make a bomb and he told me I should try it and that's
I
what I did.
never say try it. I never say try it, boy. Hey, don't get me in trouble, boy. But after this session, I'll show you some of the electronic things I made. I made like amplifiers and power supplies and switching circuits and things.
Okay. Then now we hurry up this session to see all those stuff.
Yeah, like my previous physics classes, like when I was doing the electrical part of physics with them, I would have showed them actual demonstrations in real life and things. And I'd get them like handle experiments with the electrical components, like the diodes and all that. Yeah. Like I could show all you these waveforms in real life if I wanted to. Like I could show you it in real life. I could make the circuit and show you the waveforms. Yeah.
I'd love to see that.
Telling you, one day I will have my own school and I'll be showing kids like practical examples, not reading from our textbook. Yeah, you'll see it for yourself. Right?
Using an oscilloscope.
Say that again?
Sorry, you're talking about using an oscilloscope.
Yes, I have an oscilloscope.
Okay.
Yeah. Sound like you want to be an electrical engineer as well. I'm gonna go into, well, in my final year, I'm gonna move on to, I'm gonna specialize in power systems, like transformers and things. Yeah. Or I might do a double major with electronics and power systems. Right? So I trust that everybody understand the transformer question. Let's look at 48 now. So what is the period of the current? Or you should know this by now. Period is just the time it takes for one oscillation. So what's the time for one oscillation there?
Say A. 2 seconds.
4 seconds.
4 seconds.
B.
Okay, Maria, I say name is correct this time, right?
No, sir. No,
What?
sir. Oh my God, say butchering it.
Here, I'll just call you. I started pronouncing the name correct, and then I don't know what
So
happened. It
just
was like
say
a decay curve. It was like a decay curve. That's what it was.
yes, sir. So just say Kyle or something. I don't know.
I was say key,
All
right?
right.
I can't mess up that. So, K, you said 8. Oh, how you saying 8? How much
Son was say,
oscillation is it?
son was say, no, sir, I didn't say it. I slip up and I said A, which is 2 seconds. But I forget that it's supposed to be for like a full oscillation. So that's why I slip up.
Okay. We have 2 oscillations here,
Mm-hmm.
right? So I want to say name correct, I just say Miss Baptiste. Right.
So you didn't even say my last name. All right.
Oh my God. Okay,
So
so
it's not Baptist, it's, it's Baptiste.
but it says BAPTISTE.
Yeah, but it's not Baptist.
See me as a math slash electrical engineer. I
So
specialize.
you had to get a little, you had to take a little side course in phonetics.
Yeah, I really think I should. I really think I should. Yeah, so if you wanted to do what you was doing, then 8 would be for 2 oscillations, and so you'd have to divide that by 2 to find for 1 oscillation. But if you do it the normal way, 1 oscillation is just 4 seconds. So that's the answer. 4 seconds. Right, 49. An ideal transformer has a primary to secondary turns ratio of 1 to 3. Oh yeah, I need your attention for this one. This one kind of tricky. So an ideal transformer has a primary to secondary turns ratio of 1 to 3. So we should be thinking about a specific formula. If I'm talking about the turns ratio, what formula am I talking about? Somebody tell me.
So something with V over.
So P1 over V1 equals P2 over V2.
What? Nah.
No, it's something with V and N or something like that.
Is NS over NP is equal to VS over VP.
Oh, right.
And so according to this ratio, it's 1 to 3, right? And so primary to secondary. So primary to secondary. So how much turns we have in the primary?
1.
1, so that's going to be 1 all over. How much turns we have in the secondary?
3.
Wait, it's supposed to be 3 over 1, right? 3 over 1. Yeah. 3 over 1. So look at what we're doing, right? So the turns ratio, which is primary to secondary, is 1 to 3. So we have 1 turns in the primary and 3 turns in the secondary. So that's going to be NS is 3 and NP is 1. I hope all you understand that.
Yes, sir.
And they're saying an alternating potential difference of 200 volts is applied to the primary coil. So that's VS or VP.
VP.
Right? So VP is 200 volts. And a resistance of 200 ohms is attached to the secondary coil. So on the secondary side, we have a 200 ohm resistor. So that's what we have. So guys, do we know the voltage across the secondary coil? Yes or no?
No.
No, well, we could find it. So I could cross multiply. If I cross multiply, that's going to be 1 by VS, which is just VS. And 3 by 200 volts is
600.
So we have 600 volts across the secondary. So we have the voltage across the secondary, and we have the resistance. So can we find the current for the secondary circuit?
Yeah.
So remember, V is equal to IR, and so I would be equal to what?
V over R.
V over R. What is the voltage across the secondary side?
600 divided by 200, which is 300.
Right, so answer is D. That's how you work this question out. Yeah. Hard or like manageable?
Say it was manageable.
Okay, cool. Keegan, hard or manageable?
That was easy.
That was easy. Okay, I hope you get it correct. Like if they change up the numbers, I hope you get it correct.
That's I will get it correct. I'll get it correct.
Okay, cool. Does anybody want me to run through back the question or you're good?
Me?
Yes, sir. Go through it.
Okay, so they're saying that the turns ratio, which is primary to secondary, is 1 to 3. So Akida, primary to secondary. So how much turns it have in primary then?
1,
Right? And how much turns in the secondary?
3.
So NS would be what? That means the number turns in the secondary. NS would be what?
3.
And NP would be?
1.
Right. So you understand how I get 3 over 1?
Yes, sir.
Okay, and that will be equal to Vs over Vp. At any point in time, did they give us the voltage in the secondary side?
Nope.
No, they said that we're applying a potential difference of 200 volts across the primary. So the primary voltage is 200. So that's Vp. So 3 over 1 is equal to Vs over 200 volts. So I want to find for the secondary voltage. Before I could find for current in the secondary, I need to figure out the voltage across the secondary. Yes or no?
Yes, sir.
Right. So I would cross multiply. And if I cross multiply, it's going to be 1 by Vs, which is just Vs. And it's going to be 3 by 200, which is just 3 by 200.
600.
Right. So the voltage across the 200 ohm resistor in the secondary is 600 volts. Yes or no?
Yes, sir.
So we have the voltage across the secondary and we have the resistance. So to figure out the current that's going through the 200 ohm resistor, I'm going to use V is equal to IR. If I make I the subject by dividing both sides by R, I is going to be equal to V over R. So the voltage is 600, the resistance is 200 ohms, and so 200 into 600 is 3. So 3 amps. That's it.
Okay, I understand that. That was simple,
Yeah, it's not bad. Just look at the turns ratio. Okay, and for those of you that are very good in the electrical part of physics, I'll show you a shortcut. So the turns ratio is 3, because 3 over 1 is 3. So what does that mean? That means whatever voltage you have on the primary, you just multiply it by 3. So since the turns ratio is 3, I could just multiply 200 by 3, that's 600 volts, and say 600 over 200, and I get my answer one time. Yeah. 50. Which of the following combinations of ammeter characteristics is correct? So we should be able to answer this. Ammeter. How is an ammeter hooked up in a circuit? In series or parallel?
In series.
And is it have a high resistance or a low resistance?
Low.
Low, because current has to pass straight through it. So the answer is?
The answer is B?
Yeah. So low resistance and in series. Okay, this question is a nice question. I have a very common sense approach though. Let me ask you a question. Where would most current flow? Through a higher resistance or lower resistance?
Lower resistance.
So if 1.8 amps passing through the 4 ohms, you think more current go pass through the 6 ohms or less current?
Less current will pass.
Less current.
So where's the only option as less than 1.8?
Share over, sir.
1.2 is the low option.
So let me say it over one more time. So what I'm saying is, in any circuit, current will take the path of least resistance. So what I'm saying is, if you have a lower resistance, more current will pass through that route. If you look over here, the resistance is more, it's 6 ohms. So do you think more current will pass here or less current?
Less current.
Less current.
Less current. And the only option that has less current is 1.2. That's your answer one time.
Yeah.
Although I'm going to show you the calculations or? Tell me.
So we understand.
Yes, sir. I think it's understood.
Okay, wood. Right, 52. The best material for the core of an electromagnet is iron. iron. Right? Everybody okay with that? Typically,
Yes, sir.
it is be soft iron. Right, 53. Given that the potential difference across the lamp in the circuit is 4 volts, what is the potential difference across resistor E? So guys, these two resistors are in
Parallel.
parallel. Anytime you have a parallel connection, the voltage across will be the think of your house. Your house is wired in parallel, and all the outlets will give you the same voltage.
Yes, sir.
So what it means is all these resistors are going to have the same potential difference across them. That's what it means, right? So here we're going on. I'm going to introduce all to something called KVL, Kirchhoff's voltage law. And it basically says, so guys, watch. In this circuit, NP supplying 12 volts.
Yes, sir.
So if 4 volts is dropped across the bulb, how much voltage is dropped across the resistors?
3.
3, no, 8. That makes sense. So Kirchhoff voltage law says that the source voltages, when you add up the voltage drops, it must be equal to the source voltage. So I like you to understand that the circuit is we have a battery supplying 12 volts. The bulb has a potential difference of 4 volts, is using up 4 volts. And so the other 8 volts will be dropped across the resistors. That's what's going on.
Oh, okay, sir. I don't understand.
Yeah. So energy has to be conserved. So 4 volts drop across this, so 8 volts drop across this. And because they're in parallel, the voltage is going to be the same for A, B, and C. So your answer for this one is going to be
B.
B, right? Because 12 minus 4 is 8.
Can you also say it's because the lamp is in series with all the resistors and the series voltage is shared?
That's KVL. That's KVL.
Oh, really? Huh.
Yeah, that's when you go, you plan on pursuing electrical engineering. Rachel, yes or no? Nah.
Pardon?
Say that again?
You said something?
Yeah, I was asking if you're going to pursue electrical engineering.
Not really. I haven't thought about it.
So let me know if it's fun. Is it a fun field?
Say that again?
I was asking if it's a fun field to get into.
Well, I love electrical engineering, so I would say yeah. Yeah. Like I
So
said,
like calculation earlier, so of course you like electrical engineering. You like calculations.
I sure the calculations we started doing electrical engineering, like a ball. Like a ball. Like cool, like it's crazy. But it's fun, it's fun. So yeah, the answer is 8 here. So I hope you understand it. 4 volts is dropped across the bulb, and so the rest of the voltage will be dropped across the resistors. 8 volts.
So 54 looking like a repeat question.
Yeah, 54 is a repeat question. They're going to be positive charge and not very penetrating for alpha particle. Isotopes of an element differ from each other in that they have a different number of
neutrons.
Neutrons, right? Let me show you how isotopes will typically look. So I'm going to show you all an example using carbon 12 and carbon 14. Wait, notice that the mass numbers are different, but the atomic numbers are the same. I want you all to remember that the mass number,
It's just the number of protons and neutrons.
Right? And the atomic number is just the number of
protons.
Right. And so if I wanted to find neutrons, I would just subtract the atomic number from the
mass number.
So this would be 12 minus 6, which is just 6 neutrons. And this would be 14
minus 6, which is 8.
So the only difference between isotopes is that they have varying number of neutrons and the mass numbers are different. Yeah. Take a note of this, right? They like to bring questions like this. Right, 56. Let's repeat. What's the answer? Well, I have the answer here, but Akira, and you know the answer is D?
Yes. Oh. Okay.
Yes, sir.
Okay, cool. 57. Which of the following scientists formulated the equation E is equal to mc squared?
D.
Big up Iman.
That's a giveaway question.
Yep. Right. 58. Which of the following statements about radioactive decay are correct? So why do elements need to undergo decay? Elements would need to undergo decay when the nucleus is not stable. So when the proton to neutron ratio isn't 1:1. So yeah.
I might say you're still explaining.
So I'm saying the main reason for radioactive decay is because of what happens on the inside the nucleus, right?
So it's just 2 and 3.
Yeah, because 1 would be wrong because that talks about the external conditions outside of the nucleus.
Things like temperature, etc.
That really affect it. The main reason why radioactive decay does happen is because our element, once it becomes more stable, so it needs to either emit an alpha or beta particle to become stable, more stable. Right, so the answer is 2 and 3. It is a random process and it is due to changes in the nuclei of atom. So 2 and 3 is the correct answer, 58C. 59 is a repeat. Which of the following statements about radioisotopes are true?
C.
C. They are sometimes used in medicine. 60. An isotope of uranium 2^92U changes to thorium, which is 230.
I want to say is A.
Yeah, it's A because remember the left hand side had to be equal to the right hand side. And to make this valid, this would have to be 4 here and this would have to be 2. And that represents an alpha decay. Well, alpha emission. So it emits an alpha particle and so it undergoes alpha decay. For anybody that don't understand what I'm saying, right? Watch what I'm saying. It goes from uranium to thorium. And so where did the 4 go from the 2 to the 4? And where did the 2 go from the 92? It was emitted as 4-2. And 4-2 we should know as an alpha decay. Akira, yes or no?
Okay, I understand is an alpha decay, but why would we consider alpha decay?
Okay, so here on watch, right? Before we had uranium, what was the atomic mass here? I mean, not the atomic mass, what's it? The mass number. What was the mass number?
234.
And what is it after the decay?
It's 230.
So how much should have lost?
You lost 4.
Okay, let's continue with this pattern. What was the atomic mass initially?
It was 92.
It became?
90.
So how much did it lose?
Lost 2.
So what represents 4-2?
That's possible. Both of them are positive values.
No, you should remember that 4-2 means alpha.
It's just
Watch.
Oh, okay. I remember it now.
I think I'm supposed to have a note on that somewhere. We went through that somewhere. Yeah, watch. Alpha is a 4-2 helium nucleus in nature. Beta is a electron in nature, 0 minus 1.
I know it now.
Yeah. So that's it for this year.
All right, so should we
So
only
you're gonna send the
stuff in the
paper?
room?
Yeah, gonna send the people now. Right?
So we could see all the cool things in the room, like the transformers. Please.
Okay, I'll send a picture of a transformer. Right. Let me just send this first. Are they all like a 5 minutes break or straight into the other year?
5 minutes.
5 minutes?
5 minutes.
Okay, take a 5 minutes break. I will send everything in the meantime. I find like this year didn't really have much repeats. Honestly, didn't really have much. Wasn't hard though. All right. Chloe, here what? Send me a message at 7842630. Right? Let me just send a message and I'll add it to the chats. So 784. Just for the country code in case.
Excuse me, sir.
Yes, hello? Yeah, let me know if you hear me.
Yes, sir. What time is it over there?
In Trinidad, it's 8:04 p.m.
So
So,
we'd finish 10 o'clock at your time?
so come back in 5 minutes. So just time 5 minutes from whatever time it is in Jamaica. I think in Jamaica, right?
So what time you just now say it is?
I say it's 8:04 p.m. here.
So it is
So it's
7:57.
8:04.
Wait, why I say that? I looking at my iPad. My iPad is just shipping us. I would have.
Okay.
Yeah, it's 8 o'clock here. It's 7:58. I don't know wrong with my iPad.
Sir, so the meeting will finish at 10 o'clock in your time?
Say that again?
The meet will finish at 10 o'clock in your time?
Yeah, in Trinidadian time. 10 o'clock.
Okay.
Yeah.
Okay.
So join back in 5 minutes from now. 5 minutes from now, join back. Just time 5 minutes from now and come back. All right, guys, I'm gonna follow you back.
I'm here.
Okay, word. Right. Just let me know if the others there. So guys, if you're here, just unmute and let me know you're there.
Yes, sir.
Yes, sir. Yeah.
Okay, word. I'm gonna share my screen. Akira, do you see the transformer? Wait, Akira, aren't you in the group chat?
On the screen or on the chat?
On the chat.
Um. Oh wow.
It's not looking that big, right? It's not looking that big, but trust me, it's big.
It's interesting, that's for sure.
Yeah, that's an example of a step-up transformer. So that takes 120 volts and steps it up to 240. Yeah.
That little thing.
Yes, it's not a little, trust me.
Okay.
Yeah. Like, let me give some like size comparisons. Like, okay, watch. All right, so did anybody ever try 2023 as yet?
Yes, sir.
I only did 2025 January and 2024.
You did 2025 January to 2024 so far? Isn't that like what we did in class?
Yep.
That's crazy.
Basically.
That's
So,
very
so
yeah. Yeah. Somebody was saying something? Yeah, but if somebody was saying something, but
no, sir.
okay. Yeah, so Akira, watch. So
Oh, that's actually very
so like the over there they have two transformers. So these so they have a small one. So you see like the regular size of typical transformers as be used in electronics. And then I have this one. So
oh wow. A sizable difference for sure.
yeah.
Oh, I feel like something my friends would make. Oh, it was difficult to make.
It's typical. I mean, it could make a transformer, but you typically buy it because it cannot tedious to
Okay.
make. Because you would imagine, okay, a transformer is like have windings, right? You just have coils to like manually sit down and make the coils stick like real like wrap the coils stick real long. So you typically just buy it.
Okay, so good job. Very impressive.
No, I didn't make that transformer. I just have it. But the second thing I sent you know is what I make that. But that's a real simple circuit. It's what's a capacitor?
A
No,
capacitor.
there's not a capacitor. I don't know why I said that. There's a full wave rectifier. It's a full wave rectifier. You see four diodes?
Yeah.
So that converts the alternating current to direct current. That's always actually
Okay. Sounds very complicated.
no, it's literally just four components as well. Literally just nothing complicated about it.
Okay, so
Yeah. All right, so let me continue. So as soon as I see the screen, I'll go let me know. Right. So question 1. 3.1415926 expresses two significant figures is so we have to run it off the two
A.
significant figures. So the answer is A. Why is it A? The first significant figure is 3, the second one is 1. a number after 1 is not 5 or more, it's 4, so we round down. So that's why we see in 3.1. Question 2. What is an example of a vector quantity?
C.
C, displacement, yes. Does anybody know why displacement is an example of a vector quantity?
It has magnitude and direction.
Exactly. So guys, if I displace something, and I could displace something really in any direction, let me give you an example. Let me just say I have this block here, and I could take it and move it to the left, or I could take it and move it to the right. Yes or no?
So
if let me just say the left is negative, so this could be -5, and this could be +5. So this is what displacement means. Displacement means to move something from its resting position or original position. Move something from its original position. Right. Part 3. Which of the following instruments is suitable for measuring the diameter of a human hair? What do I think I should use?
Micrometer.
The screw gauge. Why do you screw?
Right, I should use the micrometer screw gauge because let me tell you some information here, some facts. The average human hair is about 0.06 millimeters to 0.10 millimeters. Yeah, that's really, really thin, right? And so we need a region of micrometers here. So a micrometer screw gauge, it could measure up to the highest degree of accuracy is 0.01 millimeters, right? That's the degree of accuracy you can get from a micrometer screw gauge. So let's see why it makes sense to use a micrometer screw gauge, right? And it typically measures the range is 0 millimeters to 25 millimeters. It's like the typical range of a micrometer screw gauge. Right. Question 4. What should be the magnitude and direction of a third force which will cause the object to remain stationary? So we have a force X pushing it to the right. We have a force Y pushing it to the right. So could somebody tell me what the resultant force would be? Since both of them are pushing to the right. It would be X plus Y, right?
Yeah.
Okay. And so if I'm pushing
This
X plus
question
Y.
does repeat a lot.
What's it again?
This question does repeat a lot.
Yeah, apparently. Well, I never see it in the other years, but there were other force questions. It's the same kind of concept, but this one real simple. I'll show you how. So Akida, if I'm pushing with two forces to the right, you understand that this is pushing it to the right, right?
Yes, sir.
If I wanted to oppose that and keep the object stationary, I would need to apply an opposite force with the same magnitude. Agree?
Yes, sir.
So that would be X plus Y to the
Left.
Yeah. So my answer is B. Okay, cool. Let's move on. I hope everybody understands this. Question 5. Which of the following is a derived unit? So a derived unit is a unit you get from a formula. This is temperature, this is time, this is mass. This is what? What is that?
Volume.
Volume. For N to get volume, you use a formula. Yeah, to find volume, you use a formula. Volume is side by side, typically. Right? And because I'm using a formula to derive its unit, then it's a derived unit. Think about it. You wouldn't really have a formula for temperature or for time or for mass. Those are fundamental quantities. And so meter cube is a derived quantity because you use a formula to get the quantity. I mean the unit. Is everybody understanding what I'm saying?
Yes, sir.
Egan, you understand why I said meter cube was a derived unit?
Yes, sir.
Okay. So all of the other ones are examples of what? What kind of units?
Those are standard units.
Not just
SI,
standard,
SI.
they are fundamental units.
Fundamental.
Question 6. A block is allowed to fall freely towards the ground. As it falls, its gravitational potential energy is what?
Converted to kinetic energy.
Kinetic energy.
Yeah. So if something falls, what happens is as time passes, the potential energy is decreasing because it's converting to motion. And if our object has motion, it has kinetic energy. So 6D. Question 7. What is the reading shown on the thermometer? So between 80 and 90, we have 5 divisions. And 80 to 90 is 10. So 1 division will be equal to 2. And so this reading would be 1, 2, 3, 4. So if we have 4
88.
divisions, that's going to be 88, right? So the answer is A. Right. Question 8. Which of the following is a unit for momentum? Remember, momentum is mass by velocity. So the mass is kg, and velocity is ms minus 1. This is RAP. Kg not looking at you is not acceleration. So you don't put ms minus 2. It's kg ms minus 1.
Yes, sir. I know that now.
Okay, cool. Let's move on. Question 9. The kinetic energy of a body of mass m and velocity v is given by D. Oh, you know why I say D?
No.
Now, where's the formula for kinetic energy, guys?
Half
Oh,
mv
sorry.
squared.
Is a half mv squared, right? Yes or no?
Yes, sir.
So what is a half by mv squared? Wouldn't that just be mv squared over 2?
Yeah.
Yeah, let me show you something, right? If I have a half by 7, or let me just write it in the form of the custom seal. If I have a half by 7, and I can write out 7 over 2? Yes or no?
Yes, sir.
Yeah, so what's the difference over here? It's the same thing, I have mv squared on top, so mv squared by 1 is just mv squared over 2. No difference. So, the answer is 9D. Question 10. A body initially moving, let's underline that. It was initially moving. So did it start at rest?
No, sir.
No, it didn't. It was not starting at rest. It was moving at an initial velocity at the start. So a body initially moving at a constant speed, let's underline that as well. A constant speed. If we're talking about a constant speed, it has to be a flat line, right? Because the speed would not be changing. And is brought to rest at a uniform rate. Uniform rate, would that be a curve or would that be a straight line?
Straight.
Line.
A straight line. Anytime you see uniform or constant, that means straight. So this is automatically wrong. This is automatically wrong. Why is this wrong? This is like, it cannot reverse.
Because it looked like if it start from.
Well, in this case, it starts off with a speed, and as time passed, it accelerated to a greater speed, and then it started moving at a constant speed. But that does not describe the situation.
They say it starts at a constant speed.
And it was brought to rest at a uniform rate. So this looking like it. So we start off at a constant speed, yes, and then we started to decelerate, and until we were at rest. So all this seeing what I'm talking about, right? So this is constant speed, and this is uniform rate. It has to be straight lines. This is wrong. It's very wrong. Because
the speed is not constant.
This basically means
it is constant, but
the speed is not constant here. The speed is decreasing with respect to time. So this is deceleration. If
you think about it, it constantly decreasing.
Well, yes, that is why we call it deceleration. So the gradient for this would be deceleration. So this represents this portion over here. Right, so the answer is C. Is there anybody in class that doesn't understand why the answer is C? Tell me now.
Could I go back to the instructions?
Okay, no problem, Rachel. So Rachel, over here, they're saying a body initially moving at a constant speed. So if the body is initially moving at a constant speed, would it would be constant, right? It'd be a straight line. Yes or no?
Yes, sir.
So we start off with a straight line because the speed is not changing, but then we start to decelerate until it was brought to rest. Notice it said uniform rate. So that has to be a straight line. So this represents a constant speed. This part over here, a constant speed, and this part over here represents a uniform deceleration. Rachel, you okay with that?
Yes, sir.
All right, let's move on to question 11. A 4 kg mass is traveling with a constant speed of 5 meters per second. It is brought to rest in 2 seconds. The average force acting on the mass to bring it to rest is... So in this question, we have mass, right? And they want me to find the average force. So F is equal to ma. That's what I'm going to use. So the mass is 4, but do I have the acceleration?
No, sir.
So
Yes, sir.
No, I don't have the acceleration. I have the velocity or the speed, but I don't have the acceleration. How would I find acceleration?
Multiply the 5 meters per second by the 2 seconds.
Nah.
Isn't it V by T? Velocity by the time?
Yeah, it's velocity
V
divided by
minus
time.
0.
It's specifically the final velocity minus the initial velocity over time, because acceleration is a change in velocity over time, right? That's what it is. So in this question, the body was traveling at a constant speed of 5 meters per second. So that's where it was initially. So that's the initial velocity u. And then it is brought to rest in 2 seconds. If it was brought to rest, what's the final velocity?
0.
0. So that'll be 0 minus 2. What's in? That'll be 0 minus 5 all over 2. And so the acceleration is negative 2.5 ms minus 2. And it makes sense because we are stopping it. We are bringing it to rest. Wouldn't the acceleration be negative? Because the speed is decreasing with respect to time. Doesn't that make sense?
Yes, sir.
Yes. And if I want to stop something, then I would need to apply a force that opposes the direction it's going in. So we'll get a negative force. And the answer will just be the magnitude of whatever we get. Right? So watch. The acceleration here is negative 2.5. So what is 4 by minus 2.5? Should get minus 10. Just confirm that. Minus 10, right?
Yes, it's say minus 10.
Right. So what's the answer here?
C.
No. C.
E.
What I want to later understand is, right?
But sir, I just said C.
Oh, I didn't hear. My bad. Now, in this question, you need to understand you're stopping something, you're bringing something to rest. So your acceleration is going to be negative. And so the force you get is going to be negative because you're applying a force in the opposite direction to stop something. Now, none of the answers are negative. I think it's supposed to be negative, but that's okay. The magnitude of the force I needed was 10 newtons, but it didn't specify the direction. So that's why we said 10 newtons. Is everybody okay with this question?
That's the question.
Yes, sir.
Yes, sir.
Okay. Question 12. This is our repeat. What's the answer? I think it's our repeat.
A.
A.
Right? The upthrust is less in liquid A than in liquid B. So the ice cube sinks in liquid A. That means liquid A is less dense, so it has a weaker upthrust. But it floats in liquid B, so liquid B has a greater upthrust. So yeah, the upthrust is weaker in A than in B. So 12.
Sir, is it a repeat or is it just like a similar question? Because I remember we saw a question that was talking about bubbles or something like that.
I know what you're talking about, but this is a repeat watch. I think I could locate the exact same question, I think so.
So she's talking about the one with soda?
Yeah, that's the one she's talking about. What? She's talking about this one. Question 14. She's talking about this one. Right? But I believe the question was also prevalent in January 2025. If I'm not mistaken. Swear to God, it was in 2025, you know. Yeah, watch. Yeah.
Okay, okay.
It's the exact same thing too. They didn't bother to change it up. It's A. Yeah. All right. So 12A. Question 13. A bus with luggage loaded on top is more likely to tip over when rounding a corner than the same bus without the luggage. The reason for this is that the luggage is, guys, if we strap on luggage to the top and we increasing the height, the vertical height of the body, yes or no?
Yes, sir.
And if we increase in the vertical height, what are we doing with the center of gravity?
It raises the center of gravity.
Yeah, you're raising the center of gravity.
This is center of gravity.
Somebody said lower. Nah, it's not lower. If you lower any center of gravity, you lower any height. But what's happening, right? Let me just say that this is the bus here. And it's not really a good drawing of a bus, but we will work with that. And this will be the bus with the luggage. So I have some luggage here. So you can see that in doing this, I increase my height. So my center of gravity would actually be increased at a higher point. And when the center of gravity is at a higher point up, it has a higher chance of tipping over. So everybody understand what I'm saying?
Yes, sir.
Okay. Question 14. Does I repeat? What's the answer?
So 1 and 3.
1 and 3, right? Option 2 is wrong because the spring did not obey Hooke's law for the entire duration of the experiment. Watch. Beyond 75 newtons, the elastic limit was exceeded. So it did not obey Hooke's law for the entire extension. Right, so it's 1 and 3. Right, so that's B. Power is the measure of?
Work done.
You sure?
The change of energy.
So somebody said work done. That's not true. Work done is energy, right? So power is the rate of change of energy. Let's see. Why is that? Remember, power is equal to energy over time. So power is energy with respect to time. So it's a change in energy with respect to time. So 15C. The person that said the answer was A, you understand why the answer is C? Because it's energy over time. The person that said the answer was A, you understand why it's not A? Work done is actually energy.
Yes, sir.
Power. All right. Two forces of 8 newtons and 10 newtons cannot give a resultant of what?
1.
Yeah, can't give 1 newtons. Does anybody know why?
Sir?
Okay, let me show you.
Sir,
So if you have a force of 8 newtons and 10 newtons, the smallest force you can get as a result of that is when both of them going in opposite directions. Make sense? When they're going in opposite directions. Yes or no? So
Yes.
watch. Yes. Example. Let me just say I have two forces here, right? This is the 8 Newton force, and this is the 10 Newtons force. Okay. If both of them going in the same direction, you will get a resultant force of what?
18 Newton.
18 Newton.
Right. Let me just say they were going in opposite directions. So we have 8 Newtons here and 10 Newtons here. What would the resultant force be?
2.
2 Newton.
So where's the range then?
Between
Between what?
Between 18 and
That's correct. So realize 1 is out of that range. Understand?
Oh. Yes,
That is
sir.
why it cannot be 9.
Say that again.
That is why it cannot be 9.
no, because
could be
9 is
9.
within the range.
No, it could be 9. It could be 9. Remember, these forces, these are the two extremist situations, right? Now, these two forces could be at some angle to each other. And when you find the resultant, it could be between 9. Yeah. So the answer is 1. One is outside of the range. Let me check something real quick. So if, let me just say the two forces are perpendicular to each other, let's see what's going to happen. So we'll just say 8 and 10. Okay, if you do that, you're going to get 12.8. Right, so that's still within your range. So to the guy that wanted to know why 9 is part of the solution, I want you to unmute. I want you to explain to me why do you think 9 is not, it cannot give off a resultant of 9? So I want you to understand something. These two forces, they don't have to, okay, these two were the two extreme examples. These were the two extreme examples. You could either have the forces going in the same direction or opposite directions. But in the middle, you could have these forces acting at angles to each other. So it could be like that, could be like that, heck, it could be like this. And what we covered was the two extremes. So in the middle, you could have you can get a resultant force between 2 and 18. But you can't get a resultant force at 1. That makes no sense. Right, so I trust that everybody understand this, yes or no?
Yes, sir.
Okay, good. Question 17 now. I want somebody to give this a read. K. I want to say a name.
Yes, sir. Hold on.
The wrong thing.
Yeah. Yes, sir. X, Y, and Z are three billiard balls of equal mass whose centers lie in a straight line. Y and Z are touching one another. X, traveling with a velocity of 20 meters per second, impinges on Y, assuming that the fares are perfectly elastic. The resultant motion after impact will be that.
Okay, this question is very similar to a question we did previously. That's this question over here. And it's an example of Newton's cradle. Do you know what the Newton's cradle is?
No.
Nah, that's like the you never see this thing where it have like a bunch of balls and wait, again I'll call it. So like you never saw this it's beyond like desktop something like when you if you take this ball and you lift it up.
So and like all the other balls hitting each other.
So with the energy transfer.
Yeah. Let me send all you an exact it's not like the experiment I'm talking about, but I think D'Angelo, I think you know what I'm talking about. So basically what happens is in a perfectly elastic system, when one ball hits the other ball, the momentum gets transferred through the other balls to the ball to the other end. That's what happens. Right? Newton's cradle. Massacre. Right. So do you guys see what I'm talking about there? Let's see what I'm talking about. So what happens is if you lift one ball, it would gain momentum and it would transfer the momentum to the other balls, and the ball to the end would gain, it would transfer the momentum to the ball to the end. And so that's essentially what we have here. So again, I don't Okay, let me know if I hear ma. Internet kind of bad.
I was supposed for Tuesday.
Oh,
Yeah, I'll be breaking up plenty on this end.
technical issue.
Yes, technical issues. Let me know if I hear. Yeah, let me know if I hear ma now.
So you're good now?
I using data. The internet
Yeah.
in real trouble. This rain not treating me very well.
Yeah. Have you enough data for that?
Yeah. So you're sending right now by me now. Place hot.
Which part you from?
Well, I don't south.
Well, I don't sound to it raining here. I don't know which part of South you.
It's nothing by me.
Right? I'm supposed to have enough data. Yeah.
You're supposed to.
It's
Good
okay.
luck, sir.
It's okay. It's a worthy sacrifice. I'll show you the benefits somehow there. Right, so don't
Say I
worry.
can
Yes,
give
sir.
you a Bobby for this.
You go send a Bobby?
Yes, sir.
Okay, nice, thanks. So let me answer this question, right? So if this is an example of Newton's cradle, what's the answer?
The answer be B.
Yeah, the answer is B. So X and Y will remain stationary, right? While Z moves on with a velocity of 20. So what happens is this ball would collide with this ball, and the momentum would transfer through those balls to Z. And so Z would move along with the velocity of 20. Understand?
Yep.
Okay, good. Question 18. What is the gain in the gravitational potential energy of a body of weight 200 newtons as it rises from a height of 30 meters to a height of 35 meters above the Earth's surface?
1,000 joules.
1,000? Yeah, 1,000 joules is the answer. Do you know how to get 1,000 joules? Yes or no?
No, sir.
No? All right. You understand that the formula for gravitational potential energy is mgh, right?
Yes, sir.
Right. What is the mass? Do we have the mass?
Yes, sir.
No, we don't have the mass, right? But I'll show you something. In the formula for potential energy, it's mass by gravity. What is mass by gravity? What
The
is mass
weight.
by weight, right? So another way I could write the gravitational potential energy formula is weight by height. Do we have the weight in the question?
Yes, sir.
Yes, sir.
So here what? Let me figure out how much potential energy we have. If we 30 meters from the Earth's surface, then we will find how much energy we have at 35, and then we go minus it to figure out how much I gain. The other method was just to say 30 from 35 and plug it into the formula and you'll get 1,000. Right? But I think I'll go understand this method more. So it's going to be 200 by 30. What is 200 by 30?
6,000.
Right, 6,000 joules, right? Okay. And that's when I'm at a height of 30 meters from the Earth's surface. Let's say I go up to 35. So 200 now by 35. What's 200 by 35?
That is 7,000.
So how much energy did I gain by adding on another 5 meters?
1,000 joules.
1,000.
So everybody understand it now?
Yes, sir.
Yes, sir.
Energy gain is and the other way to do it would have just be to say, well, so GPE, that would have been weight by height. The extra height is 5 because 30 from 35 is 5. And so you get answer one time. Yeah. So this is method 1 and this is method 2. Let's continue. Question 19. Which of the following quantities remains unchanged with an increase in temperature?
Mass.
Yeah. Mass does never change.
Mass.
Right? Mass is the amount of matter in an object, and that doesn't change. That remains constant. Right? Question 20. What is the specific heat capacity of a substance? is the amount of thermal energy required to. So anything you see with convert, no. Specific heat capacity deals with a change in temperature. A change in temperature, not a change in state. Right? Change in temperature. So which answers are wrong one time?
Buoyancy.
Right? B and C. So we're seeing raise the temperature of the substance by 1 Kelvin. This is wrong. This is the formula for heat capacity. I mean, what's the formula? This is the definition for heat capacity. So my answer is D. Anytime you see specific, your answer must include mass in it. So your answer is D. Everybody okay with that?
Yes, sir.
Yes,
All
sir.
right. 21.
bro.
Right. So 21. The specific latent heat of vaporization of water is 2.26 by 10 to the power 6 joules per kg. When 0.01 kg of water is converted into steam, it does what? So what formula I have to use here?
E equal ml.
MLV, right? So the mass is 0.01 and the latent heat of vaporization is 2.26 by 10 to the power 6. Now 0.01, I'm going to do some odd maths fast. That's 10 to the power minus 2. And so since I'm multiplying, I'll add the powers. So I should get 2.26 by 10 to the power 4. Yeah, 2.26 by 10 to the power 4. 2.26 by 10 to the power 4 joules. Right? And let me ask you a question. If I convert in water to steam, water into steam, would I be absorbing or giving out heat?
Absorbing.
Given out?
Giving out heat.
No. If I want to get hot, wouldn't I have to absorb the heat to get hot?
Oh yeah.
Yeah. If I want to heat up something, I need to supply it with heat energy so it can absorb the heat energy, so the particles would gain kinetic energy and they would start to vibrate and they would move about and eventually the bonds would break and it would become steam. That's the process. So the answer is absorb 2.26 by 10 to the power 4 joules. I feel like a good couple earlier would I get this question wrong. Just remember, if you're experiencing heating, you're absorbing heat. Absorb heat. If you are cooling something, you're giving out heat. Giving out. Think of it like this. If you're giving out heat, you're losing your heat. And if you're losing your heat, you're becoming cooler. That makes sense, guys? So giving out heat means like you're giving out your heat.
Yes, sir.
So you're becoming cooler. Right. Question 22. A gas occupies, this I repeat, what's the answer?
27 degrees Celsius.
Right, this I repeat. 23. Which of the following method is the most suitable means of heating a brass bulb in order to determine its specific heat capacity by the method of mixtures?
C. Placing it in a boiling water bath.
Yes, C. Placing it in a boiling water bath for 10 minutes. That's correct. I don't know why so much people call it now. I will shoot people, you know. Oh, you're not supposed to hear that. I wouldn't actually do it, but I don't know what I mean. Like when people keep bringing down your phone.
So make the bomb.
I won't make the bomb. Yes, I will light it up.
It's a bomb them.
Right. So let me continue with all the still ones. Are they just here when you're ringing? Like an alien? Are they just here?
Yes, sir.
Yes, sir.
Oh, oof. All right. So somebody read question 24.
According to the kinetic theory, when a gas in a closed container is heated, the pressure rises because... Damn.
Why would the pressure rise? So when you apply heat to something, what happens to the molecules or the atoms on the inside?
They gain kinetic energy.
And if you're gaining kinetic energy, that means you're moving about, you're vibrating. And if it's moving about and it's vibrating, then it's going to have more frequent collisions and it's going to bombard the wall. And if it bombards the wall, it's going to exert a force and that's going to increase pressure. So the answer is 24D. Right? So the molecules will move faster and hit the walls of the container harder and more often. Make sense?
Yes, sir.
Okay, nice. 25. Molten naphthalene. Or for those who don't know what naphthalene is, we have any Hindus in class? I'm a Hindu, by the way. Yeah. Have any Hindus in class? I'm sure like one only do it is right. And just okay, let's call it camphor. That's naphthalene. That's
Dirty
naphthalene.
mothballs.
Yes, that's naphthalene. That's what naphthalene is. Right? So naphthalene at 100 degrees Celsius is allowed to cool down to room temperature. If naphthalene has a melting point of 80 degrees Celsius, which of the following graphs best represents the cooling curve? So any curve that doesn't have a latent period is going to be wrong. What do I mean by a latent period? Hence, there's energy involved converting it from a liquid to a solid. Yes or no?
Yes, sir.
Yes, sir.
Yeah, so where's the only correct answer?
C.
Is it C?
Yeah, C is the only correct answer because there's going to be a time period where there's no change in temperature because we rearrange any atomic structure to change state. Yeah. Okay, nice. 26. In which of the following is conduction the main method of energy transfer? What do you all think?
C? No, wait. Is it D?
It's D. If you're cooking food, if you're cooking food in a pot, and the food would be like, okay, let me just say cooking eggs, right? And the eggs will be in direct contact with the pan or the pot. Yes or no?
Yes, sir.
And so that directly, remember, conduction has to do with physical contact. Physical contact. Let me explain why I would not say C. If you're cooking food in a barbecue, and you just have the food on the grill, and below the grill, you would have the coal, and the coal would be radiating heat. And when you close it, you have convection. So the main forms of transfer there is convection and radiation. Yes or no? That makes sense?
Yes, sir.
Yeah. I mean, well, sometimes when the heat directly touching the food is conduction, but most of the times, the coals is just be radiating heat. 27. Which of the following are reasons why a hot liquid is a repeat? What's the answer?
So is it all of that?
Nah. If you
1 and 3 only.
1 and 3 only. Let me explain why 2 is wrong. The goal of a vacuum flask is to keep the temperature constant. If I want to keep the temperature constant, why would I absorb heat from the surroundings? If I absorb heat from the surroundings, then that's going to change my original temperature.
Yes, sir.
Yeah. So it's 1 and 3. So my answer is B. 28. A person coming out of the sea would feel cool because the seawater evaporates from the skin. So when the water evaporates from the skin, it takes the heat energy with it. So you lose heat energy with evaporation. 28C. Everybody okay with that?
Yes, sir.
Okay, cool. 29. The kinetic theory of matter suggests that the molecules of a gas are D, right?
Far apart.
Far apart
D.
and at
I'm
random.
moving at random.
That's correct. 30s, I repeat. What's the answer?
A.
A.
Yeah, A. All right. Item 31 refers to the following diagram, which shows the instantaneous profile of a wave traveling across a water surface. From the information above, the frequency is, somebody tell me, what's the formula for frequency? 1 over?
1 over T.
1 over period.
Okay, but can I figure out the period from this graph?
No, sir.
No, I can't. Period is time. Are they seeing any time axis over here?
No, sir.
Right, so no time axis. So So do I have sufficient information to find the frequency?
No, so it'd be D.
No, sir. That'll be unknown.
It's unknown. Yeah. 32. The sharp edges of shadows suggest that light, well, light typically travels in straight lines. Think about it, guys. When you're drawing ray diagrams, have you ever draw light like this?
No, sir.
No, light is always be in a straight line, right? Yeah. So 32A. 33. An echo is quieter than the original sound that produced it. This shows that compared to the original sound, the echo has a, we're talking about loudness.
B.
B.
Amplitude.
Anytime we're talking about loudness, we're talking about amplitude. Right? 34. At some points, this is basically the question that comes in all the exam. This is basically the question. Right? So at some points, no sound is heard. Why is that? Why is that?
Because of the interference.
Yeah, the interference. Some points it would have constructive interference, and in those areas it would sound louder, and some areas it would have destructive interference, and it would have no sound there, or little to no sound. So everybody okay with that, right?
Yes, sir.
35. All right, see, let me change up the question. A ray of light leaving air enters glass of refractive index 1.6. So if we had to use the formula, n is equal to sine I over sine r. So they gave us a refractive index, and they are saying that the angle of refraction is 27 degrees. So they want me to find the sine of the angle of incidence. Okay. So they give them an n, and they give them an r, and I have to find the sine I. So I'm going to say 1.6 is equal to sine I all over sine r, and r is 27. So Hagan, will we go and find the exact value in our calculator, or like we're just going to leave it in exact form?
No, sir, we leave it in exact form.
Right. I'm looking at you, I'm looking at catching to see. I'm looking at you to see if I'm going to catch you lacking. I'm looking.
No, sir, I don't be lacking.
So since we have two fractions
So he
on
would
either
put
side.
E and then put the solved answer.
Yes, yes. Imagine in the exam, he gonna put E.
No, sir, I know what I'm doing.
No, that sounds like a you thing to do. All right, and then they're gonna cross multiply. To cross multiply, 1 by sine I is just sine I, and 1.6 by sine 27 is 1.6 sine 27. So that's what sine I is going to be equal to. So hang on, tell me, where's the answer?
Says this, sir.
Yes, it's D. Nice. Let's move on. 36. Which of the following waves travel only longitudinally? Only, yeah? Only.
There's one for sure.
A.
A is A.
A, sir.
You see, like, if you do some deep research, you'll see that water waves could travel both longitudinally and transversely. It depends on the occasion. You can look it up. And so, if we're talking about only longitudinally, we're talking about sound waves, right? Yeah. I'm just asking, in longitudinal waves, the vibration of the molecules are what to each other? Perpendicular or parallel?
Perpendicular.
No, parallel.
Parallel.
Imagine you have a speaker over here. If you ever forget, just draw a speaker, right? And enter speaker. And this is a symbol for speakers. Yes or no?
Yes, sir.
And so they could clearly see that they parallel to each other. So they can see that.
Yeah.
Here,
Yeah,
so,
like this.
so longitudinal waves are parallel, in case I ask that. And transverse waves are perpendicular to each other. Which of the following can produce a diminished virtual image of a real object? Based on the previous question we did for divergent lens, you should know that the answer is a divergent lens. Let me show you the question I'm talking about. Which question is that? Was it from this year? No, I feel it was in 2025. I feel so. What year that was, mate? How did be this here then? Really jail. I know I draw a divergent lens diagram. Yeah, look at here. Watch. Somebody tell me the properties of this diagram for a divergent lens. Just remind me. The image is smaller or bigger than the object. So this is the object here, this is the image. What bigger, the object or the image?
Object bigger.
Yeah, so it forms a diminished virtual image. Or you can see that virtual, right? Because it forms behind the lens and it's smaller. So we're clearly talking about a divergent lens here. So anytime you see virtual, just think immediately divergent lens. Because with divergent lenses, the light ray has to bend away from the lens, and so you get convergence behind the lens. Always get convergence behind the lens. I really feel like get what I'm saying, right? Basically, what I'm saying is your image will always form behind the lens when you have a divergent lens, so it will always be virtual. So I say. To the 8th, total internal reflection in glass occurs when? What? When does it occur?
The critical angle is exceeded.
C.
Yeah, C. When you go past the critical angle, that has happened. Let me give a little example, like a very quick example. Right? By the way, total internal reflection has only happened when you're going from a denser to a less dense. So let me just say this is water here. This is water. This is air. This is the boundary line. This is the boundary line here. This is normal. Right? So anytime you go in from a more dense to a less dense, you bend away from the normal. So I'll recap. And so guys, what's gonna happen? Wait. Like I said, giving all that quick recap. So what's gonna happen if I increase the angular incidence here? Wouldn't this move further away from the normal?
Yes, sir.
Yeah. And so right now it's at the critical angle. So at the critical angle, the angular refraction is 90 degrees to the boundary line, 90 degrees to the normal, right? And so I think I could see what's gonna happen, right? If I go past the critical angle, this is now going to dip below the boundary line and it's going to be in water. Let's see what I'm talking about. But if I increase this, it would move further away from the normal, and so it would reach inside the water. Yes or no?
Yes, sir.
Okay. So that's like a crash course on this. So if it exceeds the critical angle, that's when total internal reflection happens. So this would be C, and this would be more than C. A ray of light in air strikes a glass block at an angle of incidence of 0 degrees. On entering the glass block, the light will be what?
E.
A, undeviated. When we was doing lenses, right? And it have a rule that says if it passes through the optical center, the light ray will be undeviated. Yes or no? You know what I'm talking about? Like when you're drawing a ray diagram, and you just always draw a ray of light passing directly through the center of the lens. Okay, I don't think I know what I'm talking about. Maybe I should give it in a different context. So we have a boundary line here. I have the normal here. And so what would an angle of 0 degrees look like? Does anybody know?
Overlapping the normal.
At the point, sir.
Say that again?
At the point.
It would be on the normal.
Yeah, it would be this. And so this is what is happening. So if a ray of light strikes a glass block at an angular incidence of 0 degrees, it's gonna go straight through, undeviated. And that is why when we're dealing with lenses, the rule is that if you have a ray of light passing through the optical center, it goes it goes through without being refracted. Yeah. So that's where your rule comes from. Question 40. The position of an image formed by a plane mirror depends on the, what does it depend on?
B.
B.
B. Remember, if you have a mirror, then the distance the object is away from the mirror is always going to remain constant, right? So if it was 5 meters, if you have an object here, then the image is also going to be 5 meters away from the mirror on the other side. So if I want to change the position of the object, I would do that, and as a result, wouldn't the position of the image change as well? Yes or no? If I change the position of the object, wouldn't the image in the mirror also change?
Yes, sir.
Think about if you're looking at yourself in the mirror and you're moving, you will see yourself moving, right? Because you see object.
Yes, sir.
Yeah. Right. So the answer is B. 41. Which of the following expressions would represent the formulae for linear magnification? So to find magnification is always the distance over the object. So it's the, wait, I'm going to say that one more time. So it's the distance, so it's the property of the image over the object. The image over the object. So it could be height of image over height of object, or it could be distance of image over distance of object. So which one is my answer? Do I have two options or one?
One.
One. Now this would have been correct if it was image distance over object, but it's wrong. So it's always the distance of the image over the distance of the object. So it's always the image over the object. Just keep that in mind. Image over object. Because we want to compare the image to the object, which is the original. So the answer is 1. So is everybody okay with this? So again, it's always image over object. So we start off with object here and then image here. And it's the same thing here. It needs to be image over object.
Yes, sir.
Right. Let's move on. Item 42 refers to the following graph showing the variations of alternating current with time. The value of the current I1 at time T1 is called the what current? What do you all think?
D.
D, the peak value.
Peak.
Isn't this the highest point for the graph? And so that would tell you the maximum current. Another word for that maximum current is peak value. It's peak value. Right. So, Hagan, I want you to read question 43.
So is a repeat?
No, that's not right.
When a polythene rod is when a polythene rod is rubbed with a cloth, it becomes positively. Hold on. It becomes positive. Hold on. Stand. It becomes positively charged by loose. Hold on. Wait, hold on.
No, the answer. No, that's not the answer. This is a trick. It's a catch. It's a catch.
Hold on. I'll go and get it. I'm going to get it. Negatively charged. Negative. Hold on. It says D. Negatively charged by losing protons.
He said negatively charged by losing protons.
Wait, no, hold on.
Say I could say the answer.
Yeah, somebody say the answer.
No.
We have a real big debate here. Now, in the previous times, we had a glass.
Oh yes, we will get negatively charged because if it
Is it not B?
The answer is B, right? The answer is B.
Thank you.
I saw another picture of something, right? That's the triboelectric series. And so that kind of shows you which one would be positive and which one would be negative, right? So polythene, if you look at the diagram, all the polys are negatives. So they would gain electrons, right? And if you look at glass, mica, polyamide, rock, salt, all of these would become positive. They are more likely to lose electrons. So you could keep that in mind. So I know a good amount of people would have just put positively and move on with their life. But no, it's negatively charged by gaining electrons. Yeah. Any other teacher ever told you about the triboelectric series?
So we didn't learn about that, but in the physics concise book, it has the two examples when I rub the polythene rub with the quartz, and like they're talking about via conduction and convection. I don't know if anybody else learned about that, but it's in the physics concise textbook.
Okay, well that comes from the triboelectric series. Well, obviously it's a bit more advanced. Like you learn that when you're doing material science. Like I had to learn this for one of my courses, even though I'm doing electrical engineering. So that's
So is that uni level or is that like Form 6?
that's uni level. You wouldn't learn this in upper six or lower six physics. I mean chemistry
Okay.
or physics.
Okay.
But you understand what I'm saying, right? You can see that any
Yeah, so no,
series,
I knew the answer.
so anything that's negative, so hear this, right? If I were to rub wood against a silicon rod or something, I mean, what's in silicon? If I were to rub it against like a silk cloth, that would become negatively charged. Same thing for gold. If I rub gold on a cloth, it would become negatively charged. Think I'll get the idea. So since I have the list there, no matter how they change it up, it should be fine. Here, gonna looking at you again. You should be fine. Right. So over here, this is an example of magnetic induction, for those who don't know. Remember the example with the nail? And I said that all ferromagnetic materials, they have these things called domains. And when you bring a magnetic field close by, they align and they become a temporary magnet. I'll remember when I say that? Yes or no?
Yes, sir.
Okay, so basically what's gonna happen? The domains in the ion are going to align with the magnetic field. Now, the ion is going to become a temporary magnet. So this is going to become the North Pole and this is going to become the South Pole. And if that's the case, how would the magnetic field go?
North to south.
Right, it would go north to south. North to south. So yeah, the answer is C. Did any of you all know that this was an example of magnetic induction? I take it as no. Yeah, well, this is magnetic induction in effect. Because you're magnetizing the ion without touching the ion. 45. We have a nice question here. So item 45 refers to the following circuit where the ammeter reads 0.4 amps and the voltmeter reads 0.6 volts. All right. What is the resistance of R? So guys, so the ammeter reads a current of 0.4 amps. So that means we have a current of 0.4 amps flowing through the circuit. Yes or no?
Yes, sir.
Yes,
Now,
sir.
the voltmeter is going to have a high resistance or a low resistance.
So you have a high resistance.
So it's going to, like, the ideal voltmeter will have an infinite resistance. It will have an infinite resistance. So all the current is just going to pass through R, right? So 0.4 amps is going to pass through that resistor. Now, what is the voltage across our resistor?
0.6.
0.6, right? So across the resistor, we have 0.6 volts. So is it possible for me to find the resistance if I know the current passing through the resistor and the voltage across it?
Yes, sir.
So V is equal to IR. And if I make R the subject of the formula, R is going to be V over I. And so my voltage is 0.6. And my current is 0.4.
1.5.
Yeah, 1.5 is correct.
B.
How much would I figure this out?
So that I think that I feel like that's baby maths. Like I feel like once you make to make subject or the formula.
Yeah, it is baby maths. We didn't get on. We didn't start to do the interesting questions as yet. The interesting electrical questions. All right, so let's move on. If you have anybody that don't understand this, let me know now, or forever hold your peace. Okay, I'm gonna move on. 46. A conductor rotating in a uniform magnetic field induces maximum instantaneous current when the conductor cuts the magnetic field lines at, what's the answer?
D, sir.
D.
45.
Well, I said D. No, the answer is C.
C.
90 degrees. Let me give you an example of something. I'm going to blow their mind. When are they doing Fleming's right-hand rule or Fleming's left-hand rule? Which one are they more custom with? Fleming's right-hand rule, right? Or Fleming's left-hand rule? Which one?
C, right. Right hand.
So it is usually left-hand rule when you're dealing with motors, and it's usually right-hand rule when you're dealing with induced currents. So let me use the right-hand rule, right? Because we inducing current here. Remember the right-hand rule, your thumb is the motion, your second finger is the magnetic field, and your third finger is the current. So when you do that, so I want everybody to be doing Fleming's right-hand rule, right? Do Fleming's right-hand rule. Let me ask a question. The current and the magnetic field is at what angle to each other in the Fleming's right-hand rule?
90 degrees.
90 degrees.
Yeah, 90 degrees. And so like, poof, I just blow all in mind there. I was sure they were talking about. Yeah, that's what I'm talking about. So Fleming's right-hand rule assumes that you're inducing the maximum current possible. It assumes that. Right, let's move on. 47. Which of the following relationships is correct for the combined resistance RT of resistors R1, R2, and R3 connected in parallel?
C, sir.
Yeah, the answer is C. C. Anytime you want to figure out, well, this is the original formula to combine parallel resistors, right? So basically, you add all the resistances, you add all the reciprocals of the resistances. So it depends on the amount of resistors you have. So in this case, we have 3 resistors, so it's just R1, R2, and R3. Then we just say we had 5 resistors, and then it'll be R1, 1 over R1, plus 1 over R2, plus 1 over R3, plus 1 over R4, plus 1 over R5. Are they getting the point?
Yes, sir.
Okay.
Yes, sir.
48. A voltmeter has a very high resistance so that it can be placed. We know the answer. What's the answer?
B.
No, whoa.
A, sir, A.
A.
With A.
Yeah. Remember a voltmeter? Cover example here. How is this voltmeter hooked up to this resistor? It's in parallel.
Hello?
Right. And so at the hook-up voltmeters in parallel. Why? Because a voltmeter measures the difference between 2 points. That's why. And a voltmeter should have a very high resistance so that no current would pass through it. Right? So all of the current will just pass through the resistor. Yeah. You don't want to take up current from the circuit. Although understand that if this have a low resistance, any current going to split at this junction and it's going to actually consume current in the circuit.
Yes, sir.
Yeah, it will consume current in the circuit. So we need it to have a very high resistance. So the answer is 48E. Places in parallel, and it must have a high resistance, so it don't affect the circuit. Cool. Which of the following graphs illustrates an alternating current? How much are they going to answer this? Out of curiosity, how much are they going to answer this?
No, sir. So it wouldn't be D?
It will be D, but I'm interested in knowing how much are they going to put C? Be honest with me. How much are they going to put C?
So it can't be C because if it alternated, it had to have something on top and something on the bottom. It can't have just on top.
Exactly. Exactly, right? You need to be
Sir,
alternating.
I feel like you only.
Wait.
So I feel like the only way you get caught up with this is if you don't know what's the difference between AC and DC because how it's just going squiggly. But then you could think that same thing for me if somebody get caught up with that.
Yeah, that's why I circled it, because at first glance I look like a quote unquote alternating current, but it's not. Right? Alternating current means that the magnitude changes, so it switches from positive to negative. It remains positive here. And guys, I'm so bad at this. This is the current after it comes out from a what rectifier? A half-wave rectifier or a full-wave rectifier?
Halfway.
Yes. Oh, we have some electrical engineers here, boy. Half-wave.
You hearing me?
And a half-wave rectifier is just you just use one diode. This is the example when you use a full-wave rectifier.
Sir.
Yeah? Somebody saying something?
Sir, so the rectifier or the what you convert like the alternating current to direct current.
Yes. That's the purpose of a rectifier.
Okay, sir.
Yeah, that's it. Or they want me to, like after class, or they want me to hook up my oscilloscope to like the transformer and show the alternating current.
Yes, sir.
Yes, sir.
I will do that. Yeah. Just remind me, right? And I'll show you the different waveforms as much as I could. Okay. And this over here, I really don't know what to call this. This looks like a fluctuating direct current. So it's fluctuating between current values. So it's fluctuating. Right? So this is a fluctuating DC current.
So that look like the snake from the Nokia game.
For real. There's some old people in class, boy. I surprised you know about that. Yeah. And this is when it get real big. When the snake get real big and they had like a real maneuver. Yeah. Yeah, you see it?
Sir, sir, so
wave.
sir, you hearing me?
Yeah, I know.
For the alternating current, what I think about is just say like you would have complete one positive and negative half cycle. So basically you would have just go to a positive then to a negative portion of the graph, basically if you extrapolate it. So
Yes.
yeah.
I like how you're thinking about it. That's exactly how I just think about it too, because if it alternated, that means it alternated from positive to negative.
Yes, sir.
Were you there when we did the previous question? We had do a nice question about that,
No, sir, a good while just joined.
Were you there when we did this question?
No, a good while just joined.
Oh, okay. Well, good. So yeah, this is alternating because we alternating from positive to negative, right? Okay, let's continue. 50. Okay, this is a nice question. I'm gonna see what they're gonna say. Which of the following circuit arrangements is best suited for measuring a lamp's voltage? I want to measure the lamp's voltage. Let me see what's going on here. This is chaos, right? This is definitely wrong.
Sir,
So you have to be in parallel.
It's in series. The voltmeter is in series.
Yeah,
so that is wrong.
This is real
you
wrong.
have to make it in parallel. So yeah.
So that's wrong as well too.
There's something looking wrong there. That's not correct.
What is this measuring? It's
So
correct.
it's measuring the cell.
Yeah, this is measuring the potential difference of the cell. Right, measuring PD of the cell. So this is still wrong. This one looking right. Yeah, are you agree?
Yeah.
Yes, sir.
Because it's measuring the voltage across the bulb. We see in that the voltage across the bulb. So it's C. Let me see.
By the way, I'm hearing an accent. Are you from Trinidad?
Yes, I'm from Trinidad.
Oh, okay.
Are you from St. Vincent?
No, Jamaica.
Jamaica? Okay. I would have said St. Vincent and the Grenadines. Because I have a partner from St. Vincent and he's talk like you.
Oh, okay.
Yeah. And okay, in this question, well, in this option, this is measuring the potential difference across the resistor and the bulb. So this would tell us the voltage drop across the resistor and the bulb. And let me see how bad it is, right? If this is 5 volts here, what will the voltmeter read?
Nothing.
it would, well, I close the circuit, right? I close the circuit, so you can't say nothing.
Wouldn't it be 5 volts?
It will be 5 volts, yes, sir. The reason for that is because the voltmeter, in this case, is set up to measure the voltage drop for all the components. Remember something, you wouldn't know this, but again, Kirchhoff's voltage law says that the source voltages had to be equal to the sum of voltage drops in the circuit. So every component in a circuit uses up a voltage. And so, and these are the two components in the circuit, Malia, and these are the two components in the circuit. Yeah, these are the two components that are using up energy in the circuit. So if I measure the voltage across these components, I should get the 5 volts because those two components would use up the 5 volts. All you get what I'm saying?
Yes, sir.
Yeah, because these are the two components in the circuit that's using up the energy. All right. So let's move on. So the answer was 50C. Which of the following circuit diagrams best represents a series arrangement? Well, we know this wrong because the current is going to split at this node. It's wrong. B is correct because the current, if we draw the direction of the current.
Yeah, one direction.
One direction, yes. I like you. You sound like you can be my partner. And I love electrical engineering, so sound like you like electrical engineering too.
Yes, sir.
You in the group chat by chance?
No. My friend sent me the link.
Okay.
Yeah.
Okay, well, send my message at 7842630. I'll add it to the chat. After I finish with this session, I want to show you some sine waves on them using your oscilloscope.
Okay, could you repeat that, please?
I was just sending it in the chats.
Okay.
Right. Yeah, this is no example of a series circuit because watch. The current splits at this junction. And well, over here, it splits at this junction. Everybody understand why B is the answer?
Yes, sir.
Good word. 52. Oh, we have a nice question here, boy. We have a nice question. Let me go. So I was on TikTok and I keep seeing people saying how they wanted logic gates question. So somebody that wanted a logic gates question, I would like it on mute. Let me do this question now. Okay, you're real excited. Okay. So first of all, tell me what kind of logic circuit is that? Well, what component is that?
That's an AND gate.
Right, this is an AND gate. And an AND gate does what to the two inputs?
When both inputs are high, it will output a high input.
So what's the operation? Multiply. Yes. And this over here, this is a what kind of gate? So
which one, sir?
This one.
OR gate.
So OR gate. And an OR gate does what to the two inputs?
It adds. Add.
Right, so we have an AND gate over here, another AND gate, and it multiplies the two inputs, right? So what is the output at C and D when an input of 0, 0 is made at A and B? 0, 0. So let me see what's going on, right? So 0 and 0, 0, that would mean over here and over here will be 0. And so the output is going to be 0, because 0 by 0 is 0. Over here it's going to be 0, 0. And if I add 0 and 0, that's just going to be 0. And so 0 and 0 will be fed to the last AND gate. And so the output is just going to be 0. So we just don't answer that whole question. Even stuff they didn't ask for, because we were real bad. So where's the answer, guys?
A.
Have anybody here that didn't understand what I did?
Yeah, what were you saying about operations? I never learned it, so.
Say that again?
I never learned it, so like the AND multiply and the OR gate being plus.
That's really interesting, but that's the operation. That's what it does. Because ain't you learn that for AND gate, for both of them to be turned on, the only time it's turned on for AND gate is when you have a high and a high. You learn that,
Yeah, I learned it says if there are two high outputs, then you'll get a high output. But if one of them isn't high, then you'll get a low output.
Okay, so Rachel, watch check this, right? I'm gonna apply what you're saying and show you how the operation makes sense. So you're saying only when it have a high and a high, you get a high, right? Yes or no?
Yes, sir.
So a high would correspond to 0 or 1.
1.
And 1 by 1 is 1.
Yes.
Let's check out all the other possibilities. So we could have 1 by 0, that'll be 0. We could have 0 by 1, that's 0. We could have 0 by 0, that's 0. So you see, you understand why, you understand how what you learn and what is how over here is the same thing?
Yes, sir. I
Yeah.
should never teach it, so. My gosh.
But it's the same thing, right? It's the same thing. The only problem with how you learn it like that,
Same thing.
it do prepare you for these kind of questions. I guess I know it does because you would have said this would have been 0 because a low and a low, and you'd have said this was this is a low and a low, so it would be low. That's how you'd do it. It'll be fine though. But I prefer the sign
Sir,
for the arithmetic. Yeah.
how do you know the difference between the types of gates? We didn't do it in school or lessons.
Oh, you had to memorize the different types of gates. You want to just list it out over here?
Yeah, but how do you know how do you identify them on the diagram? Like here, how did you know that okay, C was the AND gate, you know?
It's just symbols
Yes.
you have to remember. It's just symbols you have to remember. It's literally just it's something you have to remember. So let me just list all the logic gates you
So,
need
sir,
to remember.
one would have a different symbol?
What's that again?
You're saying that one will have a different symbol?
Let me show you guys all the possible gates, right? They're we have like 5 at this level you're supposed to know. So the first one you don't know about is a NOT gate. This is what a NOT gate looks like.
Sir,
Yeah, somebody was saying something.
I believe you did the third on our paper.
Wait, I'm not hearing you properly. So all the gates represent a
I said
different
you
type
did it
of.
on another paper already.
You see this on another paper? They like to bring this question, but typically when they
Yes,
bring it,
sir.
they would change the letter or they would change the gates. So you have to be careful. So we have a NOT gate over here. Basically, what a NOT gate does, it flips the output. So if I supply a 0, it's gonna give me 1. If I put in a 1, it's gonna give me a 0. So the NOT gate just switches whatever I put in. So I'm gonna list all the gates over here, and then I'm gonna show you all the truth tables here. So we have a NOT gate. We also have an AND gate, right? So I could call this E prime. The AND gate looks like this. This is what the AND gate looks like. You have 2 inputs, you have 1 output, and you have the NAND gate. If you're seeing this for the first time in your life, drop a 1 in the chat. Let's get a look at the chat. Yeah, so for the person that was asking me, how would I know? Well, you had to remember it. Yeah, you kind of have to remember it. So let me just run through the concept real quick. So in a NOT gate, it basically inverts the input. So if I were to input 1, I would get an output of 0. So let me just show you what I'm talking about. Right. So for a NOT gate, Right? So for a NOT gate, this is going to happen. So if I put in 0, my output is going to be 1. If I put in 1, my output is going to be 0. I might need more space. I'll make some more space. Let me just take a screenshot of this, right? So a NOT gate just basically it inverts the input, right? An AND gate now. An AND gate multiplies. That's what AND gate does. Multiplies. So let me just call this input A. Let me just call this input B. Input A, input B. And I'll call this the output O. This is what's gonna happen. So 1, 1, 0, 0, 0, 0, 1, 1, 0, 1, 0, 1. And so it's going to multiply. So 1 by 0 is 0, 1 by 1 is 1, 0 by 0 is 0, 0 by 1 is 0. A NAND gate behaves like an AND gate, it just inverts it. So I'll show you what I mean by that. So with a NAND gate, you're going to multiply, but then you're going to flip it at the last minute. So watch. 1, 1, 0, 0, 0, 1. So watch this, right, guys? So for the NAND gate, I would multiply 1 and 0. So 1 and 0 is 0, but then I would change it. I would change it to 1. I would find the complement. And 1 by 1 is 1, but for a NAND gate, that go on turn to 0. 0 by 0 is 0, but I go on turn to 1. 0 by 1 is 0, but I go on turn to 1. So maybe I should just show you the operation. I will do that. I think I'll leave understand it better like that. So this is just A by B. Right? This is just A by B complement. And for the OR gate, does anybody know what happens in the OR gate? Yeah, does anybody know what happens in the OR gate?
We have one high output, so inputs.
So
Okay.
operation is
Allow
Addition.
Okay.
Okay, some of them might be wondering, well, why the hell if I add in 1 and 1? Oh, charisma, your camera on. Yeah. Right? Some are probably wondering, well, if I have 1 and 1 and I add in, how is that 1? The reason is because we're dealing with binary numbers here. Binary numbers. And when you're counting in binary, it don't have, the only numbers you have are zeros and ones. Because binary means base 2. Okay, and for a NOR gate, it's the same concept. You just flip in the input, or you just flip in the output, right? So for an OR gate, you would add, or for a NOR gate, you would add and then flip it. So it's A plus B prime, or complement. So check it out. So 1, 1, 0, 0, 0, 1, 0, 1. If I add 1 and 0, that's going to be 1. So the opposite of 1 is 0. If I add 1 and 1, that's going to be 1. Opposite of 1 is 0. If I add 0 and 0, that's 0. The opposite of 0 is 1. If I add 0 and 1 is 1, so the opposite of 1 is 0. So yeah, you all could take a screenshot of this later. Yeah, or I could take a screenshot of this. Take a screenshot fast. Right, so I'm going to move on. Right. I'm gonna move on, right? Cool. So for the person that asked me, how do I know? You just had to remember it. So I would know that this was an AND gate because I remember it. This is an OR gate. I remember it. It's another AND gate. So all AND does is multiply. OR gates add. So whatever I feed it in, I add it. Whatever I feed into the AND gate, I multiply. That's it. That's the concept. Simple.
So you could go back 1 second there, please.
Okay.
Yes, so that's it.
Okay. So, question 53. Hadgi. I'm sure I'm saying that wrong. I'm sure I'm saying that wrong. Real wrong.
Haji, sir. My name is Haji.
Haji.
Yes, sir.
Yeah,
Haji.
yeah. Sorry about that. Sorry about that.
Yeah, you're
So
good, man.
I will help more question 53, right? So give that a read. Okay, I'm not hearing you. Not hearing you. Okay, I'm not hearing. I'm not hearing you. So I'm going to do the question. I'm going to do the question. So guys, let's eliminate some answers, right? This has a greater resistance than this. If this has, what's in? This, so I2 has to pass through a resistor with a greater resistance. I1 has to pass through a resistor with a lower resistance. So where would more current be? I1 or I2?
We do want less resistance. I1.
I1, right? So any option where I1 is less than I2 is wrong. So is A correct?
No, sir.
A is wrong immediately. B is wrong as well. And C is wrong as well. So like guys, you can figure out the solution by just doing that. Just by doing that. Yeah. Drop out.
Sir, you hearing me?
Drop out all in chat if you understand what I'm saying.
Sir, you hearing me?
Yeah, hearing you.
Oh, you, sir, it's like me something there glitch, like me not some nothing weird or like you could go for that, please?
You want me to go it over again?
Okay, yes, sir.
Okay, so you understand in this circuit, we have a parallel circuit and the current splits at this junction.
Yes, sir.
So where would most of the current go? 32 ohms or the 4 ohms?
To the I1, sir.
I1, because the resistance over here is less.
Yeah, yes, sir. Makes sense, yeah.
So any option where I2 is more than I1 is going to be wrong because we know that more current is going to pass through 2 ohm. So this option would be wrong. So this was wrong. This option would be wrong. And well, they can't be the same because they have different resistance values. And that leaves me with this option. That's my answer.
Oh, okay, yeah, yeah.
But let me show you the calculation because we were using calculations, right? I'm gonna run through it fast. The first way to do it is use the current divider law. The current divider law says that if I want to find the current in I1, it's going to be the second resistor all over the sum of the resistors multiplied by the total current. So in this question, if I want to find I1, I'm going to take R2. R2 is 4 all over 6. And I'm going to multiply by the total current. Total current in the circuit is 6 amps. So I'm going to get 4 for I1. Right? And if I know I1 is 4, what would I2 be? So if I know I1 is 4, what would I2 be? Because it splits from 6 amps. It splits from 6 amps. So if 4 amps is going here, how much amps is going here? Does anybody know? So I1 is 4 amps. So we start off at 6 amps, and from 6 amps, it splits.
So you hearing me?
Yeah, hearing you. Tell me, what do you think it will be?
Yeah, I said 2.
2 is correct.
Because 4 4 plus 2 would have given 6.
Yes. That's one way you could do it using the current divider law. Okay. The other way you could do it would have been to find the total resistance, the total parallel resistance. So to do that, I would have a bunch of different methods you could use, but I typically use this method. So if I want to find the total resistance in parallel RP, that would be 1 over 2 plus 1 over 4 to the power minus 1. And that should be what? If you work it out, you should get 1 1/3 ohms. 1 1/3 ohms. That being said, that's also to be written as 4 over 3 ohms. So the total resistance is 4 over 3 ohms. So I could take that circuit and write it like this. So if I were to write the circuit with using one resistor, it's going to be 4 over 3 ohms. And a current of 6 amps is going to pass through that. So if I want to figure out the voltage drop across the resistor, how would I do that? How would I figure out the voltage drop across the resistor? V is equal to can I hear anybody? But V is equal to IR. My current is 6. And my resistance is 4 over 3. So my voltage drop across the two resistors in parallel is going to be 3 into 6 is 2, 2 by 4 is 8. It's going to be 8 volts. So across the 2 ohms and the 4 ohms, I have a voltage drop of 8 volts. That's the situation I have here. So I have a voltage drop across of 8 volts. This is 2 ohms, and this is 4 ohms. This is I1, and this is I2. So if I want to find for I, I'm going to use V is equal to IR, and so I will be equal to V over R. And so V, for both of them is going to be 8 because they're in parallel. Parallel circuits have the same voltage. And if I'm looking at this one, if I want to find for I1, it's going to be the voltage across it, which is 8, all over the resistance rate, which is 2. And so I'll get back 4 amps. Cool. For the other one, I2 is going to be the voltage across the resistors, which is 8. And the resistance there is 4. So 8 over 4 is 2 amps.
Sir.
Yeah. Summer?
Yeah, sir, the formula where they write down for I1, I could have go back look up this, I could have write it down.
This
Yeah,
formula?
really helpful. Yeah, really helpful. I never learned it.
Okay, so that's the current divider law. So if I wanted to find for I2, let me show you how I'll find for I2. To find for I2, it would have just been R1 all over R1 plus R2 by IT. Notice you're using the alternating resistor. If I want to find the current for 1, I'm not going to use R1. I'm going to use R2. If I want to find the current going through the 4 ohms, I wouldn't use the 4 ohms, I would use the 2. Yeah. But guys, any common sense method makes sense. More current had to pass through I1 because the resistance is less. So you're looking for a question where the current for I1 is more. All you understand what I'm saying? Like the common sense approach?
Yes, sir. Yes, sir.
Yes, sir.
Yeah, and under all circumstances, that make the most sense to use on a multiple choice test, right? So Akida, let me know if you're there. I think Akida boss out. But Hagan, you understand the common sense method, right? Because I don't feel like all you're going to do all of this calculation in the exam.
Yeah, we understand.
You understand that the resistance here is less, so more current has to pass through here. So the only option,
because current follows the path of least resistance.
Exactly. So more current has to be going through I1 than I2. So common sense, the easy best, like use the common sense method. It's only if you forget, then you could use the current divider law, or you could use Ohm's law.
Yeah, I understand.
So which of the following materials is most suitable for the core of an electromagnet?
Soft iron.
Soft iron, right? Yeah. Soft iron. 55. This I repeat the answer. P is equal to E. B.
Sir,
Tell me.
sorry, the soft iron is the one that's easily magnetized but does not retain its magnetism, right?
Yes, that's correct. It also has
Okay.
a very low hysteresis loss. You can look up what that means.
Repeat.
It also has so soft iron, out of all these options, soft iron has
Yeah.
the lowest hysteresis loss, and additionally, it also has the highest magnetic permeability. Right. So basically what that means is, if we make an electromagnet, what I want is I want the core to be able to channel the electromagnetic field lines. So I want all of the field lines to be in the core. So I want all of the magnetic field lines to be in the core. So I'll use a material with a very high magnetic permeability. If all you're not going into electrical engineering, don't bother what I'm saying. This is just extra information now. So let me know if you understand what I'm saying. So if a material has a high magnetic permeability, it means that it will want the magnetic field lines to pass through it because it's very permeable to
Permeable, yeah.
magnetic field lines.
Yes, sir.
Yeah, so magnetic field lines can pass through it very easily. 56. Which of the following symbols would be possible for an isotope of a nuclide represented by AZX? Remember,
Sir, for this one, yeah, either like add 2 or subtract 2 from the mass number, right? But the proton would remain the same.
exactly. So when we're talking about the isotope, the mass number changes, but the atomic number remains constant.
Yes, sir.
So the answer for this is, I would say A plus 2Z. This one. A plus 2ZX. So we're changing the mass number, but we're keeping the atomic number the same. Right? 57. Which of the following cannot be deflected by a magnetic field? Which one here is not charged?
The
I can't see
Gamma.
the
Gamma.
yeah, this wire gamma rays, electromagnetic rays.
Gamma
I
rays
don't know why.
because
Yeah. Sir, it's like my screen and just a glitch. Like, oh, come back now. The gamma rays, yeah.
yeah, I
Alright.
hear what you're saying because gamma rays are electromagnetic radiation and they are just pure energy and they have photons and photons don't have a charge. So they wouldn't be deflected by a magnetic field.
Yes, sir.
So 57C. Right? 58. All right, we know the answer here. Iron is easily magnetized.
May I get ahead of myself?
So iron is magnetized and steel retains its magnetism well. So the answer is 58B.
Oh, yes, yeah.
Right? 59. Which of the following scientists discovered radium? Is I repeat, Marie Curie.
Marie Curie.
Oh, they're slandering the girl name, boy. Wait. Oh, you know she died because of radiation?
Yeah. She always or something like that.
You really had to die doing what you love, guys. You really had to. All right. I believe this is our repeat as well. What's the answer?
C.
C's the answer, right? Cool. So we'll take a 10 minutes break. We're gonna.
Go back, sir. Oh, yeah, go on. Okay.
Yeah, tell me.
Oh, yeah. Let's look for some.
I said your name correct, right?
Yes.
Haji.
Yes, sir. Sir, for this one, right, for like alpha radiation, the mass number always differ, but yeah, 4.
Yeah, that's the explanation.
Yeah.
The left hand side had to be equal to the right hand side. So this had to be 4, so I'll get back 226. This had to be 2, so I'll get back 88. And so 4, 2 is alpha. That is it.
Yes,
right.
Sir.
I feel like I will do one more paper and I'll call it a night.
Yes,
Yeah.
I'll got you one more.
And
Got you one more.
I will do some other papers and send it. I will upload YouTube videos.
Sir, you have like in the like you send links to these papers, so like in your class, students have access to it or what?
Yeah, so after class, I'm gonna send all the solutions I would have done today.
Oh, okay.
Yeah.
Yeah, I'm gonna join a class.
All right. So a little break, we just go straight into 28 the other year.
Let me take a break, sir.
Take a break. Kind of like taking a real break, but okay.
Pause. So I feel you could go straight into it now.
I feel so, I feel so. That's what I feel. This is okay.
What
No,
about
no, guys, let me go straight into it now. This is just a bunch of repeats. It's just a bunch of repeats, guys. Let me go. What are you waiting for? Let me go, right?
So speed run.
Speed run,
So
right?
7.5.
7.5. That's the answer. Why, shit, my Apple Pencil dead. Oh, God. Nah, boy.
So
Wait.
for 5 minutes.
Wait.
That's a sign. That's a sign. That's a sign.
Yeah, take a 5 minutes and we go speed run.
Yeah, that universe saying take a break.
Hey, Colleen. I see you joined finally. I didn't hear you in a long time. I was like, I'm not hearing your voice.
So I really just sit down taking it,
Ah, I see.
I study one
I just listening and taking it.
I see. Oh, it's just there. The information reaching all your brain through induction.
So when I build up the
because I
funds, I'll
didn't
help you build
understand
up the school.
Thank you. Appreciate it.
I mean, it clearly not because I didn't understand it, joke. So I had to take it in some more.
That's okay. That's okay.
Guys taking a break or
Yeah, we're taking a 5 minutes break. Come back in 5 minutes. Whatever all the time
okay.
is, just come back in 5 minutes. So in Trinidad, that'll be 9:58. Yeah.
Okay.
Yeah, we will speed run this. This paper easy. Real easy.
So scroll I feel like I know like 80% of all them questions.
Like what I see and I look at it and I was like, hey, cake, that real cake. Real easy. Right, so I come on back. Don't talk shit in the meantime. Try to keep it PG because I recording this. And like when I talk, all the names pop up and it will be on a YouTube video and people go see what they're talking shit. Yeah. Next thing all them mother see it. Or your father licks buddy. Licks.
If you haven't already, make sure to like and subscribe. Share it to everyone Even your granny, she could learn something.
Yeah. Send it to your dog, copy the link, post it on your
Send it to your
Instagram,
dog
everything.
Send it to
Yeah,
your dog.
comment, like, subscribe, everything.
Yeah, share
so
it, share
also
it, share
have
it.
a TikTok. Go look him up on TikTok. Follow all the socials.
One time, big up.
I had to say, I'm happy that I know how to promote myself. I promote someone. That's good. That's good. Yeah, so I come back. Okay, I'm back. But I still have 3 minutes on the clock. So yeah. I feel like we could finish this particular paper in 10 minutes. If we speed running it. 10 minutes. I think so.
So I hope the exam come like this tomorrow.
Yes, sir.
I mean tomorrow, Friday. Wait, when is the exam?
When is the exam? What? Bro,
Friday evening.
Friday.
boom,
The
Mukla.
exam is
Friday.
in the afternoon.
You see, you ready? You reach a threshold now. You so ready, you don't know when the exam is. It is like a point of no return. You're that ready. Like the only thing that on your mind is physics. You're not studying any date. Just physics on your mind.
Thanks to the best teacher in the world.
Nah. You cannot butcher him up, day. Cannot butcher him up. Don't have to trust you. I just be trying my best, you know? Just be trying.
So very we appreciate it. We appreciate it very much.
Thank you. I'm gonna drop the YouTube channel and TikTok and thing, or I'm gonna drop a follow and thing, you know? So the YouTube is. Oh yeah. And like I currently accepting Form 4 students, so they go like spread the word now. Because you know anybody that need Form 4 lessons, hit me up. Kishiva, you still in class?
Yes, sir.
Hey, look here, you're pulling through, man. Renisha, no problem. It's my pleasure. My pleasure. Right? Which part of South you from? If you don't mind me asking.
Penal.
What? We're right there. Right there. I live in
So
India.
it's still raining?
No, it's not raining right now. It's not raining by now.
Place
But
get hotter.
well, I find the place still cool. Never mind now. Open the window and I feel the warmth. Never mind. How do you see on?
So rain and more rain.
That is not a problem.
Get some rain now, boy. Send some.
Rain is not a problem. We want rain. Rain is the best thing upon the earth. Unless you're traveling, which in that case is not very nice. Bread
again.
Bread again? What do you mean? Jamaica hot like fireside. Haji, which part of Jamaica are you from?
Westmoreland, sir.
Okay, that's like in the main part of Jamaica or like?
Yeah, like the west part.
Okay, all right. Good. Right. Let me begin, right? Let me begin. Speed run. What percent of Apple Pencil reach? 63? Okay, we'll work with that. What's your first answer?
7.5.
Right, 7.
Yeah, B.
Right, 2. Mass by acceleration. That's kg ms minus 2.
D.
Right, kg ms minus 2. 3. That is x plus y to the left.
Right. Sir, yeah.
Because we have these two forces that would combine going to the right, and so x plus y to the left to keep it stationary.
Yeah.
Is that repeat?
Net force here. Yeah. What happened?
A.
I like this paper so far, boy. Oh, good. Right? 2 and 3. C. Uniform momentum is?
B.
Right? Because it's mass by velocity. A 4 kg, 10 newtons.
P.
Wait, boy. 8D.
P.
Q. A piece of string is tied onto a small stone, and then the stone is totally immersed in water. The tension in the string will be, well, it wouldn't be 0. It wouldn't be equal to the weight of the stone.
So it would be C.
It would be C.
C.
The reason why it would be C is because when you place the stone in the water is going to give it an upthrust. And so it's going to decrease the perceived weight. Everybody understand? The buoyant force is going to cancel off with some of its weight. That's why some molecule do push up in the ocean while they can't do it in real life. Or they can't do it in the air. No shots fired. No shots fired. Anyways, 11. Which of the following properties remain unchanged?
E.
Wait to see if I realize, boy. Okay. When a ball is thrown vertically upwards and it reaches its maximum height, it has
maximum potential energy, but the kinetic energy.
Maximum potential.
Right. Think about it. When you reach the maximum height, remember the formula for potential energy is mass by gravity by height. So if the height is the maximum, then you have the maximum potential energy. And at that point, stationary, it's going to convert to kinetic energy when it's falling down. So 12D.
Energy and motion.
Yes. 13. The time period of a simple pendulum oscillating with a small amplitude depends on the length of the pendulum.
Length.
This one is 1 and 3. So that's B.
1 and 3 only.
Which of the following is an SI base unit?
C. Ampere.
Amperes. Right.
E.
Wait, I'm going to read it. Which of the following implements are designed to take advantage of large moment provided by a small force? So crowbar is one. A pair of tweezers. What you said the answer was? I'll tell you if it's correct.
1 and 2 only.
What is that claw hammer? Let me check what a claw hammer is. I never see a claw hammer in my life. Oh yes, I did see a claw hammer in my life. I did see a claw hammer. So a crowbar makes sense because when you use a crowbar, the point at which you hook something, that's a pivot, and you would, when you exert a force, you'll create a moment. So crowbar, any option that doesn't have crowbar in it is false. So this is false. A claw hammer, a pair of tweezers. While they're saying that tweezers, I'm trying to think about it. A tweezer. Or they think a tweezer. I don't think so, you know. A tweezers? How does that generate a moment?
So I don't think so.
I don't think so. That don't make sense. But
it's turning. I don't think no.
I think the answer is 1 and 2, right? Because a claw hammer this look like this, right? And NT would hold a claw hammer at the base so that when you hit something, the force will be multiplied. That makes sense, right?
Yeah.
Yes, I would say 1 and 2. 1 and 2 makes sense. A tweezer, what tweezer had to do with moments?
No turning force not gonna generate. I think no.
Let me show you. This is a regular hammer, watch. But until I agree. And the longer
no turning force.
Yeah, the longer the handle of the hammer, it would kind of decrease the force that you would have to exert to hit something with. You could see, so like in a hammer, when you hold this, that's kind of like the pivot, and you would apply a force, and this is the distance. Yeah. So I'm gonna call you understand that. I'll call asterisk by this, but this is what I think makes sense. Because at least I don't have anything to do with moments. Are they okay? I'm gonna follow you, okay?
Yes, sir.
All right. Let's move on to 17. There are no attractive forces between the molecules in a
Yes.
gas. Right? A gas, the molecules are very loosely bounded and they're just moving about randomly. 18. Which of the following statements about the pressure law are true? So somebody tell me, what's the pressure law fast?
Sir, for a fixed mass of gas at constant volume, at fixed mass of gas at constant volume, what pressure is directly proportional to temperature or something like that.
Right. So it says that if you increase the temperature, so the pressure and temperature are directly proportional.
So P over T would I get K.
So you have to keep the volume constant, so that's true. You have to keep the volume constant. Part 3 is wrong because the pressure is changing. And part 1, the ratio of pressure to Kelvin temperature is constant. That's true.
So sorry, so that is like P1 over T1 would like be a K now.
Yeah.
Okay.
Ratio to pressure to temperature in Kelvin. So we're looking at 1 and I would say 1 and 2. All right, so what's the answer?
Yeah. So
Here.
1 and 2, so A.
Right. 19. What should this I repeat? The answer is 35 to 44.
Yeah.
20. The specific latent heat of vaporization of water is the energy required to change 1 kg of water at 100 degrees Celsius to steam at 100 degrees Celsius. We're dealing with that change in state there. 21. The energy required to change doubled. So I repeat. Right? 22. This I repeat again. The answer is
D.
Right? D. 23. Which of the following materials is both a good absorber? This I repeat. D.
D,
right?
Yeah, makes sense.
This I repeat again. So when we're talking about steam, we're talking about absorbing 2.26 by 10 to the power. A is the answer. Convectional currents.
Excuse me.
Convectional currents would be B. Are you agree?
Yeah.
Right?
Sir.
Okay. 26 is a repeat. Water is a heat.
No, B.
Water.
Yeah.
Water, C. I'll keep saying answers. Let's take your time. C. C is the answer. Water is a poor conductor of heat. Is I repeat again? L was infrared, R was ultraviolet.
So it was D.
D. A student carries out an experiment to determine the specific heat capacity of a solid using the electrical method. The answer for this is C.
C.
Right? C. Okay. This is a repeat. What was the answer?
PS.
Yes. I'll pray to God a formula has come.
I pray in this whole paper come.
A.
Yeah,
A. 30
Right, let me just verify. Which of the following equations expressions represents the correct relationship between the wavelength, speed, and frequency?
A.
Let me just verify that. So V is equal to F lambda. So F would be equal to V over lambda. That's correct. So yes, E.
Yeah.
Right? Okay, this I repeat again. The answer is B. So item 32 refers to the following. Yeah.
C.
So sorry to interrupt, but did you send the paper that's previously corrected?
No, I didn't send that paper. Didn't
Okay,
send that one.
don't forget to send it, please.
All right. Let me just remind her, right? But I will send it. I promise. Right? 32. Item 32 refers to the following diagram, which shows a longitudinal wave where C and R represent compressions and refractions, respectively. If lambda is the wavelength, the distance between C1 and R1, okay, C1 and R1, that would be, okay, so you saying C is the answer? Wait, so let me just double check that. So we have a compression here, and we have a refraction over here. So C1 to C2 will be one wavelength, and so between C2 to C3, they have R2, and that will be half of a wavelength, so you're correct. So it's 1.5. Let me just explain that one more time for anybody that doesn't catch it. So remember, the wavelength is the distance between a successive compression or a successive refraction. So, and everybody understands that C1 to C2 will be one wavelength? Yes or no?
Yes, sir.
And so C2 to C3 would make that two wavelengths. But we are stopping in the middle. We are stopping in the middle. C1 to R2. So this is going to be 1.5 of the wavelength. Everybody understand?
Yes, sir.
Yes, sir. Which of the following diagrams illustrates the law of reflection? Is the answer. Is the answer.
They are equal.
So easy, oh my god.
Yeah.
Right? Because remember, for refraction, maybe I'm saying refraction, for the reflection, angle of incidence must be equal to the angular reflection, right? Must be the same, like a mirror. 34. Which of the following properties is true of both light waves and sound waves? They undergo refraction.
Yeah.
The amplitude of the wave is 4. Find out what would the frequency be? Not frequency. What would the wavelength be? If I ask you wavelength, what's the wavelength?
7.
7, because we have 3 full oscillations, and so 3 into 21 is 7. So 1 oscillation is 7 centimeters, in case you change it up. The refractive index of a transparent medium with a critical angle C for light traveling from the medium to air is? All right. So let me show you.
I want to say D.
Let me see. So N is equal to sin I all over sin R. Wait, so a transparent medium with a critical angle C for light have a specific formula we had to use here. I think that was equal to 1. I mean, if C is equal to 1 over sin N. Let me just verify that. Unless it was N is equal to 1 over sin C. Yeah, it would have to be this one. Yeah, this is the formula, and guys, just remind me. And N is equal to 1 over sin C.
It is.
And so N sin 90 is 1. And sin 90 is 1. Just verify that. Sin 90 is 1. So the answer is B, right? But let me show you the full working. So to work this kind of question out, I would use Ni sin I is equal to Ni sin R. And so we're dealing with the critical angle. So at the critical angle, we're going from a denser medium to a less dense medium. And so Ni would be the refractive index of the medium we're going from. So I'll leave it now blank. So that'll be Ni. And the angular incidence is going to be the critical angle. And this is going to be, we're going to A. So that's going to be 1 by sine. And since we add the critical angle, the angular refraction is going to be 90. So Ni would be equal, well, yeah, so Ni is going to be equal to sine 90 all over sine C. If you understand what I'm saying, drop a 1 in the chat. That's how I would do it. If I didn't know N was equal to 1 over sine C. Ni sin I is equal to Ni sin R. I go in from the dense medium to air. So I don't know what Ni is. If I add the critical angle, then the angular incidence is going to be C. If I go into air, the refractive index for air is 1. So that's why I say Ni was 1. And if we add the critical angle, angular refraction is 90. So 1 by sine 90 is just sine 90. So sine 90 over C. Everybody okay with this? Yeah, no, maybe.
Yes, sir.
Okay,
Yes,
I'm gonna move
sir.
on. An explosion causes the emission of the following types of waves. Which of these will
Light and
be
infrared.
first? Yeah.
The light and infrared waves, but they travel at the same speed.
No, I want you to understand something, right?
all three.
Infrared are all on the EM spectrum, and everything on the EM spectrum travels at what speed?
Light
Right.
speed.
So-
the 8 first person.
So technically, it would be 1 and 3, right? And 1 and 3 would be going at the same speed. So 1 and 3. To the 8, the note from a drum is a repeat amplitude. Which line lies along the principal axis of the convergent lens?
JK.
JK, that's correct. So this over here, this is the principal axis, right, guys? And so J to K would lie on the principal axis. Right. Just parallel label. Principal axis. Right. Rectification can best be done by using a diode. Because a diode only allows the flow of current in one direction. Did you know that? Yes or no?
No, sir.
Yes, sir.
Yeah, so like the picture I saw with the little black things in a square, that is a full wave rectifier. Yeah, that's a full wave rectifier. That's what I'm talking about. right?
Sir, so I convert alternating current into direct current.
Yep. All right. Does I repeat? What's the answer? What's the answer, guys?
C.
C is the answer, right? Yeah. Because that's the only circuit where the current does not split, and that represents a series circuit. 42. Okay, we have a nice question here. Given the following truth table with inputs A and B and C, which logic gate does it describe? So let me see what's going on, right? So we have 0 by 0 and we gain 1. 0 by 1 we gain 1. 1 by 0 and we gain 1. 1 by 1 is 0. This is looking like a NAND gate. I will explain why. So in a NAND gate, you would multiply the inputs and you'd find the complement. So let's see if this is the truth. So if I multiply 0 and 0, I'm gonna get what?
0.
And if I find the complement of that, I'm gonna get 1. Yeah. What is 0 by 1?
0.
0 and the complement of 0 is 1. 1 by 0 is 0. The complement of 0 is 1. 1 by 1 is 1. The complement of 1 is 0. So that's a NAND gate. Yeah.
So, you could run that back, please.
Okay, no problem. Did you take a screenshot of this?
That's I didn't get one time.
Okay, so let me explain this back fast for you, right? So in a NAND gate, what you're gonna do is you're gonna multiply the two inputs and flip wherever you get. So let me show you an example. So if you have an input of 1 and 0, you're gonna multiply that. Cool. And if you multiply 1 and 0, what are you gonna get?
0.
What's the opposite of 0?
1.
Yeah, NAND gate. 1 by 1 is?
1.
Opposite of 0? I mean, opposite of 1?
0.
0 by 0 is?
0. Opposite of 0 is 1.
I think you get the idea. So that this represents the behavior of a NAND gate. That's what NAND gators do. A NAND gate, you just multiply the two inputs and flip it. That's all. You good?
Yeah, thanks. Sir.
No problem. So this is a NAND gate. Which of the following equations cannot be used to determine the power dissipated in a resistor?
First C.
C. C is a wrong formula. Is V squared over R. Is V squared over R. This formula is a lie. This is the correct formula for it. Right? Yeah. P is equal to VI, P is equal to I squared R. Watch, let me show you what I mean, right? So what I could do is I could probably make I the subject. If I make I the subject, I will be equal to V over, no, I will be equal to P over V. And so, no, I want to find, wait, I'm going to try that. So that'll be P is equal to, but then that will be P squared over V squared by R. And so I would divide both sides. Nah. And I'd have to find the inverse. Okay. P is equal to IR. P is equal, I just want to draw a couple of things here. P is equal to VI. And so V is equal to IR. So I could say P is equal to I squared R, right? Okay. And R is equal to V over I. Does anybody know the correct answer? I know for a fact that this is correct and this is correct, right? I know for a fact A and B is correct.
It's C.
It's C. Do you know why it's C?
Because isn't the form the alternative formula V squared over R? I've never seen R over V squared.
Say that again.
I've never seen R over V squared, but I've seen V squared over R.
Yeah, V squared over R does look familiar, but I want to figure out the formula, I want to figure out the derivation. So I know that, I'll come back to this. But yeah, the answer is C. But I want to derive the formula the same way how I could derive I squared R. Yeah. So I'm going to do that. I'll come back to that. This I repeat. What's the answer?
B.
B is the answer, right? 45. Which of the following circuit symbols represents a fuse?
B.
B. The first symbol is a diode. The third symbol is a bulb. And the last symbol is a galvanometer. Right. 46 is a repeat. The answer is E. Best material for a core for electromagnet. Soft iron, 47D. An ammeter has a very low resistance so that it can be placed
in series.
Right? B, right? Does I repeat with the answer?
3 amps.
Right?
D.
Which of the following symbols represents the AND gate? So the AND gate, which one is the AND gate?
B.
B, right?
B.
And what would this represent? Is that what kind of gate?
And
NAND. Anytime you see the little circle, just add an N to whatever. Just add an N, right? So this is our what kind of gate? What kind of gate is this?
Or?
Or, right? And if I add the little circle to it, that'll become a what?
No.
Yeah. Okay, nice. I don't understand the thing. What's the answer for this?
1.2.
Wait, 1.2, right? Which device allows, the answer is obvious, magnetic relay. Right, what's the answer for this?
Step up transfer.
Is A. No, sorry, C.
C. Step up, AC input, right? A transformer. Well, this one, it have more coils in the secondary, and you need an AC input to induce a current in the secondary coil, in accordance to Faraday's law. So C is the answer, right? 54. Which of the following is a repeat? What's the answer?
Positive charge not penetrating.
D.
Oh, D.
D.
Sorry.
Half-life is defined as? What do you all think?
A.
The time so half-life is just basically the time it takes for anything to become halved, right? So A says the time it takes half of the radioactive atoms in a sample to decay. Yeah, this answer is somewhat correct. Let's check out the other answers. The time it takes the radioactive atoms in a sample to decay, no, has to be half. Half the time it takes, nope. Half the lifetime, nope. The answer is A. So I'll understand in A, they're saying the time it takes to half a quantity. That's what half-life is. Basically, how long it takes for something to become halved. Right. Are they okay?
Yeah, yes, sir.
Yes, sir.
Okay, 56. So we have to find half-life here. So let's find half-life for this. So where's half of 400? 400 would have been the initial. Where's half of 400? 200. And so where's the time in days for that?
2 days.
All right, so the answer is 56B. Okay, 57. Nuclide 23490TH contains. So we know it has 90 protons, and to find the number of neutrons, you would subtract the atomic number from the mass number. So 234 minus 90, and that'll be N. So we're getting for that. Should get 144.
Yes, C.
C is the answer, right? 58. Which of the following statements about radioactive decay are correct? This I repeat, the answer is 2 and 3. C. Which of the following statements about a proton is not true?
That is the same as an electron.
That's correct. The mass of an electron is, I think, like 1 over something. 1 over 1192.
1 over 1080. 1 over 1840.
Yeah, that's what I'm looking for, right? So that's not true. D is not true. 60. An isotope of uranium 23492U changes to 23090TH. This is an example of?
It's A, alpha decay. 4 over 2, sir.
Right,
4
because...
So I get it this time.
You did get it this time. Nice, nice. Yeah, somebody was saying something?
You could explain this one, please.
So 59 is B.
Which one you want me to explain?
This last one, 60.
Okay, so we're going from 23492U to 23090TH. And so to go from uranium to thorium, the uranium would have had to emit a what? Let's see. So we had 234 originally, now we have 230. That means we're going to end up with our emission with what on top here? What's it going to be? So we start off with 234, and so we have 230 here. So what happens to the rest? It's going to be emitted, right? So that's going to be 4 here. And what about over here? How much was emitted from the atomic number?
2.
2. So what does this look like? 4, 2. Which decay? Alpha, beta, or gamma?
Oh, so I see my problem here. I don't know what's any other days. So,
Oh,
yeah.
so alpha is 4, 2. Beta is this. Gamma is 0, 0. Right? And if you want to learn it off as how it exists in nature, I'll also provide that. So alpha exists as a helium nucleus in nature. So that's going to be 4, 2, He. Beta exists as an electron in nature. And well, gamma is just electromagnetic radiation. It remains the same. So yeah, take a mental snapshot of that. All right? Yeah,
Thank you, sir.
no problem. I wanted to move on to the next paper fast, because I feel like we do enough questions to just be done.
I figured out the derivative.
Are they okay?
So the next paper is 21.
Yeah. All I want to do is speed run that or call it a night.
Speed run.
Speed running.
Yes, sir. Let me go straight.
Okay, give me a second. Right? Somebody messaging now. Let me just charge my Apple Pencil in the meantime while I respond. All right, guys. Let's go, right? So, power can be defined as?
Work done over time.
Right.
Yeah.
Number 2 is?
B.
B.
Let me see.
B, sir. It's B,
B,
sir.
right? B, how to take it at a right angle.
Yeah.
Which of the following pairs consists of fundamental quantities? Can be weight, so 2 and 3.
D.
2 and 3.
D.
What would be the magnitude and direction of a third force, which would be B, right? It will be x plus y to the left.
B.
This one is gonna be
B.
It's gonna be B, right? Do you all know why?
Pythagoras.
Yeah, Pythagoras theorem, right? So this would be L, this would be M, right? Think about it like this. If we know the resultant force, you would just need to apply that same force but in the other direction. So to figure out this resultant force R squared is going to be equal to L squared plus M squared. So the resultant vector here, by the way, force is a vector, right? So the resultant force here is L squared plus M squared. So if I want to keep this object stationary, I would apply another force but in the opposite direction. That's going to be L squared plus M squared. Are you understand what I'm saying?
Excuse me, sir.
Yes, sir.
Okay, wait. Question 6.
Excuse me, sir.
Yeah.
For 4, how come it's to the right or not? How come it's to the left and not to the right?
Okay, check this, right? So we want to keep the object stationary. I don't know why the screen is showing. Okay.
Oh, you wanted to keep it stationary. Okay, now it makes sense. Thanks.
Okay, you sure you understand that? 100%?
But so
Yeah,
wait,
I didn't read the top of the question. Sorry.
That's okay, Colleen. Yeah, tell me, Colleen.
but so in truth, how it wouldn't be to the right, it wouldn't be x plus y to the right.
What is right?
If you putting it to the right, you'd be pushing the object further. Since you want to keep it stationary, gotta get opposite force. Equal opposite force.
Yeah, that's the perfect explanation. So, Colleen, you see that we currently exerting a force x and a y. What direction is this to? You left or you right?
Oh, I'm sorry. I don't know my left from my right. My bad.
Bringing back memories from Fleming's left and right hand rule.
Yes, sir. You traumatized me with that already. You thought my hand was back to front or something.
Oh, right. Question 6. Which of the following changes can be caused by a force acting on a body? The answer is D.
Shape and motion.
Let me explain why. Now, if you apply a force to a body, the shape going to change. Think of aluminum foil, right? If you take a sheet of aluminum foil and you apply a force to it, obviously the shape is going to change. Depending on how you apply the force, I would just say kick something, it could gain motion. And now the density part, let me explain something. Guys, if all you have bread, right, and all you exist a force on the bread, what happens to the density of the bread?
It decreases because the volume decreases.
Exactly. If you apply a very strong force, the volume decreases, and if you're taking up less volume, remember, density is equal to mass over volume. So if the volume is decreasing, then the density is going to increase. Yeah. So I hope you understand that. This is a kind of chain of question. Because if we're talking about fluids.
So you sure? I think it's E.
I would say D because Javon, again, take for instance, if you exert a force on aluminum foil or like a hydraulic press, what happens to the object? Doesn't the density of the object increase? Because you're decreasing the volume by applying a force.
Yeah.
Yeah. So I would say the answer is D. Now some people would say the answer is A. You see, they never specified, right? Because if we're talking about liquids are incompressible and the density wouldn't change. But if we're talking about gases, if you compress a gas by applying a force, the density is going to increase. But I personally would say D, right? I personally would say D because I understand what I'm saying. If you apply a force to something, if you apply enough force, the volume going to decrease, and if the volume decreases, the density will increase. Yeah. Hagan, you understand what I'm saying? Hagan, you understand what I'm saying?
Yes, I understand.
Because then when you squeeze bread, okay, if you squeeze bread, doesn't the density of the bread increase because you're compacting it?
Yeah.
Yeah. All right. Question 7. Item 7 refers to the following diagram, which shows two different size containers, P and Q, with water at different levels connected by a glass tube and controlled by a tap. When a tap is opened, water will flow from P to Q until what?
The water levels are equal.
Yeah. That's correct. The water levels are equal. Right? Does anybody know why?
Concentration gradient.
No, I wouldn't say concentration gradient.
Both of the same pressure.
It has to do with pressure, yes. It has to do with pressure. So I want you to think about it like this. And if we expose something to the atmosphere, and it's going to have atmospheric pressure, yes or no? Yes or no?
Yeah.
Yeah. And so you have atmospheric pressure pushing down on this liquid. Now, until you remember that pressure is equal to height, until you remember that pressure is equal to height by density by gravity.
Yeah.
So, because this is exposed to atmospheric pressure, it's going to cause the liquid to go into Q until the heights are equal. And when the heights are equal, it'd be at equilibrium because the pressure acting on P and acting on Q would be the same. You see what I'm talking about, but that's it. So it would need to reach equilibrium. The heights would have to be the same. And that's when it would stop. I'm going to give you an example, right? If all you blow into a straw, any drink would come up. Yes or no? Yeah, like, okay. If you
Yes.
yeah, like
If you blow into a straw,
okay, if you have because the straw is submerged in a liquid, right? And you blow into the straw. If you blow hard enough, wouldn't the liquid rise? Because you're blowing air into the system. Yeah. I really had to show you some experiments. But the reason why this working is because the atmospheric pressure is going to be more over here and over here. And so the atmospheric pressure is gonna exert a force on this. And because the force here is less, the liquid is gonna move from P to Q until both of them are at the same height. And at the same height, they'll have the same pressure because they'll be at equilibrium. Yeah. So Javon, you understand what I'm saying?
Yeah.
Yeah. So you knew the reasoning, like the full reasoning.
Yeah. Well, yeah. No, sir.
Okay. Eight is a repeat, right? What's the answer?
1 and 3.
So 100.
Right? So B. The kinetic energy of a body, that's mv squared over 2. That's a repeat. Which of the following will be constant if a constant net force is applied? Acceleration. Right? Because remember, F is equal to ma. And so if I make A the subject, you'll get F over m. So if F remains constant, the acceleration remains constant. Question 11. Pressure in a liquid can be calculated using the formula P is equal to density by gravity by height. Which of the following sets of units will result in the SI unit of pressure? So what's the SI unit for density?
Kilogram per meter cube.
Right. And for gravity?
Newton per kilogram.
And for height?
Meters.
Right. So D looking like a correct answer, but it's wrong because the other two units are wrong. So the answer is B, right? Answer is B. So kg per meter cube and meter and gravity is newtons per kg. Are they okay with that? Let me know.
Yes, sir.
Okay, word. 12. An ice cube sinks as a repeat. What's the answer? Repeats. What's the answer, guys?
A.
Is the answer, right? Okay, the pressure on the dam and the bottom of the reservoir depends on the talking about pressure as a result of liquid.
The depth of the water.
Depth of the water, that's correct. Because depth corresponds to the height. Remember, pressure is equal to density by gravity by height. Which of the following is an SI base unit?
Ampere.
Amperes, right?
Okay.
From the graph, it can be deduced that the runner is, okay, so we have a displacement time graph here. Right, so what do you all think?
B.
Going at a steady speed.
Going at a steady speed, because if you find, well, it's supposed to be velocity here, because we have a displacement time graph. Very poor on CXC part. Because
so it should be velocity instead of speed?
It should, because you have displacement over time, right? Well, all you can see that is it going up at a uniform rate. And if it's uniform, that means if I find the gradient at any point, it's going to be the same. And the gradient for displacement time graph is velocity or speed. And so the answer is going at a steady speed. B. It's not going faster and faster. It's not going faster and faster. Don't make that mistake.
Sir, if it was going faster and faster, would it start to curve?
Say that again?
If it was going faster and faster, like would it start to curve?
Yeah, it starts a curve. Because you understand that this represents a linear increase, right? It's a linear increase. So at all the points there, the gradient is the same. So velocity will be the same for a straight line at all points. So will speed. Right, this is a repeat here. Question 16 was the answer.
A.
A is the answer.
1.
We know this answer, this could be less than the weight of the stone because of the buoyant force. 18 was the answer.
1,000.
Right?
1,000 joules.
Who was responsible for arriving at the mechanical energy of our joules? Anytime is the energy joules.
Joule.
Does I repeat, was the answer?
D.
D is the answer, right? 21. What's the answer?
A, sir.
E, correct. Because it has to absorb, going from water to steam, it has to absorb heat. 22 is the answer.
27 degrees Celsius.
Right? 23 was the answer.
Room temperature only, that is false.
Yeah, that's a lie. Which of the following is the porous conductor of thermal energy?
Yes.
A.
The air.
All the others are example of metals, and metals have free electrons, so they're very good conductors of heat. Okay, I don't even know how to look at this. I can tell you the answer is C.
C.
Yeah, because we change in state, and anytime we change in state, you have the latent period, which is represented by the straight line, and this is a repeat as well. 27, this is a repeat as well. What's the answer?
1 and 3.
1 and 3.
1 and 3, right?
No, sir, 1 and 2.
Wait. They switch up things. Here.
1 and
switch
2.
up things. Yeah. So they switch up things, right? You see why I had to be careful? So if you remember, the purpose of a vacuum flask is to maintain the same temperature. So you don't want the temperature to be influenced by the environment. So you don't want to be absorbing heat from the surroundings. So it's 1 and 2.
So it would be
right. Right, so it could be. Anybody confused by that? Yeah, take it, everybody understand that. Cool. As the temperature of a liquid rises, what happens? Let's repeat.
Kinetic energy increases.
Yeah, the kinetic energy increases. A light bulb is filled with a gas at a temperature of 293 Kelvin. All right, if the initial pressure of the gas is P, what will be the pressure when the temperature increases to 360? Okay, so what are we dealing with here? Pressure law, Charles' law, Boyle's law.
Pressure law.
Right. So P1 over T1 is equal to P2 T2. They already converted the temperature to Kelvin. How nice of them. Why do you know? This will be T1, right? It's P around a bit too much. So what's the initial pressure? Do I know that?
P.
293.
Just P, right?
293.
No, 293 Kelvin is temperature. That's the initial temperature.
Pressure is P.
Right? So the initial pressure, they said it was P, right? So I just replaced P1 with P. What's the final pressure? Do we know what that is?
P60.
No, we don't know what that is because they want me to figure out that. So I'm going to leave that as P2. And what's the new temperature?
360.
So I want to find for P2, so I'm going to cross multiply, or I could just multiply through by 360. But I know students understand the cross multiplication better. So that's going to be 360P is equal to 293 P2. And so to find for P2, I would have to divide both sides by 293. So P2 is going to be equal to 360 over 293 by P. So where's my answer, guys?
D.
Right, my answer is D. Right. Question 30. What's the answer?
A.
Water is a poor conductor of heat.
A. Right, the human is incapable of hearing a silent dog whistle because why?
The
It's the
frequency is
frequency of the waves are above the range detected by the human ear. C.
Remind me, guys, what is the range of human hearing? In case I ask that,
20 hertz,
20
20
hertz, 20
kilohertz.
kilohertz.
right? Cool. An echo is quieter. There's a repeat, smaller amplitude, right? There's a repeat as well, 1.5 wavelength. There's a repeat as well. What was the answer?
1.6 times
D.
27.
I'm hearing a bunch of different answers. Somebody tell me.
E.
D, sir.
D. Yeah, D is correct. Which of the following diagrams best represents the wave generated in a ripple tank by a small
sir.
spherical dipper? E? Yeah, that's correct. Yeah. Notice that at a constant frequency, so this is going to be the answer. This represents frequency changing. Because remember, frequency and the wavelength is correlated, right? V is equal to F lambda. So if the frequency changes, wouldn't the wavelength change? Oh, you understand what I'm saying, right? V is equal to F lambda. So F is equal to V over lambda. So if the frequency is changing, or if I make lambda the subject, lambda will be equal to V over F. So if I change the frequency, then my wavelength will change. But since the frequency is constant, my wavelength has to be the same. Guys, notice the wavelength here is changing, right? So this represents the frequency changing. 37, where's the answer for 37?
Always undergo refraction, refraction, and interference.
Right. C, all waves undergo reflection, refraction, and diffraction. That's true. 38.
So they go to interference as well.
Say that again?
They go to interference as well.
That's correct. That's correct. But it didn't include that, but yeah, that's correct. 38. Which of the following objects can detect X-rays?
Photographic film.
Right, photographic film. Right, 39. A ray of light, we know the answer. It will be undeviated. Right. 40. The position of an image was the answer. Let I repeat.
Distance of object from mirror.
Right.
B.
The answer for this is C. Sin 90 over sin C, right? This was a repeat as well. From the previous year we just did. Which of the following diagrams is a graphical representation of current versus potential difference for a metallic conductor at a constant temperature?
D.
The answer is D. The answer is D. Does anybody know why the answer would not be E? Let me ask you a question, right? Let me ask you a question. Nth V is equal to IR? Yes or no?
Yeah.
Right.
Yes.
So if V is equal to IR, and from this relationship, we know that voltage and current is proportional to each other. Yes or no? Yeah, we know that. So we're supposed to get a straight line graph, and the gradient will be positive. So it needs to be going in this direction. This one over here gives us a negative gradient, so we have to be careful. Right? Cool, I'm going to move on. 43. What is the answer? They're talking about a polythene rod.
Negatively charged.
B, sir. Negatively charged by gaining electrons.
Ah, you know the thing,
So you could give him a round of applause.
All right.
Big up Pagan. Pagan Alexander. By chance you related to Marlon?
Marlon? Who's
Yeah.
that?
You know Marlon Alexander? Man.
Oh, Roger Alexander?
What's his Marlon? No, we have wrong with man. Roger, yeah. You related to him?
No, not related to.
Sure that's not your uncle?
I ain't sure. Nah, probably.
All
You
right.
never know.
Pagan, while after, tell me the answer for 44.
C.
C is
Q
the
equals
correct formula. There's a repeat. Right, this is a repeat as well. What's the answer?
B, sir.
B.
1.7.
Right. Two light aluminum spheres A and B are suspended by insulating threads. If they come to rest, as shown in the diagram, the force keeping them apart is electrostatic. That has to be electrostatic. Yeah. Let me know if I understand that.
Yes, sir.
So it would not be magnetic, right? Because it's aluminum spheres. Aluminum on its own is not magnetic. Centripetal, no, that's not centripetal. Centripetal is the force you get when you rotate something in a circle. Can't be gravitational because gravitational would result in these things actually swinging, right? And so it has to be electrostatic because you're dealing with two light aluminum spheres and we're talking about insulating threads. Maybe the threads had a charge. We should be following current sine graphs best represents a DC current. What's the answer?
A.
A, right? All the others are alternating between positive and negative. What's the answer for this one?
C.
Step up. Transformer.
AC input, right? Rectification is best done by?
A diode.
Diode. Okay. Part X, what's that?
Slip rings.
Slip rings.
Right, that's slip ring. If you don't know what it is, it kind of looks like a ring, eh? So like, even if it guesses, you're gonna get correct. All right, what's the answer for this one?
B.
Right. Item 52 refers to the following diagram, which represents a straight wire carrying a current into the plane of the paper. So which of the following diagram best represents the magnetic field around the wire? So guys, we had to use for this.
Screw.
The right hand.
Right hand rule. Grip rule.
I was right hand grip rule, right? So what you're gonna do is you're gonna use your right hand, right? You're gonna point your thumb, and the same current is going into the paper. So you're gonna point your thumb into the paper, and you're gonna observe how your other fingers are curling. You should get C. Yes or no? All again, that? Wait, what I say? No, it's not C. It's not C.
Again, D.
Go B. I don't know why I say C. Yeah, it'll be D. All right, everybody again, that? D? I'm gonna send a video.
So you come back with these hand rules. You know how I feel about the right hand and the left hand and the hands.
Colleen, I promise it's not that bad. I promise it's not that bad. Use your right hand, right? They're seeing that the current going into the paper. So your thumb is going to be pointing into the paper, and you're going to observe how your other fingers are curling. Right. Right, so I'm going to send a video of what's going on. Yeah, so Colleen, check the video. I don't know if you understand what the hell I'm doing there. Right? I don't know if you understand that. So the answer is D. You're supposed to get D. Right. Which one is the hand gate? Colleen, tell me, which one is the hand gate?
B.
B. Right. 54. Which one is best for electromagnets?
A?
Soft iron.
No, not A. It's soft iron. Soft iron. Okay. In the diagram above, element F has 9 protons. How many protons does element B have? Chemistry people here earlier. 5. All right. Why are you all saying 5? Explain that.
Iron has 5, becomes 4 carbon, and carbon has 6.
So I count backwards. That's why.
It's in a Christian atomic number, so you just count backwards.
Yep, that's exactly it, right? Right, so it'll be 5. Okay, 56. The number of neutrons present in the nucleus of the nuclei 22286Rn is. Right, so to find neutrons, you're going to subtract the atomic number from the mass number, and you should get, well, what are you guys getting? 136, yes, that's correct. 136. So you're going to say 222 minus 86, 136.
The next one is C, gamma rays.
Gamma rays.
Okay, I'm proud of you. I'm proud of you. It sounds like you don't get full marks in that exam. That way it sounds like. You ask me, that's what it sounds like. Right. So I want somebody that don't understand this. Wait, no. Colleen, I'll call you. You're the one I was having trouble with it. So Colleen, help me here, right? So let's observe. Does the mass number change? Yes or no, Colleen? No.
Nah, mass number not changing.
So this had to be 0 here on top because it didn't change. Yes or no? Make sense?
Yeah, that making sense.
And what we had to do with 12 to get 11?
Minus, so like add an electron.
Yeah. So where's the answer?
A.
No, A is not
Maybe A,
correct.
B,
B, right?
B. Sorry.
Because you
My glasses on.
need to get a negative sign. Remember, electron is negative. So negative 1 plus 12 is 11. So you're good, right?
All right, I'm noting, man.
Yeah, that's why I saying you're noting. You're good, you're good. Which of these scientists discovered radium?
Marie Curie.
Marie Curie.
Marie Curie.
Right. And she died doing what she loved.
Curie.
I was not gonna make that joke. All the Guyanese people in class go say Marie. Curry. Oh, wait a. I'll go take a screenshot of this or a picture. Curry. Wait, guys, I'm just ready Guyanese flag. All the Guyanese people in class, they go and shoot me. They go and find me and shoot me.
It's chicken curry.
And we're like, how do you
You know, they just scrape and take over there, so.
Say that again?
I said, they just scrape and thing over there in Guyana, so.
Scrape?
Scrape it.
I don't know what you're trying to say.
Oh gosh, sir. We had to get you up to the times next day.
Up to the times, way. So let me take a little picture of this. I think
Hey, at least
I use it.
in physics, eh?
Where is it?
Right?
Yeah, so take a picture of that. Wait a. At Math Vibes. Yeah, take a picture of that now. I can appreciate my diagram there. My drawing there. If I post it on the status, so they will tag me, right? Yeah.
So you can make that a thumbnail for a video or something.
Yes, I will do that. I will do that for this video.
There's the thumbnail,
I will do
there's the
that for this
thumbnail.
video. That's smart. You take a screenshot of this one time. I'm gonna stick. Yes, if I post it, don't forget to tag me, right? Math Vibes or Reggie Barker. There we go. So question 16. A radioactive isotope has a half-life of 20 days. How many days will it take for a given sample to have its activity reduced to 1/8 of its initial value? So,
60.
if it's 1/8 of its initial value, how much half-life would that have to happen?
3.
3, right? Because a half by a half by a half is 1/8, so that's 3. So what's the answer, guys?
60, sir.
60, because we know that we got 1/8, right? 1/8 of its initial value would have meant it would have had to have 3 half-lives, and if one half-life is 20, it's going to be 60. Write down a little explanation here. So, a half by a half by a half, 3 half-lives, 1 half-life is equal to 20. 20 by 3, 60 days. Yeah. I feel like we do enough questions now to just like spam. Like just
Yeah,
like
man, sir.
automatic.
Yeah, man. Yeah, man.
I feel like semi-automatic now. You know, like any paper they do from now, it should be easy. Because like we do like 6 papers. 6 papers, did we? No, we do 5. Call tonight or one more. It's like our addiction. All they say, like, call
Sir,
tonight.
3 more. I feel it. 3 more, sir.
3 more.
2020, no, sir.
Sir,
Okay.
Fine, we could go
Sir,
until
do an
tomorrow.
old paper.
Old paper.
Yeah.
What?
Thank you.
Like
I'll do the whole
2012?
past people.
Like 2012? Or like 2012?
2008, sir.
What?
Old.
No, they wouldn't. They changed the syllabus for CSEC physics. I passed that. So like you're gonna find questions there that you wouldn't see again. Right. Past papers, paper 1s. Okay, so like could look at probably 2012. Where is
All
it?
right.
Okay, here it is. 2012. All right. So who wants to help me with this paper? Who wants to speed on the paper with me? Any volunteers?
Silence, boy.
Let's go.
Pauline, you want to help me?
I could attempt to.
Oh, let me go. When used in front of a unit, the prefix mega, what does mega mean?
10 to the positive 6.
Right, 10 to the power positive 6.
A.
This is a repeat. What's the answer?
3.1.
3.1.
What's the answer for 3?
kg ms
Kilogram
minus
meters per second.
B. All right. Question 4. The unit of electrical resistance is expressed as, okay, so remember V is equal to IR, and so R would be equal to V over I. And so voltage is
Volts per ampere.
over. So that I can write as VA minus 1. What's my answer?
A.
A is my answer, right?
A.
This question is a repeat. What's the answer?
Length of the pendulum.
Length of the pendulum, right?
C.
When x is equal to 0, the value of y is
S.
S. That's correct. Watch. For those who don't understand, when x is 0, it would be S. Look, when x is 0, no, wait, let me just change this back. Yeah, when x is 0, and so like C is S, yes or no?
Yes, sir.
Okay, question 7. What's the answer?
Acceleration.
Acceleration. Right. 8.
Moment of a force.
Right, moment of a force. Nice. Remember, because turning force is equal to moment by distance. So moment could be, what's saying, boy? F by D. Right? So F is newtons and D is meters. So anytime I see Newton meter, that's turning force, moment of a force. Right. Question 9. What's the answer? You never see this question in my life.
Sir, A.
Never.
CODC.
But let me read the question. So, which of the following expressions is used to calculate the efficiency of a machine? So, load by distance moved by the load. Okay, so load would be, right? So, load, that would be newtons. Okay, so that would be force by distance all over effort by distance moved by effort. So, okay, I wanted to understand something, right? Force by distance, isn't force by distance energy? Did you all know that energy could also be written as force by distance?
Well, yes, it makes sense.
Right. So energy is force by distance. Think about it. When you use a crowbar, any work done and any work you do will be given by F by D, the force by the distance from the pivot. Yeah. So I need you to understand something. Whenever you find any efficiency or something, it's always how much you use versus how much you're actually supposed to use. Let me give an example. So let me just say we have a transformer, right? If the total power of the transformer is 100 watts and only have 90 watts at the output, how would I find the efficiency? And I would just say 90 over 100 by 100. Yes or no? If I have a transformer, right, and I wanted to find the efficiency of it, wouldn't I take 100, which is the original, which is the input current, or I say input current, which is the input power, and I would put the actual power getting the secondary on top? Yes or no?
Yes, sir.
Right. So it's the same concept over here with load and effort. So effort is, so say we have load and effort. So all effort is, effort come like the original and load come like we're actually using. So it's like a similar example here, where 90 is how much power you actually get. and 100 is how much you use. So load is what basically the machine could pull a load or something, and so that's what it's capable of. But effort is the amount of energy you're supplying to the machine. I don't understand what I'm saying. So if I want to find the efficiency of the machine, I would figure out how much of the energy is being used, and that will be on the load, and I would divide that by the total amount of energy I'm putting in. And that's the effort. And so that's how you find efficiency. So I'll make a little note about it here. Energy used energy inputted. So the answer for this is B. So if I see it tomorrow, you know what the answer is. It's load over effort.
So you just say tomorrow?
Tomorrow.
Oh
Day
my.
after. Yeah.
Day after tomorrow. I saw some of these marathons being the night before. Right? So the answer is B. It's always, so like, guys, load would be the energy the machine would have used, and is actually the useful energy all over the energy that put in. So that's the effort. So that's B. Question 10. The point X on the graph shows when the ball is what?
A.
Yeah.
E.
Which
That's
highest point
correct.
above the
Because when the ball reaches the highest point, anybody that didn't add maths here, right? Until they know that the top of a graph is the stationary point. Why do they think this called a stationary point? That's because at that instant, if you throw a ball, the ball will be stationary here for a brief moment, and then it would begin to fall back. Yeah, so in case you didn't know, now you know. So at the stationary point, the ball has a velocity of 0. And so anytime you see a velocity of 0, it's the highest point we're talking about there. Question 11, the gradient of the line PQ represents what? What does the gradient PQ represent? What is velocity over time?
acceleration.
Acceleration. So that's acceleration, right? Question 12. A falling raindrop reaches a constant speed when?
Oh, net force is acting on it.
Right. And think about it like this. If I apply a force to something, wouldn't that cause the object to accelerate? Yes or no?
Yes, sir.
And so if no net force is acting on something, it would not accelerate. And if it's not accelerating, it's moving at a constant speed. So I'll probably understand the explanation there, right? Question 13. If an object is moving along a surface with a constant acceleration, the net force acting on the object is?
Constant.
Constant, right? Because it's constant acceleration. Constant acceleration. Remember, acceleration is equal to force all over mass. And so if I keep the force constant, the acceleration will be constant. Question 14 was the answer. Did I repeat?
C.
Yeah.
Question 15. The rate of which of the following will determine the power of a machine?
Sir, 1 and 2.
Yeah, 1 and 2.
1 and 2.
1 and 2. Changing temperature has nothing to do with the power of a machine, right? So doing work and converting energy, that has to do with the power of a machine. Some of you are probably wondering why. Anybody wondering why? Can you give a quick explanation? Remember, power is equal to work done over time, right? And we know that work done is energy. So that's why I said doing work and converting energy. 15C. 16. What's the answer?
Sir, 1 to 3.
Is D?
D. I would say D is the answer. I would say D. Guys, what does a pair of tweezers have to do with moments? What is a pair of tweezers have nothing to do with moments. A claw hammer, yes, because the further you hold a claw hammer from at the base, when you plunge something, it'll generate a greater force. A crowbar, you would hook something and you would exert a force by the end, and that would create a very strong turning force. A pair of wire cutters uses moments to make it easier. Because guys, humans would not be able to cut wires, so you need some physics involved. So the only one that's wrong there is a pair of tweezers. Cool. Question 17. The diagram above shows a dam. The pressure on the dam, that's a repeat, right? The answer is depth of water. Right? This is a repeat as well. It will be less than the weight of the stone because of the buoyant force that's acting upwards. A bubble of gas rises to the surface is a repeat. What's the answer?
The upthrust is greater than the rate of the bubble.
Right. That's what would cause it to rise. Because weight would be acting downwards, and if the upthrust is greater, it would result in a net force acting upwards. 20. What's the answer?
D.
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 Right? 21. What's the answer? And which of the following is conduction the main method of energy transfer? Does I repeat? What's the answer?
It would be conventional.
It would be D, right? D, because if you're cooking food on a pot, think of frying an egg, or think of frying plantain. All those are examples of conduction. Even if you're boiling something and the water gets hot through conduction, because it conducts the heat from the metal pots. So the answer is D.
How come it's not C?
Okay, let me explain something, right? When you cook food on a pot, the main form of transfer is conduction because you're placing the pot directly. Okay, well, in this case, it's an electric stove, right? I don't think they're talking about an induction heater. Any electric stove. So you understand that you have the heat being supplied to the bottom of the pot, and you place the food directly in the pot. And so the food will be in contact with the bottom of the pot. Yes or no? Make sense? And so in D, what is the main heat transfer for D? Enters primarily conduction.
Yes, sir.
So conduction has to do with physical contact, right? If you're cooking food in a barbecue, the main things there are really radiation and convection currents. Why? Because when you place barbecue, it places on a grill, and beneath the grill, you have hot coals. And the hot coals would radiate heat upwards. And that heat would radiate upwards, and it would then sink back to the bottom, and that would create convection. So you understand why I say in D? C is more an example of radiation and convection.
All right, sir. Thank you.
Right. 22. Which of the following are characteristic features of a clinical thermometer? What's the answer?
B.
A? No, I wouldn't say A.
B. Said B.
Sir, B.
B is the answer.
Boy.
Well, let's see another answer. Let's see like A for, I was going to say a bad word. A for acrobat or something. B for bat, C for cup, something like that, right? So a clinical thermometer has a very limited range of temperatures, and it has a narrow constriction in the tube just above the bulb. Why? Because when you take readings in the clinic, the nurse will probably walk away, and when she comes back, she still has to take a reading. So we don't want the mercury to sink back to the bulb. So that's why we have a narrow constriction. 23. Which of the following are reasons why a hot liquid placed in a double wall is a repeat? What's the answer?
1 and 2.
1 and 2, right? Cool. 24. What's the answer? This is a repeat.
Dog.
Dog, yes. Anytime you see specific, look out for mass in the definition. 25. An electric kettle full of water is plugged into an electric mains. The process by which heat travels through the water is?
C.
Convection.
Convection.
Right.
C as in convection.
26. What's the answer?
D as in dog.
Right. Substance has to change state. So that's latent heat. By light waves, the answer is all B. 28. Destructive interference. So for destructive interference to happen, the waves need to be out of phase by half the wavelength. Yeah. So if you didn't know that, now you know. Right? Keep that in mind. I feel like this might come tomorrow. So total destructive interference has happened when the two waves are out of phase by half a wavelength. Keep that in mind. 29. What's the answer? Does I repeat?
B.
B? Let me take
No, sir. C, C, C,
easy
C,
answer, right?
book
Let me take your
T.
time. V is
So
equal
it's
to F
D.
is D. Okay, watch. V is equal to F lambda. So if I make F the subject of the formula, I will divide both sides by lambda. So F is equal to V over lambda. So that's C. How you getting D? If I make lambda the subject of this formula, I will divide both sides by F. And so lambda will be equal to V over F. You understand why D is wrong? That's supposed to be V over F. Yeah or no?
Okay, sir. I understand.
Yeah. 30 refers to the following diagram showing a wave front about to reach a reflecting surface XY. Which of the following would represent the wave front after reflection? So it's being reflected. What's the answer?
E.
Right? A, that's correct. Because it's being reflected. 31. Which of the following statements about sound is not correct? What's the answer, guys?
The transverse waves, not a transverse wave.
Yeah, sound is a longitudinal wave. Right. 32. What's the answer? So for those of you that have a hard time remembering this, I'm going to teach you a little acronym. Right? So rich men in Vegas use expensive gadgets. So after this, you should remember it, right? So what does rich stand for? What do you think?
Radio is
right? Radio, micro, infra, visible, ultraviolet,
X-rays.
X-rays, gamma. Oh, so let me show that a common sense approach to this, right? So hence we know that wavelength and frequency inversely related. So they're inversely proportional. Yes or no? Did you know that?
Yes, sir.
Okay.
No.
Well, now you know, right? So watch. Frequency and wavelength are inversely proportional. So basically what that means is if one goes up, the other one goes down. So guys, which one has the strongest penetrating power here? Which one can pass through anything?
X-ray.
No, gamma. Gamma.
Oh, I thought you were referring to the question.
Oh, I just showing you something here so I can remember it. But yeah, you're correct. X-ray, right? In terms of the question. If something could penetrate through anything, wouldn't it have a very small wavelength? Yes or no?
Yes, sir.
So it could pass through anything, right? So gamma rays have the smallest wavelengths. And if they have the smallest wavelengths, that would mean they have the what frequency?
The largest?
Yes. So I would say the highest frequency. And well, just like that, you can figure out radio waves. Think of it like this. Radio waves is how to travel at great distance. So they have a very long wavelength. But the frequency is radio waves have the what frequency? The lowest frequency. So just remember one, right? And just remember that frequency and wavelengths are opposites. So just remember that gamma could pass through anything, so it has the smallest wavelength because it's the smallest. And if it's the smallest, the frequency is the highest, and you can figure out the rest from there. So my answer is D. My answer is D. So if I want to write it in order of increasing frequency starting with the lowest, you should know that radio waves have the lowest frequency and it increases down the line. Trust everybody okay with that. Which of the following statements provide a reason why the diffraction of light is not usually observed? Okay, so for diffraction to happen, the slit must be very close to the wavelength or smaller than the wavelength. So what do you think is the answer?
E.
A is the answer, right? We typically don't see diffraction because the size of the slit for diffraction to happen is very, very small. So the wavelength is too small. 34. On which of the following would the position of an image formed by a plane mirror depend?
B.
Right? B. This I repeat. 35. What's the answer, guys? Just by looking at it, we know the answer.
C, sir.
C.
Sir, C.
Remember what I showed you. If something entering a medium and leaving, the initial incident ray has to be parallel to the resulting refracted ray. Remember that? Okay, 36. What's the answer for 36?
The diverging lens only.
Yes, a divergent lens only, because we understand that a plane mirror would produce something of the exact same size, right? So that can be it, because diminish means smaller. And a convergent lens, and we know that a convergent lens would produce a real image. Yeah, so that's wrong. So the only one here is divergent lens, so that's 2. So I hope they understand that. What's the answer for this one? So repeat.
A.
A, right? In which of the following diagrams are the magnetic field lines plotted correctly?
Sir, all three of them.
All 3 of them, right? Yeah. Because in this one is going from north to south. Say that again?
If you could explain the one in the middle.
Okay, whenever you have, okay, opposites attract and like elements repel. So can you clearly see that the 2 magnetic field lines want nothing to do with each other? They want nothing to do with each other. Can you see that they are repelling?
Yes, sir.
So if it was south and south, it would be the same thing, right? If it's the same thing, it's going to repel. Over here, it's north to south, so we're going north to south. Yeah, this makes sense. So all 3 make sense. Which of the following is not one of the ways in which the strength of the magnetic field near a solenoid carrying a current can be increased?
Sir, increasing the resistance.
Yeah. Why would you want to increase the resistance of the coil? If you increase the resistance of the coil, you're going to draw less current. And if you're drawing less current, you're going to produce a weaker EMF, a weaker induced current. You understand what I'm saying, right? Because if the coil is using less current, then the power is going to be less. Hopefully you understand what I'm saying. The electrical people don't understand. All right, question 4. Which of the following relationship between the electrical quantities is correct? The only correct one here is
C.
C. Yeah. The kind of changes up here, we just typically see Q is equal to IT. Right? Just be aware of this. Right? So Q charge is equal to E over V. And where does that come from? That comes from the formula V is equal to EQ. And so if I make Q the subject of the formula, I'll divide both sides by E. Wait, I'm making a mistake. Is E is equal to VQ, right? And so if I make Q the subject of the formula, yeah, that would be E over V. Yeah, that's the formula. That's where it comes from. E is equal to VQ. Energy is equal to voltage by the charge. All right. So question 41. So question 41 is a question that confuses real people. So guys, what do you think the answer is? What do you think the correct answer is?
Says B.
So you think it's B, right? Let me run through the options.
So let me hold on. So wait a second.
The question first.
So in which of the circuits below would the meters give readings which would enable us to then to determine the resistance of the filament lamp? So A is clearly wrong. A is clearly wrong. Does anybody know why A is clearly wrong?
Because you have the volts passing directly through the circuit, which is wrong.
This is technically not wrong, but this will be measuring the potential difference across the battery, which would never change. That's what it's doing. They're measuring the potential difference across the battery.
So when I said B is correct?
B is correct? No, B is wrong. B is wrong.
No, it's hard to be C. I just realized it is C.
So you're saying C. Okay, why are you saying C?
Because when I watch the ammeter now, I see which side have the positive and negatively charged. So if you follow where the battery is, the negatively charged go wrong, so it must come back to that negatively charged, and then the positive must go to that positive there.
Okay, I hear what you're saying, but it's still wrong.
So I feel it's D.
It is D. The reason why C is wrong is because, guys, think of it like this. We have a rheostat in the circuit. A rheostat changes the total resistance of the circuit. So, guys, where would it make sense to put the rheostat? Before the ammeter or after the ammeter?
After the ammeter.
Right, after the ammeter, so I could get a different reading for the current. Remember, if I want to get resistance, I would need to get different values for current and resistance. What's saying current and resistance? Current and voltage, right? Do you understand what I'm saying? Hagan,
yes, sir.
Explain that here, right? Hagan, look at where this ammeter is. Will the reading ever change for the ammeter? Yes or no?
No.
No, it will always read a specific value. And that's because it's right by the battery. If I want to get different readings, it has to be over here. Because
right, okay, I understand what you're saying.
If I want to plot a, so let me explain this. Right? You want to find for resistance. We want to find for resistance. Remember, V is equal to IR. So if I want to find for resistance, I'll plot a graph of V versus I. Right, so V is equal to RI, Y is equal to MX. Right, I would plot a graph. But here, and to plot a graph, I would need different points. So I would need to get different values for current and voltage.
Yes, you will.
Right, so by placing the rheostat here and placing the ammeter after, and if I change the resistance of the circuit, wouldn't the current and the voltage change?
Yes.
Yeah, and in doing that, I would be able to get points to plot a graph.
Right, that are proportional to each other.
Yeah.
Yes, sir.
Good,
So,
okay.
okay with D being the answer.
So is it a giveaway that the voltage has the negative sign first, and then the positive sign? The voltmeter in C.
It's kind of, wait, in C? Okay, yeah. Watch. It's hooked up in the wrong position. So this would give you a reading that would be the opposite polarity. Yeah. I got to point that out. So Hagan, look what's going on, right, Hagan?
I see. When you have the negative side,
I would need to connect this to the positive and this to the negative. So if the reading was 5 volts over here, you'd get negative 5 volts over here because you switch the polarity of the voltmeter. So the answer is D. Be very careful with this question. Be very careful. Right. Item 42 refers to the following diagram, which shows a cell E, a diode P, and a resistor R connected in series. The current through R is best illustrated by which of the following graphs. So, Hagan, let me run through this question, right? So, do you know what a diode does?
What's a diode?
Yeah, you know what diodes do? So, a diode blocks the flow of current if the current opposes the direction of the diode. So, you can think of a diode as an arrow, right? So, right now the diode is pointing in which direction? Left or right?
Left.
Left. So, watch this. If my current is incoming like this, do you think it will be able to pass the diode?
No.
No. You can think of this over here as like a wall. But in this circuit, we have negative here and positive here, so the current is going to flow in this direction. Is it in the direction of the diode?
Yes.
So the current is going to flow. And let me explain something, right, Hagan? What is this? This is what?
That's a battery.
A battery is an example of an alternating current or a direct current.
Alternating.
What?
No, it's direct.
Direct. So will the direction of the current ever change?
No.
No. So then the circuit will always be flowing in this direction and I will always have a current.
Right.
So the graph that illustrates this is C. Is C. Why is D wrong? Could you tell me why D is wrong?
Because they cannot be equal. When you have a D, D is like they draw everything on the same line. So it can't be equal in the sense that it must, how to put it? I know what to say, but it's how to say it.
Okay, Hagan. So in the circuit, we have a battery, right? Wouldn't the battery supply a current?
Yeah.
Yeah, so would the current be zero? Because this right now we're saying that the current is zero. Would the current be
No,
zero?
the current can't be zero.
No, the current can't be zero because I have a battery and the battery and the diode is in the correct direction, so current will be flowing. So my current has to have some reading. And so that's why this is correct. Understand?
Yes.
Okay. 43. Total internal reflection in the medium occurs when the angle of incidence is, tell me.
Equals 90 degrees.
No. When it's greater than the critical
It's
angle.
greater than the critical angle.
Hey, go on, you gotta be careful, you know. Yeah.
I'm feeling sleepy, that's why.
You know what I think you're gonna need to do Friday? I think really had to sit down and read over them questions about 3-4 times before
I
you know your
find so
answer.
too. Hey, go on. If you go over all the past papers we do today, you should be able to get like 55 out of 60 or something. For sure.
How much out of 60?
Like 55 out of 60. Worst case scenario. I think we cover 90% of the questions that are going to come to the exam.
Everybody don't worry. By Friday, everything will be good. I'll organize myself.
Hey,
So
gonna
you
see
think
my-
they would pull questions from these years?
They could, you know, they could. CXE kind of wicked, but since the syllabus changed, like in 2015, I think it was 2015.
Yeah, I think so.
I don't think they would pull questions from this, but it's a possibility. It's a possibility.
I think so far, they're doing from 2015 up.
Okay, well, we did do a good bit of papers that are beyond 2015, so we're just doing this like a worst case scenario, you know. It's a good thing to be over prepared. So where's the answer for 44, Javon? While you're at it, where's the answer for 44?
Or C.
C is the answer, right? Magnetic induction occurs when? Is a repeat. What's the answer?
B.
B. Which of the following characteristics concerning ammeters is correct? Ammeter must have a what resistance?
Low
Low.
resistance.
And it must be in series. So the answer is A. Is a repeat. What's the answer?
Wire gets hot, wire melts, current is cut off.
A, right? Rectification diode.
B.
49. So we have a current into the paper. There's a repeat. What's the answer?
D.
Colleen, you did ever get through with the question?
Which question, sir?
This question. Where you do right angle proof?
I give up on that and I was like, you know what? I would just envision, if it come Friday, I'll envision the video of you doing it and get the answer because I take my hand back to front.
Okay.
But you see, like I know the answer is D now, so I wouldn't really have to do it because I know the answer.
Here, what? They could
It's
switch it
smarter,
up. They could
not
switch
harder.
it up. They could switch it up, right? They could switch it up. So just remember it like this. If the current is going into the paper, it will go in a anti-clockwise direction. Wait, no. This is clockwise. This is clockwise. Yeah, that's clockwise. So if the current is going into the paper, it's clockwise. So in is clockwise. If it's coming out, where it go be?
Anti-clockwise?
Right. So if the current is coming in, if it's going into the paper, it'll be given by a X, right? If it's coming out, it will be given by a dot. Understand? Yes or no?
No, where the X and the dot come on.
Okay, so X means that the current is going into the paper. So in a dot would mean that the current is coming out. Understand?
Oh, all right, sir. Thank you.
Yeah. So you have it here. And so if it's going in, then the magnetic field is going to be in a clockwise direction. If it's coming out, it's going to be in an anti-clockwise direction. Just remember that. Okay. In the part labeled P must be made of. What do you all think? Tell me. A, right? Has to be made of iron. Right, and this is an example of a relay, right, guys? A relay. Why does it have to be made out of iron, guys?
Because iron is magnetic, or it responds to magnetism.
Exactly, exactly. Because when I apply, think of it like this, right? If I apply a current in the circuit, it's going to generate a magnetic field, and so this over here is going to get attracted. So it's going to get attracted to this, and this is going to move up, and this is going to push. So look at what's going to happen, right? Until you could see that if this experiences an upward force, it would cause these contacts to meet. Think how you could see it. So if you have power in the circuit, you generate a magnetic field here, and that would cause P to be attracted to it, and that would cause it to move up, and that would push this armature up to cause these contacts to link, to make contact. Right. Okay. So when the switch X is closed, the wires move. So guys, what had to use here? What to use here? Fleming's left hand rule or Fleming's right hand rule?
So your left hand?
Yeah, your left hand rule, right? Colleen, you want to put on your camera and do this with me?
Yes, Colleen.
Colleen, let me know.
I mean, I was kind of lost for a second, but yeah, sure, no problem.
Okay.
Are we any bonnet again, though, eh?
Say that again? That is okay.
Are we any bonnet again tonight?
The first thing I want you to show me, where's your left hand and where's your right hand?
Okay. This is left, this is right.
Okay, you're sure, right? You're sure?
Yeah, I think so. Yeah. Sure.
Okay, so first thing we need to do is we need to draw the magnetic field. So how if we have a north and a south, how would the magnetic fields be? It's going from what to what? Now north to south or south to north? How do magnetic field lines go? North to south or south to north?
North to south.
North to south, right? So I'm going to draw that in.
Right.
Okay, and look at the battery. The battery is negative over here and it's positive. So we're going to draw the conventional flow of current. How does current flow?
Very positive to the negative.
Right, so if I close the switch, it's going to flow from positive to negative. And so the current is, it come like it coming out of the paper, right? You can see that? It come like it coming out.
Right.
Like, and it look like it pointing towards you.
Yeah, it's looking like it. Mm-hmm.
Right. So let me apply the rule here. So your left hand, right? Your left hand, L. So this represents trust. So this represents trust, magnetic field, and current. I have a lot of trust in you. Right?
Should not have as much, but okay.
So trust, magnetic field, and current. So the first thing we're going to do, right? We're going to align our hands in the second finger in the direction of the magnetic field. So north to south. So the north to south is in this direction. So your second finger needs to be in that direction, like this. You understand?
Yeah.
All right. And your second finger corresponds to what? I mean, what's in your second? Your last finger, the third one. Trust, magnetic field, and current. Trust, magnetic field, and current. So this is current, right?
It's current.
Right. So are you properly situated? What do I mean by that? In the diagram, it looks like the current is coming out.
Right.
Yeah.
And so your middle finger and is pointing towards you.
Right.
So we're good, right? We're good. And the magnetic field is aligned and the current is in the correct direction.
Yeah.
So the thrust would be upwards, right? You see that? Upwards.
Yeah.
Right, and that's it. So the wire would experience a force upwards. That's it.
That's it?
Yeah, that's it.
That's crazy.
It was good or bad?
Okay.
Okay, that was good.
Right.
So the answer is going to be upwards. All right, 52. It is possible to induce a voltage on a wire coil by the use of a. The answer is D, a change in magnetic field. Faraday's law, right? Faraday's law says that the induced EMF is directly proportional to the rate of change of magnetic flux, which is a change in magnetic field. So 52D. Which of the following statements about alternating current is true?
It can be rectified by a semiconductor diode.
Correct. 54. This I repeat. Where's the answer? If I do 2 full rotations for an AC
Nice.
generator.
C is the answer, so.
C.
Right. No practical transformer is 100% efficient. Which of the following causes energy loss? Let me hear.
D.
So I hear in D. All right. So the resistance of coils of wire, right? Some power is going to be dissipated there. Magnetization and demagnetization of the core. I would say that as well. Eddy currents in the core. So all these would contribute to energy losses. I was talking to this guy from Jamaica, Haj. I think Haji, you there? Okay, I don't think so. So basically, the second option has to do with hysteresis loss. When you magnetize something and you demagnetize it, there's a loss. We call it hysteresis loss. It was 1, 2, and 3. Yeah. So the answer is 55D. 56. Radioactivity takes place in an atom as a result of what? Yeah, nuclear instability. Right now, I feel the nuclear unstable. Anybody else feeling nuclear unstable? Anybody feeling the instability? Or you feeling like
Yeah. I want to sleep.
So
well, after this paper, or they'll get sleep, right? Right, so 57. Which of the following statements about radioactive decay is correct? C. Let me just verify that. So it is a random process, and it is due to changes in the nuclei of the atom. Right? Part 1 is wrong, so you're correct. 2 and 3. 58. This I repeat. What's the answer? Isotope. Well, it's not
1 and 3.
I repeat, but
1 and 3.
right, because of isotope, the mass number changes. Mass number changes. So, actually, the answer is 1 and 3, which is D. 59. This one real hard, guys. All you might have to think I'll bit for this one.
Say it's Donald Trump.
So it's Albert
It might be right. It might be right.
See, Albert Einstein.
I think it might be Donald Trump, you know. I feel so. Don't take a picture of this one, eh? Take a picture of this one. Let me erase it fast. Next thing I'll post up on is like, I'll go marry a stupid fella to learn by. Right? And the last one, N0 radioactive nuclei are present in a sample at time t is equal to 0.
So Z.
Wait. Let me read the question. So we're talking about radioactive decay. Yeah, it's D. I see what you're saying that. That was kind of obvious, right? That's basically a repeat.
Yeah.
And this is
Z, sir.
Z?
D.
Yeah, the answer is D. But I don't know how I hear in D. I mean Z. I don't know how I hear in Z. Because I swear I hear Z. Z for zebra. But yeah, the answer is D. Because when we talk about radioactive decay, we're talking about an exponential decay curve. So guys, how we feeling? We do like a good couple New Year's? A good couple.
You feeling something? I'm feeling something.
Nice.
I feeling like I have positive vibes for that exam Friday.
Yes,
that's how I feel.
Well,
honestly, I feel like I should go and sleep for history test today.
Yeah, history test today? Well,
Yeah.
technically tomorrow. It's not 12 o'clock yet.
So are you ready to write that exam now?
Well, hear what? I was sent all
You need to read them questions. That's what you need to do.
Yeah, Hagan, you really had to take your time, you know. You had to take your time. Hagan, you really had to take your time. I kind of worried about you.
I feel you had to stay in the exam room until time up it. Don't feel to rush it down and walk out. And when you're watching Terry Davis correct it, you'll cry. Take it.
Yes. Who's Terry Davis, why?
I will get everything right.
Whatever you name it.
Everything will work out by Friday.
Now, I believe, you see Hagon there? Hagon is Alexander the Great. That is what Hagon is.
Thank you, thank
And
you.
Hagon have it in him. Hagon has the dog in him, right? Hagon has the dog in him.
The dog being Clifford, but okay.
You said
That is
that
always
the dog being Clifford?
Yeah.
Hey, Clifford is a smart dog, you know.
You're talking about Clifford, the big red dog, the kind of triple one.
Yes.
Hey, the Salmon son says you are smart, sir.
You know who's a real smart one? George. Yeah, Curious George. That monkey real smart.
Yeah.
Or
And
like,
I would dog bring up a monkey.
no, Curious George smart. You can't tell me Curious George not smart.
So it have a 33-minute video on YouTube of how Curious George is a master manipulator and how he is secretly control the whole world.
What?
You could check it out.
Somebody link. Drop the link for me. I'll check it out.
I just
Right. So anybody have any questions? Any particular questions or they want me to verify? Anybody? Now is a little chance. Now is a little chance.
Oh, sir, I found out how to derive the V squared over R.
Say that again.
I derived the V squared over R, the question that you said you're going to come back to.
Okay. Tell me what formulas you use.
I'd have to write on the screen because I'm bad at explaining.
Wait, I'm looking for the particular question. That was a whole thing that was it this year? I feel like I can figure out that easily, you know. Give me like a minute. I'll look back at it and I'll figure it out one time.
But sir, what year's past paper we did this session? I know we do 2012. What other years we did?
No, this was 2012 here.
No, I mean what other years we did throughout like the whole time here?
January 2025, June 2024, June 2023, June 2022, June 2021, I think. And then June 2012, I think.
Oh, right.
Yeah, that's what we do. That's what we do. Rachel, which year was that again? That question? Oh, look, I find it.
I don't get this one.
Give me like 1 minute. I'll figure it out. This is not hard. Like, this is real easy. If I see the proofs are doing UE, or they will be like, damn.
It's really not hard.
It very easy. Okay, so E is equal to BQ. Bottom. Okay. Hagan, you there?
Yeah, there. Yes, sir, there.
All right. So Hagan,
Yes, sir.
you want to sleep after this, or what you gonna do?
I'm gonna review some more stuff
Okay.
and I'm gonna make sure I get everything because I'm not giving up and I'm gonna get everything right on Friday.
So Hagan, you from Trinidad or you from some other country?
Trinidad?
For some reason, I feel like I would have said some other country, you know.
Why?
I don't know, you just I don't know.
You mean how I talk?
You sound like you're from Diego Martin.
Nah, not from Diego Martin.
But you sound like you're from Diego Martin.
Yes, no, you're going something like he from in deep south.
No, he does not. He does not.
Hagan, where are you from?
Shaft, yeah.
That's close enough to Diego Martin, right? Like that's
Oh,
like
that's not that close to Diego Martin.
that's basically north side.
We could Diego Martin is more west, you know, but Acacia is in.
Wait, Rachel, I figure it out. It's real easy, right? So you're using P is equal to IV, right? And you're using V is equal to IR. And from V is equal to IR, you can make I the subject. And if you make I the subject, that'll be V over R. And I'm going to plug that in. And so I'm going to end up with V squared over R. That's what you do?
Yeah, that's what I did.
Okay, nice. So yeah, that's it. So R over V squared is definitely wrong. So yeah, we're good. Right. We have anybody in class who's still like from another country? Colleen, you from Trinidad?
Yes, sir.
Okay, I just asking that.
Wait, which part of Trinidad?
I'm from South. I'm from Laramie.
Okay, Laramie. All right. Okay. And we have anybody from DB Penal representing? I have some amazing people in DB Penal, you know.
Sir, I me, sir, I me.
Yeah. I guess it's just you and me, right? I guess it's just you and me representing. Right? But here what? That is it for today. Or you might have a hard time reaching me tomorrow because I got on rails just tomorrow. Right? I got on just tomorrow. Yeah.
Excuse me, sir. Did you send the documents already, the solutions?
I want to send the documents now. Malia, are you on the group
Okay.
chat?
No, I'm from Guyana.
No, ask if you're in the group chat. Ask if you're in the group chat. The group chat for the paper ones now.
I'll send the video in the Zoom chat.
Wait, Malia, are you in the paper one marathon group chat?
Yes, I just joined.
Okay, word. So here what guys, I will send everything now. I wouldn't wait. So here guys, thanks for coming. Don't forget to drop a follow on the YouTube channel, spread the word, and hashtag mass vibes. Yeah.
So this whole thing was recorded, right?
Yeah, this whole thing was recorded.
All right, sir.
Like and
Good
subscribe,
night, sir.
like and subscribe,
Yeah,
like
man.
and
Like
subscribe.
and
I see you from Mass
subscribe
Paper
and
1,
comment
sir.
and share.
That's
You
why I
know,
see
you
it.
know you need your help in maths.
Just
If you
So
want to get all ones, like and subscribe, and share to your granny.
don't forget to share to your granny. She had to know about Fleming's
Yeah, join the
rectangle thing.
maths live so I won in maths. If you join the maths live, you'll get on the CSEC merit list. Trust. On
Wait.
everybody's soul except mine, you'll get on the CSEC merit list.
Wait. Colleen. I'll take our recording now. Let me take our recording real quick. Yeah. Run it back there.
If you join the maths paper one live, you would get you'll get on the CSEC merit list. On everybody's soul except mine, you'll get on the CSEC merit list. Trust, bro. Trust.
I never agreed to this, but okay.
That's okay. I have no soul.
you wish upon we soul. Eh?
Nah.
On everybody's soul but mine.
But that wouldn't make sense though. How everybody could be on the merit list. It don't work like that. But
No, sir.
everybody.
All right. So how I like this one? I like this one. Everybody, watch YouTube video, like and subscribe, share to your granny, and you're sure to get at least a one.
Let me take the video, right? I'll take any video. Yeah. I'll tell you when to give it a go. Give it a go now.
All right, guys, make sure you like and subscribe. Make sure and comment. Watch the full video completely, and you're sure to get one.
Wait, I now realize the audio wasn't working. Do that one more time, dude. Do that one more time.
Hello, everyone. Make sure you like and subscribe. Watch the whole video fully, and you're sure to get one in CSEC.
Colleen, coming now. Hot, fast.
Oh, if you watch and tune into the maths paper one, on everybody's soul but mine, you'll rejoin the CSEC merit list. For sure. Distinctions all around.
Right.
Cool,
Yeah.
come hot like doubles.
Extra hot. So, guys.
Everything slide pepper.
No. What, bro? Slight? No.
Oh, that's like, oh,
Heavy pepper fit.
no. See, lost it. Sir, you know to try let's go on rail with sir.
What's that?
And doubles with heavy pepper and supply, Jenny. I just tried.
Hey, I don't want to pull a Gabi here. Hey.
Cooley Murray would be very disappointed.
You mean Corey Marie?
Boom, clock. Well, anyways, guys, I got on head to bed. I had to go up north.
Yeah,
Later, everybody.
memorize some paper once for history. Later, guys.
Later.